All right. See if I get the transcoding options today. Oh, yes. 160p on my monitor. All right. Welcome, friends. This is stream number 419. I'm going to get back into the streaming. I haven't been able to stream this week, Monday through Wednesday, mostly because my schedule has been really chaotic, and also I've been working on some tough learning, really. Part of the Rust asynchronous ecosystem was just giving me a hard time in the brain trying to comprehend it. So I think I'm over the hump, and I can go over some of that work I did, and I will continue work on my libraries that sort of form the basis of the stuff I want to do, like my game. Being web-based, I need web server client stuff, and up until now, I've written my own stuff in C++ for that, and thinking about porting it to Rust. Well, not just thinking about it, actually doing it. I know there are crates out there for Rust to do HTTP client server stuff, but I like to do my own thing, and there are some problems that I have with some elements of those crates. Most notably the URI stuff in, I think it was the HTTP crate. It just didn't support the full spec, and I didn't like that. Hey there, 715209. You are first today, and hey there, Resu Baka. And TS Joss is number 3. Hello. Hype. Yeah, so here's my Rust HTTP client, fetch. Fetching a resource given a request. So the work I've been doing in the background off stream has mostly been the management of connections to the server. And that's down here, right? This connect. And it's this reusing a connection if one is already made that was the toughest thing for me to figure out. You were waiting for this? Okay. Hopefully I didn't already do the part that you were waiting for. So, making a connection to a web server is not that difficult. The difficult part is to hold on to a connection you've already used and then reuse it later, or detect that the connection's broken. Hey there, Sarian. So I'll just go over quickly the way you connect to a server, since most of it's built into Rust, a standard library, right? So we have to form this address, which is the host name : port number. And the host name could be a IP address, or it could be DNS name. Either way works. So we use TCP stream, which is built into Rust standard library. It's you can either use the synchronous or the asynchronous standard library. I'm using the asynchronous one, so that's why we have these awaits here. But it's essentially the same semantics as the normal standard Rust library, except for that the results are asynchronous. So everything returns a future that you have to wait on, which is nice when you're going to be doing multiple things at once, like we're doing here. So connect return, it takes the address string or address socket address value that you give it. It's very flexible, actually, and will resolve the host name to an IP address and then make a TCP connection to it. So there are lots of ways this can fail. You might not be able to connect because there's no such host, or they're ignoring your attempt to make a connection, or it timed out, right? Lots of different possible errors, so we have to handle them. But yeah, given that we can connect, I have this in here for now just to play around, that we can ask the connection for its peer address, and we can print out the actual IP address, which is kind of interesting to see. And here's how we will wrap it with transport layer security. So I'm using the TLS connector from Async TLS, and you just make one, and you say, hey, connect, here's the host name, and here's the raw TCP connection. It's also asynchronous, so we got to wait for that. It can fail because of the connect does the handshake, the TLS handshake. But if it succeeds, then it becomes like a wrapper for the underlying connection. So I just box that, and that becomes the connection. So if we're not using TLS, we just box the underlying raw connection. So after this point, we don't have to remember whether or not we use TLS. We're just using a what do I call it? it's in connection results. It's a boxed connection, which is a trait that I had to declare with this little trick here, because our connections have to support a lot of different traits, and we're sending them across threads, so we have to have them send, and they have to be static, they have to be unpinned if we're using asynchronous features, and then the traditional read and write that you have for a connection. Hey there, Pyro Frosty. Why do you box it? I box it so that we can abstract away whether it's in using transport layer security or not. You can't pass around a trait object without boxing it, as far as I know. Let me pass around some haze to Pyro and to Nui. How are you doing? So yeah, if you guys know a way to do this without the box, let me know. If I just do this, we have a problem with the compiler at some point. Yeah, there it is. It will say the size for values of type dyne connection plus static cannot be known at compile time. Its size is not implemented. So maybe if I implemented sized myself, I don't know how to do that. I found the most convenient way was to just box it. Need to be behind a reference. Could be a box or a normal reference. Box works for me. I pass around this box anyway. There doesn't seem to be that big of an issue about it. So that was connect, right? So connect returns a connection, and then we go use it. Where is it that we use it? I'm lost again. Where was it that I used the connection? Oh, here it was. Open a connection. It might be reused, right? So once you get a connection, this transact does the dirty work. This is all in my GitHub, by the way. Let me do a link. https github.com imway354 http client.git. Hey there, Dr. Maruku. Did you consider having an enum instead of boxing? Nope. But that's certainly a valid point. Get it? Valid point? Violence. Yeah, boxing that stuff. Hey there, Romania. Hey, how are you doing? Right, so a transaction for HTTP is composed of first sending the request to the server, and I'm leveraging this, where is it? Oh, before we do the transaction, because we might have to send it multiple times, I do, I think I skipped that part. Yeah, I generated the raw request byte stream from the request here, leveraging this other library I made, which forms the request line and then adds the headers and the body. Yeah, pretty straightforward, right? So we write all of that to the server, and then we have to sit in a loop waiting for the response, because we might not get all the response at once. So make a buffer, then read from the connection into that buffer, and then drop any unused part of the buffer, and then try to parse what we have in the buffer. And this is also incremental that I did before, where we have to loop, and we might be in the a body that's chunked or fixed. We might be parsing headers or status line. This is a big state machine, right? And once we're done, we get this parse status complete, and we have a response back. It's easy as that. Hey, the Epic Unknown. How are you doing? Oh, well, thank you for the follow. I appreciate that. Okay, this is stuff I added really recently, handling content encodings. So this is kind of cool. I made this separate module called coding. So decode botting looks at the content encoding headers and then processes them from right to left. That's what this pop does. It's popping off of the right. And if we see gzip or deflate, we're going to take the body and decode it using either those two algorithms. If it's not something that we recognize, we put the coding back onto the list and stop. And if we have codings left, we reconstruct the content encoding header. Otherwise, we're just going to drop the whole header. And we also have to reset the content length, because of course the length can change if we decode. Like if it'll probably go up gzip and deflate are for compression, right? So it makes the body smaller. So when we decode, it's going to be bigger. So the new body length is going to be larger. And I didn't do, just like in C++, I didn't do the compression myself because it's sort of beyond my skill in mathematics and all that. I just leveraged these decoders from the Flate2 crate. So Flate2 crate gives you the GZ decoder and also gives you the deflate decoder. And they support the buff read interface, which is a standard I/O trait. So you just do a read to end if you have it all in one buffer, or you can just do the read incrementally. And if you succeed, you get the decompressed output. Pretty simple. So that was fun. I added one more thing, like after you decoded the body and you want to get text out of it, since text might be in many different character sets, I added another helper function. Oh, it wasn't in this crate. I added it in my other crate, HTTP. Yeah. It was the one we were just at. So that was decode body, right? So there's also this thing as decode body as text. So given the message headers and the body, we look to see if there's a content type header. If there is, we need to find the parameters, as you'll see in a moment. So we split out the parameters. Then we take also the type and subtype and split them, and then looking at the type. If it's text, we're gonna keep going. If it's not text, it's like it's not text. How can we decode it as text if it's not text? So we return none. Given that it is text, we're going to look at all of the parameters, removing white space, and then taking the parameter and splitting each parameter, splitting it between the name and the value at the equal sign. And then we're filtering out everything that isn't char set. And when we do the char set, we actually it's not filter, it's find. Find map will taking the name and value, try to find something and then map. If we find it, we map it to something else. So we're mapping the name and value to a value if the name is the char set. And then this is the default case. If there is no char set in the content type, we default to this de facto standard from the 1990s, right? The it's a single byte character set, which has it's ASCII plus some extended characters for like European languages and such. Option is the null and rest. The none is the null and rest, essentially, yeah. Option is more like a nullable. And C#, I forget the C# name for it. Is it nullable? It's the type that represents that you may or may not have an object. If you have an object in Rust, it's some, and then the object is inside. If you don't, then it's none, and that's roughly the equivalent of null. Optional, there we go. Optional, more or less, yep. So, given that this is all just to find what character set to use, right? Once we find the character set, I'm leveraging the encoding RS crate to do the decoding for me, because decoding different character sets is a pain in the behind. So might as well let someone else's crate do it for us. So I like this method because rather than figuring out which encoder to use, we're going to just say, hey, we have a label here. It's in the standard web format. So take it and try to figure out if there's a decoder for it. And if we get some decoder for it, then we're going to, this long function name, I have to admire how long it is. We're going to decode without byte order mark handling and without replacement character. So it's very strict, right? The body. So if there's any character set violations, we're going to get none. If everything is good, then we get a decoded text, which is, I think they give it to us in a slice, so I have to map it to a string to return it. But yeah, once we get a string that's valid, verified valid UTF-8 text, that function name practically a novel. Yeah, it's almost like a name that I would make. Decode without bomb handling and without replacement. Okay, so I kind of like, writing this code in Rust is difficult for me, but when I get it done, I kind of like how it looks. I I feel really happy about the prospect of coming back to this months later and being like, oh, I can actually read my own code. I know what this is doing. This is splitting at the semicolon, trimming away white space, splitting at the equal sign, and then filtering out anything that doesn't match that. And then with the name and value, we're looking for character set, and we're mapping to the value if we find it. It's like easy to read. All right. Anyway, that was pretty much it for the HTTP client side. So the massive work I did on over the weekend and Monday and Tuesday, that it was just so hard to do that I just didn't want the added stress of streaming at the same time. And also my schedule was all a mess. Was what do we do when we're done with this connection? And if we want to reuse it later for the next request, if there is one, this concept of storing the connection for future use. So I really struggled with this for a while. I'll go over my solution. I liked the way my solution worked so much that I even made a crate out of it. It's called the pantry. So there's this type called pantry, and what it does is it stores objects which might perish. They're perishables, kind of like the pantry that you store food in, right? Only this pantry has like a robot inside that detects rot and automatically disposes of anything that has gotten to rot, to decayed or perished or whatever. There's the concept that a value might need to be dropped because it's no longer usable. So for a connection, what that means is the server has dropped their end of the connection. We can't use a connection because the server disconnected us, right? So as long as we define a concept of how to detect if a value has decayed or perished, the pantry will automatically drop things that do. Otherwise, it'll store them for us and give us a way to fetch them back. So store in the pantry, kind of like a hash map. You have to have a key and a value. It takes both and holds on to them. And then later when we want to connect again, if we possibly have a connection to the same host, we're going to try to reuse it because it's a lot more efficient to use a connection you already have to a server rather than trying to establish a new connection. Recycle connection has to be asynchronous because fetching back from the pantry involves retrieving an option that is in some other future. In fact, it's not only just in a future, it's in a future that a separate worker thread is trying to complete, which we'll get into. So anyway, this requires some communication between threads, so we're going to have to wait for it to happen. So I've encapsulated the storing and the fetching in this pantry crate because it's really complicated. But from the perspective of the user of the pantry, it's pretty simple. You just do store and you fetch, and it's possible that you don't get you don't get back out what you put in. So that's why we have an option here. Hey there, VV1ZM8. How are you doing? Max Verbossi, yeah. All right, so let's get into how this pantry works. I think we'll start with store because that's the easiest. And we have a worker thread that manages the stored objects. So we need to send the worker thread the key and the value to store. So I opted for using a MPSC, a multi-producer single consumer channel. And the sender end is called an unbounded sender, and because we want to allocate space for any messages that the worker thread isn't able to get to. So a bounded sender you would not be able to send to it if it was full. Unbounded is going to allocate memory as needed, right? So we're possibly allocating some memory in a queue to store this key and the value to give it to the worker thread. And here I am using an enum. There are 3 different things the worker thread can do. It can stop, it can take a value and store it in the pantry, or you can give you back a value from the pantry. And I'll get into each one. If it's dead, you get a none. That's right. If it's gone, then it's gone. The pantry will drop it if it dies. So we'll go over that. So first, we'll go over the placing it. Did I get my names backwards? Yeah, take. So it's from the perspective of the user. The user says, hey, pantry, take this key and value. But if we want something back out, it's like, hey, pantry, give us the value with this key. here's our one-shot channel to give, kind of like a callback. And this is the part that one of the parts that I really struggle at when we're communicating with with another thread through one of these multi-producer single consumer. It's one way inherently, right? You can send stuff, but you can't receive anything back. So I did a bunch of Google searching and happened upon some really helpful posts where they're talking about if you need something back, what you can do is you can send something that contains a return channel. So that's what I'm doing here. This sender is a one-shot to receive back, again, an optional value, because we might not get something back. If the value's been dropped, we're going to get a none sent back to us. See how that works? Take doesn't need that because it's one way. Give is bidirectional. We have to tell the pantry what the key is, but then the pantry has to send back either the value or an indication that there's nothing to give us back. So you'll see that heavily in this crate. There's a lot of one shots to send things back and forth. I don't use a one shot for the worker thread because it is processing it like a stream. So it's basically serializing or making sequential all of these actions, giving and taking of values, right? Rather than having them disordered. I guess I'm not explaining that very well, but anyway, storing something is just take, and what take does, take. Let's find where it uses that. Take park value. I need to find, here it is. So this is part of the worker thread that's handling that stream of messages coming in through that unbounded, that MPSC, right? The worker thread has the receiver end of it. So we're driving to completion that stream. We're going to continue taking from it until we get a stop, right? This is a magical little thing I worked out a month ago, probably with your help, to like figure out if we have an infinitely long, potentially an unending a channel of messages to the worker thread. How do we know when we should stop, right? So the take while is really nice, where it will early complete the stream if the predicate you give it is true. So in this case, it's if we see the stop message, it's just, okay, stop now. Hey there, Clayman, how are you doing? Could you have used an MPMC? If I had more than one worker thread, but I try to keep it simple, so this crate only has one thread that does everything. So yeah, one thread that does everything, we're going to have just a single consumer. But yeah, if you had like a pool of threads that were to like distribute these messages, you'd need an MPMC of some kind. Hey there, Pro Table Flipper. What face indeed? Channels, yes. So this channel is receiving messages from the outside of the crate and handling them. Yeah, Pro Table Flipper, exactly. Flip that table. Professionally. All right, so we're going to look at take, right? Take is very easy. We have the key and the value, and we just need to store it. Now the tricky thing is, how do we store it in a way that we can both monitor the value for decay and potentially return it back out on request? The way that I settled on doing this was splitting the value into two things: a one shot that you can use to request it back, and then a future that's used to monitor the value to see if it dies. Yeah, there you go. Flipping those tables like a pro. So this add does most of the work. We have this place that we're actually storing all the values, this parked value pools. And I have to hold on to it through a reference count and a ref cell for two reasons. The ref cell is so that we don't have to make the pools mutable. And that's especially important because we're going to be sharing it, which is implied by the reference count. We're sharing this between two different sets of futures. One set is the one that's putting values in, and the other set is the one that's taking them back out. So this add is putting it in, right? We have to actually create we have to have actually two levels here. The pools itself is a hash map, but it's a hash map of other vectors because it's kind of like a multi-map. And the top level is based off of the key. So this allows me to have multiple values that have the same key, which I need because, for example, if your HTTP client opens 2 simultaneous connections to a server, and then one finishes, and then the other finishes, we have now 2 connections we can reuse that have the same key, and we don't care which one of the 2. So it's this concept of a multi-map in C++ that we're replicating here, which is, in general, the way you do it is you have a hash map of vectors. All right, so hash map of vectors stores our actual values. So the top level one is the hash map. So if we look up the entry for that key, and if it doesn't exist yet, we make a new set of vectors. And in that, we're going to add our value. So like I said before, we're actually adding 2 things. We're adding a channel that we use to request the value back out, and we're adding what I call a monitor, which is a feature that will be watching the value to see if it decays. Thanks for the follow. You guys stop me or make me slow down if you've already lost me. If you want me to explain it and you actually want to follow along through the entire explanation, please slow me down. If you just want to hear my voice, then that's fine too. So couldn't your take parked value take a ref cell instead of ours? It may be. It's not, all those subtle like aspects, I don't quite know for sure. You're probably right. We probably don't need to borrow the reference. We could have just borrowed the ref cell inside the reference, right? See, so that's why, Sarian, I really appreciate you and the other dozen more veteran Rust programmers. You just notice those things that I haven't noticed yet. So let me give you a point. Hey there, JT, and hey there, Red Rampage Crumpet. Let me give you your waves. Trying to stay on top of the waves today. Makes sense so far to you, but you're curious how you know if the connection is dead. We'll get to that. It was very fun and very stressful to figure out, and I still don't know if I have it right. You lost me about 5 seconds in. This is really complicated. I could not stream while I was developing this code, and you see that by the bulk of the comments here. I knew that if I didn't write comments, anyone reading this code might not have a clue what's going on because it's pretty convoluted. And also, if this is just way too convoluted, more than it needs to be, these comments will help me or someone else kind of point that out and point out ways to improve it, right? So if you lose me, that's totally acceptable. I lost myself in this for a couple days. What am I using with Rust? I am trying to make a game based off of web components that are in Rust. So the game is online right now, but it is not in Rust. I'm trying to kind of convert parts of it to Rust because I'm really into it now. So we're building up components for the game right now. It's the web stuff. I'll be doing WebSockets soon, and then I'll be doing sort of the core game stuff later. Anyway, I was looking at this ad, right? So we make a channel that we're going to use later to retrieve the value, and then we make this magical monitor, which is a feature that the worker thread is going to be trying to complete. If it completes, it means that one of 2 things happened. Either 1, the value died, and we have to drop the value, or 2, the value has been requested back out. So let's look at this monitor value. So this is how it works. Like I just said, there are 2 ways we can complete. The value could perish, or we could receive a request for the value back out. The one shot is very simple, right? It is a, where do I see that? This receiver. How come I can't control? There we go. It's just channeling the value, right? What gets kind of complicated is the requestee is a receiver of a sender, and the requester is a sender of a sender, because in order to request something back out, you have to send a one-shot through a one-shot, and then once that one-shot is received, it's used to return the value back out. So if the receiver gives us a sender, so if someone sent us a one-shot, we're going to use it to send the value out. You see how that works? Have you lost me yet? If the line of code has... That's why I have this huge comment here. It explains what we're doing. Actually, this explains... Here I was more interested in explaining why I'm using one of the variants of unwrap. Unwrap, I'm starting to learn, is a code smell in Rust, which means you're too lazy to handle errors. In this case, I have a reason for doing this, which is that it's not really an error. It's just something that it could happen if the requester gave up waiting for the value after sending the request. They send the request, but before they receive the response, they just give up. So it could happen, right? In that case, it's like, okay, we'll just drop it. Sender isn't a word anymore. Yeah, maybe using the word too liberally. You check if it's dead when someone wants it. This is where we check if it's dead. So if it's dead, then this feature will complete, and then the monitor will complete, which makes us drop everything else. So the value gets dropped, the requestee receiver gets dropped, which means if you try to request it, the one shot will bail out as canceled. And that's the key. Perishing the value is like determining if it's perished, it's the user's responsibility. If the future that we ask for here completes, then we drop everything. We drop the value, we drop the receiver, and the monitor gets dropped as well. Indicate had to review your old backend code during your last stream, got confused even with the comments. You asked the question wrong. What are you using with Rust? Oh, you mean like what other libraries I'm using with Rust? If that's the question, that's easy to answer. I can just show you the cargo toml. We're using encoding RS for text character sets, Flate2 for compression, and I'm using my own crates for handling HTTP headers and bodies and URIs. And the built-in, the other crate that actually does the network connections, it is using async standard for the TCP stream, async TLS for transport layer security. We're using async trait to have our perishable work as an asynchronous function. Using futures, using my own pantry crate we're going over now. And the HTTP common stuff between client and server, I'm calling RimaWeb, but it's my HTTP library. So yeah, answering that if that was the question. HTTP library. Oh, that was the question. Great. All right. So how does this perished work? I'll show you an implementation example that we have in the HTTP client. So we have to implement perishable, right? Perished. So this is the implementation. This is what we do with the connection while it's sitting around in the pantry. What we do is we try to read it. The server should not send us a single byte, but if it does, or if this completes because the connection was broken, we will complete this feature, which will tell the monitor that, hey, the value is rotten now, so we can drop it. If we sit here trying to read from the server and we never get anything, that means the connection is still good. So this feature will not complete because this feature will have completed first. In other words, if we manage to ask for the value before the server breaks the connection, the value will leave through this route and will never finish the perished feature. So I'm heavily leveraging here one aspect of Rust features, which is you don't actually need to ever finish them. If you do this select thing, it completes as soon as the first thing inside completes. That means either one of these never completes. It's possible for them both to complete simultaneously. In that case, this one will have sent the value out and the value will survive. Essentially three possible ways to leave here. Either the value gets dropped because it perished, the value gets sent back out because it was requested, or both happen simultaneously and they'll get sent back a value that will immediately fail, which I have to actually handle as well in the HTTP client part. Yeah, there's a race, but it's okay because we handle all three possible outcomes. If it dies, we can't get the value back out of the pantry. If we're able to get it, that's great. If we got it back out, but it also perished at the same time, I have to actually handle that in a special way out here. When we fetch, no, that's not it. It's recycle connection. So it's possible that we do get the connection back out, but it doesn't work. So what I do in this case is I remember that the connection was reused, and that becomes important if the connection breaks later. If the connection breaks later, we get it disconnected, and the connection was reused, we're going to try again. We're going to continue our loop inside of fetch because, hey, we tried to reuse that connection, but we weren't fast enough. We lost the race. It's okay because we will just try again. So it'll loop back up and it'll make a new connection, which might get another recycled connection, which might disconnect again. So this will loop until we manage to get a connection that is either new or is a recycled connection that doesn't break, right? So that covers that third case where we do get a connection out, but it's broken. It's this special case again where it's disconnected, but it was reused. So it's like, well, it was a secondhand connection anyway. Let's try again with a fresh one. All right, so I got to the core of that pantry thing, and no one said it was that horrible of a design. So that makes me feel a little bit better. I'll show you how these monitors are actually used. The main thing that drives this crate is a worker thread. So let's just show you from the perspective of creating the pantry fresh. So we make the channel that we're going to use to communicate with the worker thread. We store the sender in the pantry directly, and then the receiver, we take it and we give it to the worker thread. So this elaborate construct is doing several things. It's taking the receiver and then giving it to the worker function, which is asynchronous. So we're going to need to block a thread to run it. That thread is going to be provided by thread spawn. So a worker thread blocks on an asynchronous function that uses the receiver end of our channel. I hope that makes sense. Oh, I need to catch up on hellos. Hey there, Nightshade dude. But races are bad in programming. Races are okay as long as you cover all possible outcomes, which is what we do when we synchronize, right? So I'm synchronizing a couple different ways. I am using a channel, which synchronizes messages coming in. I'm using a select all inside of, that we saw at the top here. I'm using several select alls, or selects. Either select or select all synchronizes parallel futures. It says, here are a couple futures. Tell me which one wins and give me one of them. Hey there, Toulouse. How are you doing? Long time no see. I think it's because my schedule's all wacky. Right? It's hard for some people to watch my stream when I start too late. Hey there, Panapudi and Rastafu. I'm probably butchering names. I'm sorry about that. I don't see Rasta's message though. Did I miss it before? I might have responded. Yeah, there it is. Yeah, you lost me 5 seconds and that's fine, but hello. Glad you're here. I'm doing great, Toulouse. Thanks for asking. Hope you're doing well. Oh, you did say you're doing well. Again, with this recursive loop where we ask how each other is doing. All right, so yeah, there's synchronization going on. Every time we see a select, we are just picking the first one that wins. And that's a form of synchronization. Let me get back to where I was. It was in new, right? New for the pantry. This channel we use to communicate with the worker thread is another form of synchronization, right? Anyway, hopefully this makes sense how we make a worker thread in Rust that handles a queue. And there are other ways to do it. I happen to be using just a built-in futures crate. So this executor is from it's just futures executor. And thread spawn is from standard library thread. Our worker is here. I like how clean the top level of the worker thread looks. When it looks this clean, I like to decorate it with little comments. It's kind of like putting the cherry on top to me, right? So, or decorating something you really like. So it's easy, makes it easier to explain too. What this worker thread is doing, it's taking this the receiver end of this queue, and it's handling any messages that come across it. At the same time, through the magic of this select macro again, we're also watching the futures that we are given to for any value stored in the pantry. So I already showed you a glance at the handle messages, right? Let's go back there and look. This is the one again that will only complete when the worker thread is told to stop, but meanwhile it will handle giving and taking of values in and out of the pantry. The take was easy. The give is a little bit more complicated, but this is how it works, right? Give includes a return, like basically a self-addressed stamped envelope back to the user saying, here's the channel to send my return value on. So we're going to send it, right? And it's if we're able to get something out of the pantry, we're going to send it back to the user. Here's how that works. So we first have to remove the requester from the pool, basically snatch it back out. And that's because we only want one user to try to request the value. We don't need to worry about a race here because the only thing that calls give parked value is the worker thread, right? The handle message is only called from the worker thread, so there's only one thread context that will reach here, so we don't need a mutex or anything like that. So we're going to find the entry, and if it's there, grab it back out. If it's not there, it's none, right? If it's none, we can't get a value. There are multiple ways in which retrieving the value out of the pantry fails, right? It'll fail because we simply don't have it. The entry is vacant. It could fail even if there is a requester, but we fail to we can't use it anymore because it's the receiver's been dropped, or the receiver actually sends us none for some reason, like the value was already dead. Lots of different paths we can get none. But optimistically, what happens is we find the entry for the value in the pantry, the requester part of it. We use that requester to send in another one shot in which we will receive back the value from the monitor right here. So yeah, where it gets really complicated is when we have channels that are used to send other channels. And again, the reason we need to do that is these channels are unidirectional. They only go one direction. So if you want a bidirectional path, you have to, it's like sending someone a self-addressed stamped envelope inside of your letter so that they can return you back what you asked for. Still wish you did as many comments. Hey there, Stryhex, how are you doing today? I only did these comments at the end. It kind of felt like what I was doing was decorating a cake that I had just baked. So until I got to the end, these comments didn't exist. I had all the code without any comments. In fact, there were a bunch of print statements in here. I removed the print statements, put comments in here, and I felt like, wow, this is really pretty now. I can publish it. Hopefully it makes more sense to someone reading it. I had a special worry here, which I have a comment here for. It's kind of dangerous to do an await inside of a future if you're holding on to a resource, like a borrowed reference, or a borrow, and we are borrowing from the pools here. So I had to be extra careful about this. I didn't want this await to be within the context of this borrow. That's why I first I grab the requester out, and then once we get the requester, we're done with this borrow, and now it's safe to do this wait. If we don't do that, then what happens is a borrowed mutable reference to pools ends up in two different futures, and that causes a panic. You can only call borrow mute safely if no other thread or future is currently borrowing it. It's only one at a time. It's the runtime borrow checker. We don't want to run afoul of the runtime borrow checker. If we do, we get a panic. Yeah, today I'm mostly going through the work I'd done earlier this week, which was to make these facilities for making it easier to do HTTP client connections and connection reuse and that kind of thing. Anyway, so continuing to walk through this, hopefully it kind of makes sense that to give a value back out of the pantry, we have to find the requester, use it to send the request, and then we receive back the value. So going back to the worker thread, if I go back far enough, I'll get there, right? Hitting back a lot. Oh, here we go. If we get the value back out, we need to send it to the user. So if you think about it, there were three levels. There were three different one-shots involved to get the value back out. We had to go all the way into the monitor that's holding the value, get it to send it back out to us, and then we return it to the user. So it's a 3-hop process. Into the monitor, back out to the worker thread, and then back to the user. So that's giving and taking of values. The other thing that the worker thread does is those monitors, right? This monitor values. This was a bit more of a challenge too, because there are a few wrinkles in this monitor values. So fundamentally in the core of it, there is a select all. So we collect together a list of all the monitor futures. And basically we want to say, go to sleep until one of them is completed. And when that one is completed, it gets removed from the collection. Select all actually does that for us. If you look at its documentation, it'll say like the return future, right? Upon completion, the item resolved will be returned, and the list of remaining futures. So this monitors left is what remains of monitors after you've removed the first one that completes. Okay, and so we take what's left and we put it back into the collection for the next loop. Now, while we were asleep here, we might have gotten more monitors added to our collection. So they appear at this, where is it? Inside here, pool.monitors. So we need to drain out of that, of each of those inner vectors, flatten them, and we have to flatten it because, again, there's multiple levels. For every key, there is a list of requesters and a list of monitors. So this is the list of monitors for newly inserted values for a single key, right? And so we take them all, and then we flatten it so that now we have the list of all new monitors for every key. And then we are taking that and extending our monitor list with all of those. So basically, we're collecting together all the monitors that we had before, plus all the monitors that were newly added. That's an odd-looking construct. Drain. Yeah, I couldn't find a better way to do it. But this pool monitors is a vector, and we need to take all of the elements out and put them into an iterator that we then use with extend, because extend takes an iterator, right? Extend needs an iterator. Drain does that really nicely, because what drain does is it gives you a drain iterator that consists of all the elements that you ask to remove. And if the range that you request is the infinite range, it just gives you everything. It turns a vector back into an iterator. If you guys know of a nicer way to turn a vector into an iterator and consume the vector in place, then let me know. But that's what drain does. When drain returns, the vector will still be there, but it'll be empty. And the return value is an iterator of everything that was in that vector that we then flatten and then we extend into our monitor set. This extra thing here is to handle when the requesters are consumed. If they're consumed, they will be marked canceled. It's if the sender gives up, they will be canceled. And so if it's canceled, we just drop them. Otherwise, we end up having a sort of memory leak where the list of requesters never gets cleaned up. We have all these consumed, used up requesters lying around. So this kind of does some housekeeping for us. It drops every requester that's been used before at the same time that we're collecting the monitors. So we're kind of doing two things at once here, which makes this a little bit complicated. And I actually don't say anything about this code in this comment. I probably should. Like, maybe I can add it now. While collecting new monitors, we also drop any requesters that have been taken out or disconnected. So this gets canceled. This could be canceled whenever we take it out because the requester is actually an option, I think. Isn't it? It's a one-shot sender. Oh, it's canceled if the if the receiver is gone, it'll be canceled, right? Anyway, so this loop again collects any new monitors, and actually, yeah, there's two levels of cleaning up the requesters. This is dropping individual ones in the vector, and then this is when we drop the entire vector. Okay, not right now. Okay, so again, this is where we sleep waiting for things to decay. The problem with this select all is that you can't give it an empty collection. It has to be at least length 1. The other problem that goes along with this is, what happens if there's nothing for us to wait for, which is sort of the same reason for select all. What if none of the monitors, what if none of the values that we're monitoring die? They're all still alive, right? We won't wake up in order to add things to our new collection. So I'm like, okay, I need a way to manually wake up this wait right here to get it to loop back up and collect any new monitors. So the solution I came up to was this kick thing. What we do is, if I lovingly call it the kick, but it's an extra feature we add on that will resolve if you send something through its channel. And it does nothing more than wake up this await so that we can loop back around. So if we don't have one, then needs kick will be true. We'll make a new channel, and then we'll store the sender in our in the pantry directly, and then the receiver goes into this boxed feature, where we just simply wait for it to happen. And when it happens, we return the kick, right? And when kick gets returned, it just tells us we need to make a new kicker. So every time we kick, it wakes up and has to make a new kick feature. Now, where the kick actually gets used, you might have seen it while I was looking through the code before. And thank you for the follow. I really appreciate that. Where the kick gets used is right here. Whenever we are putting a new value into the pantry, if there's a kick set up, then we're going to take it out and use it. We're going to give that monitor a swift kick saying, hey, monitor, wake up because we've added something new to the pantry that you need to watch. So the code is actually pretty succinct, to the point where I felt like I needed to add these comments to say, like, why are we taking the kick out, and why are we sending nothing? It's not the value that's important here. It's the side effect of sending something wakes up the kicker feature and causes the worker thread to go another loop. Yeah, that's why I thought kick was a good name for it, because it doesn't matter the value. It's just what matters here is the action of waking up the monitor by kicking it. Wake up, monitor. I have something new for you to monitor. Or wake up, worker thread. I have something new for you to monitor. So anyway, this actually works out really well, because Rust just makes sure that the futures all get run to completion one way or another. The hardest part for me to get used to was this concept of futures that either complete or get dropped before they do. So again, like, this perishes a future that may never complete because maybe the value you put in never dies, right? So you can make code that never finishes if it's inside of a future. Give it a gentle pat instead of a kick. Yeah, if we wanted to make this less of a violent crate, I guess. Anyway, I think I've thoroughly walked through this pantry crate. It is available on crates.io. Crates. See if I get the. I'm not gonna know how to get the link directly, so let's just look it up. And you're all welcome to look at the source code or critique it. But yeah, this is the crate. And yeah, let me know. I don't think very many people have downloaded it, which is fine by me. Does this even say? Yeah, 11 downloads all time. That's fine. Probably 10 of those 11 were me. Anyway, there's nothing that I didn't cover here, right? Initially, I made this monitor kind of Boolean, but then one thing I learned with Rust is that code is much easier to read and write if instead of using Booleans everywhere, you actually just make enums. So it used to be that kick was true and value was false. But I'm like, let's just give them names, kick and value, so I know what kind of monitor it is. It's either a monitor for a value or it's a kick monitor. Too advanced for you? 715-209, nothing is too advanced for you. I'm sure you're just you're just being modest, right? I think I have covered everything in here. I just really like the way this looks. It just makes it clear that what the worker thread does is it handles two sets of futures. One that's in the form of a stream, which you can see if you go to handle messages. It's a stream, because that's what this receiver is. Receiver is a stream. And the other one in monitor values is a loop which handles selecting a bunch of futures. At the top level, it's very clear that it handles two different things. And if we had a third thing for the worker thread to do, it would be very easy. We would just add something else here, right? Couple details here to kind of point out is when you deal with futures which race each other, especially in a loop, you have to fuse them. What is fuse? Fuse is a way of putting an adapter around a future to allow you to poll it even after it's completed. So normally when you poll a future that's already been completed, you get some kind of like weird either undefined behavior, or it's like left up to the implementation, like what, because it doesn't really make sense. Once a future is completed, you're supposed to like use the return value and discard the future. But in this case, we don't know, the caller doesn't really know if these futures are done yet, especially if this is in a loop, right? I think internally future select has a loop. So what fuse essentially does is says, okay, the fuse holds an inner future, but it knows when that inner future is completed. And if it's already completed, the outer fuse will just say, okay, we're done. And if you ask it again with a poll, it'll say, yeah, we're done. Don't worry. We're done, right? So it basically makes a future safe to poll again after it's completed. And that's required for loops, which use futures, and for these macros, which have multiple paths through futures. You learned select last week. It's pretty dang cool. Do you know this select all? Select all is kind of like a variant of that, where you can give it an entire collection of futures, and it gives you back the remainder futures, the index of the future in the collection that actually completed, and then the output value. It's pretty elaborate. With the caveat that you have to have one or more in this iteration. If you have zero, it panics. Because it's like, you told me to select on nothing, so what the heck am I supposed to return for the output and the index? It doesn't make sense. I guess the other way they could have done it is make these two options, and then they could be none if there's nothing to select on. Anyway, I'm happy with the crate as is, even if maybe it's not the best way to do it, because as a user of the crate, it's very easy for me to do these, when I want to fetch a connection that might or might not be still good, I have a pantry I can try to fetch it from. And if it fails, it'll just be none. And when I want to put something in the pantry, I just do store. So they are basically one-liners. The most complicated thing here is I'm constructing the key for the pantry out of the combination of the host name, the port number, and whether or not we're using transport layer security, right? So that uniquely identifies the connection for the purpose of reuse. We can't reuse a connection if it's a different host, a different port number, or we were using TLS and now we're not. Any of those things changes, we have to make a new connection. Yeah, well, you guys will have to tell me if the API looks easy to use. This is the API. It's you create one, then you do fetch and you do store. And the documentation for the pantry revolves around those three things: making a new one, fetching, and storing. Hopefully then it makes it easy to use, right? Okay, now that we're popping several layers of the explanation stack, the current state of my HTTP client is that you can, where is it? You can make a new client, and then you can, given a request object, you can fetch the response. I don't know why I made this a pub, though. Why is that a pub? This should be the only public function, is that with a client you can fetch a resource. I think this is a mistake to make this a pub. To check, what I'll do is I take out the pub and make sure nothing breaks. And then I'll just check that and it's like, that didn't need to be public. I don't think that needed to be public. Maybe I made it public because I was needing it for some kind of test I was doing. Yeah, so that doesn't need to be public. The only public API of my client is to fetch a resource. Looking for where I was using. So connect is used internally by fetch. Because once we have the request ready to go, we need to connect to a server to send the request. So that's where connect is used. Hey there, Dumpson. And Radon90, how are you today? Look at that. I look so cool with those cool sunglasses. Makes me want to go get my sunglasses and wear them. And take a picture and put that as an emote so that you can add sunglasses to my sunglasses. What new features can you try out? No new features, Dumpson, because I got really swept up in the hype with the Rust programming language. Why Rust kind of says why. So, yeah. I'm working towards getting back to working on the game, but with my new favorite programming language involved. Yeah, the Rust got me. But it's only a temporary setback. Once I have started to oxidize my game, we'll be happy again and making new features. Okay, so yeah, so the only thing we can do with my client library right now is make requests. The C++ version of this did more. I think that's what I want to start working on today. The one thing that we're going to need is to be able not just to fetch a response, but also upgrade the connection for things like WebSockets. So the C++ version of this had that through what I called at the time the upgrade delegate. So where was it actually set? Yeah, so the C++ version of my fetch is called request. So if you put that side by side with the Rust, can I do this in a way that you can actually read it? Maybe, maybe not. So there's fetch and there's request, and you can kind of see what's different. We have the request and the flag saying whether or not we can reuse the connection once we made it, which is the same as this request and this persist connection flag. What's missing from the Rust is this concept of upgrading the connection. Hey there, Lentil Stew Dragon. How are you doing today? All right, yeah. Does it currently handle it? We just do 1.1 for now. I still haven't gotten into HTTP 2. I'll probably learn HTTP 2 when HTTP 3 is out. So yeah, we're still on 1.1. So this upgrade delegate is used for WebSockets. The concept is you make a normal web request, but you say, hey, when this request is done, we'd like to upgrade this connection to be a WebSocket. And when the request succeeds with a special status code of 101, that means the upgrade is successful and the user is supposed to get the connection back out. The way I handled this in C++ is the delegate was a callback. We can march that back over here. The delegate was a callback that, basically a callback in C++ is just a function where we can give, in addition to the response, we can give the underlying connection back out. So we upgrade it by giving it up the stack to the user. In this case, the user is WebSockets. And along with that, any extra junk that we happen to have collected from the connection that goes after the end of the response, because this might actually be WebSocket messages that are like given by the server immediately after the upgrade, right? So anyway, this concept is missing from my Rust end, and I want to add that. Upgrade the connection to WebSocket. Yeah, that's the very popular use for this. Other ones are mentioned in the spec. So anytime you want to have a protocol on top of the web where the protocol needs to take over the underlying connection, they call that concept upgrading the connection. And there are special headers for it. So if I look at RFC 723, why am I using Google? I should not be using Google. It likes to dox me. uh, RFC 7230, right? If we look for upgrade, it's intended to provide a mechanism for transitioning from HTTP 1.1 to some other protocol on the same connection. So that's key. So in other words, we need to promote the connection back out of the fetch, where right now it's inside of the fetch and we can't get it out. The whole mechanism is pretty involved, but essentially you have this upgrade header and that you list which protocol you want to upgrade to, and if it works, the server sends you a 101 switching protocols in the response, and that tells you, great, we can now give this connection up to the upper layer, and we're done with the connection from HTTP point of view. It's now something else. So that's, if you want to read more about that, there's the link. I like reading those RFCs. They're really insightful about how things work. If you enjoy learning about how things work, the RFCs are really nice. Okay, so I think what I want to do is actually get rid of this bool, because having bools in Rust is sort of a bad idea. I want to turn that into an enum, which then will allow me to have a third variant for the enum, which is upgrade. And I think that's what I want here. So maybe that's what the first step I'll take is I will change this bool into an enum. Let's call it connection use. We'll call it connection use. We'll call it use, or connection use. That's what we'll do. Are there any HTTP tools to check if you've covered all cases? Not that I know of. That would be sweet if there was. Probably the best you'll find is in the unit tests and integration tests of an already existing crate out there that does it. So like for me, I've already done this in C++, so I have a bunch of unit tests that I would use to try to check. If you actually look at my HTTP client library though, I actually don't have any tests because I don't know how to do them. The main reason is this fetch underlying uses connect, and connect goes straight to a TCP stream. So that means if I wrote a unit test for this, I would need a web server running. And that seems really complicated. In the C++ version of this, I actually did it two different ways. Sometimes I would actually set up a real set up a real web server in the test fixture that only talks to localhost. The other option is I would use dependency injection to not show the concrete type here, but it would be passed in as a trait of some kind, right? A trait object that you'd use to actually make the connection. So I could do that here, but I'm not sure if that's the right way to do it in Rust. I'm not going through full TDD for... This is one level up. This is not a leaf component. This is relying on my pantry, on TCP stream, and on my HTTP crate. It just works. I wish Pro Table Flipper, but in general, it's more than 50-50 chance that it will just work. It's more like 80-20, but there still is that 20% of the time where it doesn't work. That tends to be not bugs like off by one. Well, no, actually, that's not true. They tend to be bugs which go beyond things like bounds checking and borrow checking, because Rust does that for you now, or C++ doesn't. Seems like a really good way to set up an independent server with known responses and test your client. Yeah, but it's a lot of work. I guess I just didn't feel like going through the effort of setting up either a real server or a dependency injected mock of Connect. Although I guess it wouldn't be too hard. Maybe that would be the to-do for this crate. I'll get to it at some point. I'm not going to be doing it today though. What I really want to do is add the upgrade feature to this API. So I need to define what connection use means. So I'm going to go up here. I guess we'll put it here. Enum connection use. And one will be I don't know, like use once and then throw away. Single request, single resource. And then the reuse one. What do I name that one? Like multiple resources? and then upgrade. There we go. And I suppose we need to document this, so let's just do it now. This is used with fetch to tell the client how the underlying TCP connection will be used, especially after the what current request? After the currently requested resource has been successfully fetched. So for single resource, it should be close the connection after retrieving the resource. This will, oh, when this is used, the client adds the header connection close as specified, and we can actually find the references. I like having references. So it's like connection close, right? Yeah. So we'll have a reference to section 6.1 specified in IETF. Do I want to make that in a backtick? I might as well, right? IETF RFC 7230 section 6.1. And we can just make that inline, right? Inline link. That didn't work. Inline link, please. There we go. This one, guess I don't feel like making that one inline. I'd rather that be a footnote. Fetch, and then, how do I do this normally? I need to search for that. Ah, like this. So it's in the same method, right? So it's just method something. Method fetch, right? Oh, wait, this is... Okay, this is not in the context of the structure, so I have to have the structure in front, right? So this would be struct HTTP client. There we go. Hey there, worship the sofa. And also hello to Gertero. Gertero. Set up an independent... Yeah, yep, TCP listener. Building an HTTP client from scratch? Yes, sir, for the second time. This time in the Rust programming language. And it's working. I can actually show you. Check it out. We will get from a very cool game, which no longer operates, but you may have heard of it. So cargo run example. I have an example program called Rover, which just fetches a web resource. Bot.land. Rip botland. Oh, it doesn't compile yet. But I can just run it manually, right? Without building. So target, debug rover, bot.land. Oh, this is kind of old. But yeah. So it fetches the tags and everything. So we have a working client. I just don't have all the features I want. So I'm adding this feature, this upgrade feature right now. Yeah, rip Atom Botland. I don't want to fetch from like Google or Yahoo because for one thing, the response bodies you get back are tremendously long. And the other thing is they contain like creepy things like your own IP address and your own location, which I don't want to leak on stream. All right, so then keep the connection open in case the user wants to fetch another resource from the same server. This is attempt to upgrade the connection, and this needs to have more information, right? So it needs to have all the information I had in C++, which I forgot to pin. That was in client? Oh, this one. That's not it. Oh, it's sort of built into the request, isn't it? So the only thing I really need to have is a channel, probably, right? That gives the connection and the trailer. Actually, why am I thinking of a channel? I don't know why I'm thinking of a channel. I think the return value should include these things. Yeah. All right. Hey there, Ireld. And hey there, Lazy Guru. How are you two doing? And Ultramark, how are you? What happened to my RPG? It's on hold right now, and while I get some of the pieces of it working in Rust. My game is going to be turning into a Rust game. Not Rust the game, but a game programmed in Rust instead of C++. I think I've decided that the only reason I would ever write in C++ again is if I was employed to do so and they didn't want me to do it in Rust. That's how much I've become a converter. Or that's how much I've converted. Attempt to upgrade the connection for use in a higher layer protocol. Higher level protocol. Employed at a premium, you'd say? Actually, I thought C++ is so widely known that they're not paid as much. If you wanted to get a premium, you would learn COBOL. That's what I've heard. COBOL programming is where you make the big bucks. Okay, so connection reuse, we have our enum set up, and I need to actually use it. I'm just going to follow the compiler errors. Yeah, it's right here. So I think here, this should just be an if let some connection use multiple resource, not multiple, wrong one. Single resource equal borrow connection use. Actually, it's by value, so no, I want to borrow it because I'm going to stuff more things in that connection use soon, I think. Actually, I'm not sure. Oh, it's not some. It's just that, right? Yeah. So if it's a single resource, then we're going to close the connection. Hey there, it got sponged. How are you doing? Would Rust be applicable for low-level things like drivers for hardware? Yes, it's actually one of its design goals is to operate in that realm. There is a special subset of the language called unsafe code, where you set aside the extra compile time checking and safety, and open up the extra tools for doing things like pointers, hardware mapped registers, or memory mapped registers, and that sort of thing. So, hey there, Cthulhu. How are you? Foobarb Wave. I don't know this emote, but hi. Yeah, so that's a whole nother part of Rust, is the community of Rust developers that uses it for low-level things. I'm doing well, Cthulhu. I hope you are too. Is it not that COBOL is hard, just no one wants to do it? Yeah, well, it's supply and demand. Not very many people want to do COBOL, therefore it's one of the highest paying languages. Unsafe is more of a super... I think of it as neither a superset nor a subset. I think of it as just an extra toolbox you have to open. And you open it by doing unsafe. Right? This opens up the toolbox, the unsafe tools, so you can do things like pointers, right? And I don't even know how to do that because I didn't really study unsafe. I'm going to try to do as much as I can without doing unsafe code. Hey there, Silmith. And Endurn. Wow, all the moderators are here today. Look at those green swords. Namely things that aren't checked, yeah. So in order to do low-level programming in Rust, you have to do things that the borrow checker would be otherwise very uncomfortable you doing, like manipulating pointers directly. Toolbox is filled with dust of the COBOL toolbox. mod while incoming. I don't know. That was one change. So now there are multiple ways we could use a connection, and only for single resource do we want to say connection close, right? Here's the other one, right? This is if it's multi-use. So if connection use multi-resource equals connection use, right? Then store the connection. And I can't do this Y. Oh, let. Yeah. There we go. All right, and then I probably need to fix Rover. You know why I called this Rover? Because Rover is a dog's name, and dogs like to fetch the newspaper for you, right? So when we tell Rover to go fetch, Rover uses the client's fetch, and it just nicely prints it out. Okay, this is literally the example. I also threw in here Control-C handling. I think this is really cool way that they decided to do this in Rust, is that Control-C becomes a future which you can use with select. So basically your entire program is one future alternative in select, and the other one is at some point you hit Control-C. And this lets you just abandon whatever you were doing for the rest of the program and just bail. I like that a lot. You just need to wrap your rest of your program as an asynchronous future. So this needs to be, oh, and I'm going to need to export it too, right? So this is going to need both the client and the connection use in order for us to say, although that's sort of generic. Can I export that as a different name? What if I don't do that and I just be explicit on the namespace? Connection, yeah, I kind of like that better. This is single use. There we go. I'm missing a little bit of chat. Let me try to catch up. Financial institutes and governments run COBOL-based systems, and you have to know what you're doing when you're working with money or government authority. You got to be careful. Also, if you're working with life-critical things like medical equipment and airplanes. It's a superset in the sense that all safe Rust code will also work in an unsafe block. That's true. I'm not saying it's not a superset, but I just don't think of it that way. I think of it as like Rust gives you a bunch of tools, but one of those, but the tools are given to you in the form of a bunch of boxes, and normally you open up the standard library as one box, and then the unsafe is kind of sitting there, and it kind of has spikes on it and a skull and crossbones on the front, and it says unsafe along the top. And if you want to, you can open that box and take tools out of it, but you got to be careful. White hat hacker exposed that plane networks are basically unsecured. Well, unsecured as in connections on that are easy to monitor, right? But not insecure in that like you can get access to the airplane. Mars rovers have cool names like Curiosity. Yeah. Okay, now I'm randomly looking through chat. I need to catch up linearly. Wasn't Rover the same name that Mars RC vehicle? Yeah. Rover's also a dog's name though. Unsafe gives you extra things, that's true. No cryptography? Yeah, no what's the right word there? Safety isn't the right word. Anonymity? No, not even that. I'm bad with words. Rhyme was bad with words. You can read it in plain text. Yes, that's right. All right, go Rover, go. Yes, so Rover's working again, right? So I can compile this now. We can try to go to bot.land. No, I have a bug somewhere. Okay, oh, it's up here. That needs to be a semicolon. Was that it? There we go. And there we can see the unfortunate news of taken completely offline October 22nd, 2020. Yeah. Cool. All right. I have this default value for the argument just because I couldn't find a way to debug the main program but give it arguments. If anyone knows how to do that, that would be cool. My workaround right now is to just give every command line argument a default value. That way I can just hit this debug and it'll just work. Or the run, actually. But either way works now. Using the default argument. Yeah, it works. All right. Can't wait for the comma to explode. Use unsafe only for FFI. Yeah, you have to, because the foreign function interface, the FFI, is a hard boundary across which the compile time tools in the Rust compiler can't see. Couldn't you add a default print for the response? I don't get you. Default print for response. When's the next stream? I don't know, but the current stream is right now. Hey there, Shabatter. And welcome to Twitch. All right, so let me go back to from this example. I don't think I need to look at that example. I need to make a new example for WebSockets. I think for right now, I'm just going to code without having an example to test with. It will be, what do we do when the connection use is upgrade? Could I just put in the right thing here? Let me look and see, what did we have to do? What's the problem with debugging your code? The problem I was having with debugging my code is passing in command line arguments using the buttons that they add, the links that they what is it? This extension I'm using, Rust-Analyzer, right? Rust-Analyzer is a really cool add-on, but one problem is that for run and debug, there's no box here to put in the command line arguments. So if the normal way I run this on the terminal is to, oh, that's weird. What happened there? The normal way I do this is I do cargo run examples rover, and then I have to give an argument like a website, like bot.land or something like that, right? Is it example? So I can put in a command line argument, obviously, on the command line, but what if I'm doing it here? So there's no way I can put in a command line argument. Do you have code LLDB extension installed? I do, but I couldn't get that to, I couldn't get the new configuration working for that. I can debug a cargo output or tests, but I couldn't get this launch thing to work correctly with Rust. Yeah, we can look at that at some other point, but it just wasn't working for me. And maybe it's just a problem with the way I was doing it. So my workaround for not knowing how to solve that problem right now is that in my example main program, I just have a defaulted argument for when I do tests. It's easy enough. Actually, that also makes it more convenient because I don't have to store that somewhere else or type it again on the command line. Don't know how to configure it? Yeah, exactly. I don't know either. There's probably a way to do it. I just haven't figured it out. All right, back to the upgrade option. I wanted to look and see, what did I do on the C++ side? Actually, probably what I should do is peek at what WebSockets does, because it's been a while. There would be, I think what we did is we added the upgrade header ourselves, right? Is it make connection? I don't see it. Is it this one? And how come I can't oh, there we go. Here it is. How come I didn't find this before? Weird. So we have to actually set more than just the upgrade one. I was thinking of just taking the protocol name and just putting it, because there's a convenient place we can put it, right? I can just put it here. String, right? And then the WebSocket would just be the data attached to the upgrade variant. But So that would do away with needing to do this, but we'd still have to do these other headers anyway, right? As well as this connection upgrade. This we can do, I think this one we should do in the library. Maybe leave these, well, no. These are in the domain of HTTP, right? So, okay, these three lines I'm gonna take out and do in the library, and these two I'll leave in the WebSocket code. That makes more sense to me. So I will keep this in here. So attempt to upgrade the connection for use in a higher level protocol. The attached string is used for the value of the upgrade header, which is added to the request. And I'm actually tempted to make that into a structure so I can give that thing a name. Hey there, again, hi. All right, yeah, we'll leave that in there, and then I think I can use this is a nice place where we're setting other headers specific to the user agent, right? So what if we just do a match here? Match on connection use. And then this single resource arm will set the close header, and then I should have an arm for it anyway. Multi-resources doesn't need to do anything. Then the upgrade, this would be protocol. We'll do this. It will set the upgrade header to the protocol. There we go. Use a name field instead of a tuple field with a comment. Yeah, you're probably right. You've convinced me. Have a point. And that's your first point on my channel, so have another point. Points you can't use for anything yet, but in the future, maybe in the game I'm making, you'll be able to use them. So hold on to them. Let's see. I need to go here, right? Yeah, I think you've convinced me. Let's make it a structure. So this would be protocol. So then we would just document this. This is value to set for the upgrade header in the request. There we go. I like that better. What's the point of points? I know. You'd rather have a pointer. I see. Okay, so then I have to fix this, right? So this just turns into curly brackets, I believe. Yes. So we get a reference to a string, which we use here to set a header. All right, so then that's the request. Now for the response, I need a way to send the connection up if we get a 101, right? What's the issue? What's the use of triple slash? It's a doc comment. So I will demonstrate. As long as we have these, when I do, let's go to the project. If I do cargo doc open, and I haven't run this yet today, so it's going to take a few moments. Like Kit Boga would say, just wait a moment, just wait a moment, just wait a moment, just wait a moment, just wait another moment. Like my kids chant that sometimes because I let them watch Kit Boga a little bit. Anyway, all right, so there's the link. Plop it here. So if it has triple slash, then it gets put into here. Here, right? If I remove the triple slash and I do cargo doc again, should be much faster that time when I reload. You'll see that it disappeared. So it's the way to mark to cargo doc, the documentation generator, that you want that string to be imported into the documentation for that matching field. So you can do it on any field of a structure, any variant, any type, and also there's a special syntax for doing it crate wide, which I've done in the other crate here. So this is crate wide documentation where you have an extra bang in front instead of a slash, and that goes up to, so I don't have any crate wide stuff for this crate, that's why there's no documentation here, but if I added something here at the top, hello world, I think you know what will happen, right? Hello world. There we go. It's like Bitcoin. Yeah, my channel points are like Bitcoin. It might eventually have a value. / expands to the macro document attribute. That's a very interesting. I didn't know that. I like to know how things work. So, Irel, you get a point. The points command doesn't work right now for anyone else but me, unfortunately. I'm sorry about that. The points command's broken. It sometimes works, but other times it'll say you don't have any points, and also it doesn't strip out the @ sign. You can use cargo expand to see what the doc comments expand to. Oh, that's neat. Let's give you a point, Silmith. You're teaching us all the inner workings of Rust. Yeah, who knows who the best mod is? Who knows? Make mods great again. Oh, wait. Oh, I see. Yeah, because you guys are gifting points? Wow. Claim best mod. Anyway, where was I? I got a little bit distracted. Right, the upgrade. So this is building, right? Yeah. All right. So then, right, the request is done. I need to handle a response. That's where I was. So where do we handle? Here's the response right now. I don't need to have that open. Right. So we can do it here, right? In fact, it should be included in all of these things. Yes. I think what... Oh, why do I have a return there? Is that because this is... Oh, because it's in a loop. Okay. Okay, so what we get out of the function right now is just a response, but I think I need to add more things here. Because you might need to have those other two things that were here, right? They need the connection and the trailer, possibly. It's interesting that I have the response here as well. I don't remember why I did that. Because isn't the response also given back when you complete the transaction? Here's where we give the response, but then do I give it again? I think we just also store it, don't we? Oh, thank you for all the follows. I do appreciate that. Now I'm looking at my old code to see what it does. Yeah, it's harder to see because in C++ you don't have to say self dot, but this is a field of the transaction. Response there. So, yeah, you could look at the transaction and get the response back. I think this is just for convenience that I included the response. I don't want to do this. I don't want to do it that way in Rust. I think I'm going to include it here. So I think I'm going to need a new type, like fetch results. That kind of goes with fetch, and so we'll have to declare that somewhere. Can I declare it above the function? Can I do this? And make that public? I can't do that, can I? Struct is not supported inside of an impl. Alright. Fine. We'll move it out. Let's put it here. So here's where the response would go. So let's just fix this up. So where I return it, it's got to return OK. Fetch results response. And then this will have broken rover, right? So we need to fix rover. So here, I can just say fetch results, right? Just include it in the pattern, and that will fix that. Why does that not work? It's private. Oh, yeah. Don't be private. Be public. Okay, and might as well document it since we're here. This holds all the results from fetching a web resource. This contains the parts of the HTTP response returned by the server. Okay, and then now it's back to compiling, right? Cool. So now I'm free to add more fields, right? So we can add the two that I needed from the C++, which was the connection and the trailer, right? So let's add those. So if the connection was upgraded to a higher level protocol, this will hold the connection. Well, if the connection was upgraded to a higher level of connection, to a higher level protocol, the connection will be placed here. For what I want to say here, if the connection was upgraded to a higher level protocol, the connection will be placed here. That's all I want to say, right? So this is connection, which is an option, Boxstein connection, which means I need to make that thing public. It already is. Not a problem. All right. So then the last thing is the trailer, right? So that's trailer. Do I need to make these all public? I think I do. Trailer is just, which is a string, which is an optional string. Whoops, that's not what I wanted to do. Excuse me while I fight my keyboard. Okay. I kind of feel like I should combine these two into another structure, because these always go together. I think I will. So pub struct upgrade results. That's what I'm going to do. I'm going to move them in there. So the connection and the trailer move there. This holds additional fetch results for the case where the connection used in the fetch was upgraded to a higher level protocol. This is the underlying transport layer connection. This holds this is really not a string either. This needs to be a vector of bytes, because it might not be Unicode. Hey there, Frost Ice Cold. Rust and implement HTTP? Yes, exactly. That's what I'm doing today. Enable two-factor authentication worked like a charm. Nice, yeah. It's been at least a year since I did the two-factor auth. Oh, and I forgot to say hi to somebody. Siphon, hello. My stream helper reminds me I forgot to say hi to you. So, hi. This holds any bytes received from the server that came after the HTTP response, and so well, it's not trailer. Should be like leader or something. Holds any bytes received from the, because it's the beginning of the first message from the upgraded protocol, right? This holds any bytes received from the server that came after the HTTP response. They may be junk, or the first bytes of the first messages sent by the server using the higher level protocol. It's not our business to judge. Shrug. Sometimes I like to be a little humorous in my comments. I hope you don't mind. Why Rust? Why Rust indeed. I don't have a list of commands right now. I am a Costner, but hello, how are you doing? Mostly the commands are used by me and people who are regulars who know which commands do what to answer common questions. What version is HTTP? I'm just doing 1.1. And hey there, OR-driven. I haven't gotten into HTTP 2 or 3 yet. And HTTP 1.1 is still widely accepted by servers, so and I don't really have a need to use 2 myself or learn 3 yet, but probably I will. Like I said earlier, I'll probably learn HTTP 2 once HTTP 3 is released. In other words, I'll catch up when I'm way behind. Okay, so if I do that, then I can combine these two, right? So this would be upgrade results. So this is an optional upgrade results. If the connection was upgraded to a higher level protocol, this will hold additional information. Sure, and then you just look there, right? Yeah. Do you design your libraries already in mind with HTTP 2? Not really. I'm mostly trying to design my libraries around a convenient API that I would use. So, for example, this HTTP client is, I can close that, is revolved around this API, and this is common in other languages, right? Where you can say, hey, user agent, please fetch me a resource. Here's the assembled request that identifies what resource we want. And you're going to give me back some results which include a response and possibly other things. So that's what I'm designing my libraries around, is either APIs that I'm already familiar with from other environments or languages, or just what fits. So like in my example program, Rover, right? I just wanted to be able to say, ultimately, fetch this URI, right? It's a little bit more involved because you have to parse the URI from a string. But I just want to take the URI that you enter, which could be something like this, and say, just fetch it, give me the response, and the response will have status code, reason. We know what it will have, right? Status code, reason, phrase, headers, body. But let the library worry about how to get that. We just want to get it, and then once we get it, we have it all available, whatever we want. That's how I've been designing my libraries. Maybe not the best way, but it's been working so far. In the sense that if I don't get it right the first time, then the more I use my own libraries, the more I learn how to improve the APIs. So it's an iterative approach, just like a lot of techniques I use. Okay, so fetch results needs to have another field in it, right? So this would be upgrade results. So why don't we just leave that, and we'll just define what that is. Actually, I think I want to redo this. I'm going to say results depend on how we're supposed to use the connection, right? So then match the connection use. And actually, it depends on more than one thing, right? Results depend on how we're supposed to use the connection and what the response status code was. So I already know I'm going to need that. I thought ahead. So we need to also match on response status code, right? Because if it is connection use upgrade and it's a 101, then it's a successful upgrade. Otherwise, if it is a can I just do the else here? In which case, this should just be an if let. Yeah, I should just make this an if let. If let that equal that, then this, else everything else. Okay, whoops. Then, excuse me while I fight my keyboard. This can just be none. Ah. Keyboard's being a real jerk today. Oh, this had a protocol in it, so I don't care what the protocol was. So it's a dot dot. All right, so it's just going to be return OK, fetch results. Why am I writing it when I can just copy it? This has to have some more data in it, right? Upgrade results. Connection is our connection. So actually, I don't even need that. And then trailer is whatever we had left over. That will be held in the response, right? Actually, then if it's already in the response, I don't need it here. So it's just connection. Yeah. Okay, this needs to be moved then. I don't think I actually have that in the response. Okay, I'm falling behind in chat. But in doing so, do you already design it in mind that you have the transport layer as a replaceable dependency? I did for C++, but then I ended up not needing it, so I chucked that. I might bring it back though, because the fact that it's in there prevents me from doing unit testing conveniently. So we were looking at that earlier in the same library, right? When we do a connect, it is going straight to the TCP stream type in the standard library, right? So this prevents me from using another transport layer. When I did this in C++, I used dependency injection, but I only ever had one implementation. So it seemed like a waste. So I'm sort of on the fence, because on the one hand, it would make it easy to unit test this. On the other hand, if I only ever have one implementation of the dependency, then all that extra crud to do dependency injection is really not worth it, or potentially not worth it, unless you think that the testing itself is it makes it worth it. I can go back and do that. So if I decide to support other transport layers, the way we would do it is we wouldn't go straight to TCP stream connect. We'd have to inject in to fetch, or maybe to the new on the HTTP client. I'm not sure which. We would have to be able to inject in a value from which we would derive the connections. And maybe a default or stock implementation would just be to call TCP stream connect. I think I'm not going to do dependency injection for the transport layer security, because I don't see any reason why you'd ever want to change from Rust TLS or Russell's to something else. I can't imagine why you'd want to. Like, maybe if you're really picky about your TLS provider, but I'm not going to be. Seems to me after reload, everything is fine. Oh, I dropped 104 frames, but I don't see when that happened. Maybe it just happened now. I was having trouble watching other people's streams yesterday, where every 20 seconds or so, for a good few minutes, I had to hit the reload stream button. I used the BTTV and Franker, was it Frankerface? Yeah, FFC plugins to Firefox, and that adds a little button for my Twitch client where I can just reload the stream without hitting refresh. And I had to keep doing that. All right, sorry, I'm getting distracted today. This is a problem. Why? Because I didn't add trailer. I didn't add trailer because I needed to move this. That's where I was. I think this trailer needs to be in response, which is in another crate. Your princess is in another castle. I think it needs to be here, where the response is. Yeah, there's no trailer. We need to add it here. This holds any bytes received from the server that came after the HTTP response. This may be junk or the first bytes of the first messages sent by the server using a higher level protocol. We don't know if it is or not. It's not our business to judge. Yeah, exactly. And this will be an option. I think this should be fine for now, except for the new. Yeah, so the new trailer will need to be none. And then that should not affect any of the unit tests here. So I'm going to do cargo test. Oh, I can't do that because this now has a problem. Right, because I never removed it. Exactly. Okay. Why is this still not good? Oh, this should be some. I'm on the fence whether or not this space should be here. I don't put a space there, so why would I put a space there? I think maybe I should not have a space there, because it kind of, yeah, it kind of flows. It's more consistent with other things. Now, what's wrong with this one? Oh, yeah, that's not an option. That's, the option is here, so I don't need an option here. It's just our boxed connection. All right. So we're good now here. So I can run my test to make sure I didn't break anything. We're not good. Okay. Is it Rover that broke? Yep, it's Rover, of course. Yeah, so I don't care about anything else in the structure. Yeah. That's how you do that. Aren't match arms and patterns cool? I can say, I don't care. I don't care about anything else. Yeah, everything's passing, so we're going to continue. Okay, so I'm going to need a test to make sure we get the trailer, right? So let's make one back in the other crate. Not request, response, right? It's only for responses that we have this. So I need to add a unit test that has a trailer in it. Should I just pick a simple one? Like this one? That's incomplete. I need one that passes. I mean, I could combine it with chunked, I guess. What if I just didn't... no, it shouldn't go with generate. I'm just gonna steal from this and, like, whittle it down, because we don't need to have the full test. Actually, why don't I just add the trailer in here? I can't decide. And now that I think of it, it doesn't even need to be an option. It can be, let's put a bookmark here. It can be just a vector, because we can just make the vector empty. Making an empty vector doesn't actually cause a memory allocation, right? Musen taught me that. You only actually allocate something when you push something into it. So that can just be a vector new, which is, as far as I know, it's a constant time. Yeah, it just does that. So it doesn't actually allocate any memory, which is great. No need for option, right? Maybe just extend this so that we have a trailer. Yeah, we already have a trailer. Yeah, okay, good. Oh, I see what I did. I think in the C++ that was the trailer and I had a different content length. Let me verify. Trust but verify. Trailing CR. No, I had the content length including it. Okay, so that is different. Never mind. I think I will make another test, just because it's a new feature, it should have its own separate test, right? And then we can just focus on the trailer part and put it at the bottom. Parse get response, or just say parse response with trailer. And we'll just shorten this down. I don't need like server or modify. I don't need any of this stuff. We do need a content length. And sure, that's sort of like the minimum, right? I think. I think that's the minimum, right? We can say this is the body. Hold on a second. I just told the people in my house that are yelling that if they want to be on stream, they can continue yelling. You think I have noise canceling, but sometimes it doesn't always work. Okay, this is the body. This is some extra trailer junk. So, I need to count the number of characters here. So from there to there is 15, so that's 17. So then, I don't know why AutoMod held that up. You're right, it didn't work, but you can make out anywhere it's just the words were said. I'll let them know. Yeah, they can hear you all right, just they can't figure out what your words are. I think this might break a few of my tests because I assumed that it wouldn't consume the trailer, but we actually do need it to consume the trailer, correct? I think it should consume the trailer, yeah. All right, so then we might break some tests, but that's okay. It will consume the entire raw response, but this will be held in the trailer part. So then I don't care about these other things. I just drop it, right? Yeah, I don't need any of these asserts. I only need to make sure the body and the trailer have exactly what I expect. Why did I not get a warning before and now I am? That's odd. What am I doing differently? That's weird. I don't get a warning for that. But I get a warning for that? What's the warning? Calling us bytes and string. Why was I not getting that before? What? Is it only when the string is a certain size? Oh, I wonder if Rust is doing something behind the scenes here. If it's short enough, it's implemented slightly differently. Interesting. Okay, well, for my unit test, I think I don't want to have that warning. Let's just suppress that. Array bound start from 147. Yeah, okay. So it has to do with the length of the string, I suppose? Yeah, I want to suppress it like here. Not in the main crate, but here. I had to look this up, by the way. The difference between that and that is this means applied to it's an outer attribute, which means you put it outside the thing you're attributing. So it would be like this applies to just a function. This means it's an inner attribute, which means it applies to everything it's inside of. So it applies to the entire module. All right, so that will suppress that error. Okay, and then I just add the new thing, right? So this is some extra junk for the trailer. And then that will fail because we're doing test-driven development. And the trailer has nothing in it. So, oh, actually it didn't even, all right. It didn't match this assertion here. Probably because of that. I wish the response would say that. I mean, I wish the debug message would say that. It doesn't, though. When the debug stuff for matches doesn't actually tell you what the right-hand side was, unfortunately. Just prefix a string with a B. We can try that. Yeah, that doesn't work. Because because it says that this is fixed. So I could do this to make it work, right? No, not even that works. I have to actually make a reference to it. So I remember running into this before, that I didn't like the extra junk around that. I actually preferred to just say as bytes. So it's a preference thing. Is it because, yeah, so you can't just say that, and you can't just do that. You have to do all three things. You have to say it's binary, you have to actually borrow it, and you actually have to slice it. You can't just do the B, unfortunately. I prefer that, because I don't like how this looks. That just looks kind of funny to me. It's way more verbose than some crazy syntax thing. So it's going to come down to a matter of personal preference, right? So there could be flame wars around it. That's okay. I'm not going to participate in that. I go with whatever looks nice to me. And when I come back later, this is more clear what it's doing. It's saying, oh, the string as the bytes of the string, not as the UTF string. UTF-8 string. Okay, so I have to fix this test. So it has to do with what parse does, right? Right, so when we get the body, parse message for fixed body, right? So if it's greater than what's needed, it's only going to consume what's needed. So I think I need to add to this, right? I need to say if, well, one thing is this should go here, which means I can kind of take the okay part out, right? And turn this around a little bit. Although this might look a little funny, I could do it like this. I can say okay, that, comma, this, end. And then remove these and just say that. Now, does that look too weird? I don't think that looks too weird. Yeah, and then I have to do the additional thing, which is to collect into the trailer. So self.trailer.extend from the raw message needed onwards. Right? That should make the test pass. That was weird. I had multiple cursors on. Run that test. Still failing. I'm off by 1 byte. Look at that. I'm off by 1 byte. That line feed didn't get pulled in. To the body. Yes. Am I off by 1 in the content length then? Let me think about this. That's 15 characters? That's 16 characters. I am off by 1. 2 more for character turn line feed. There we go, we passed. But I betcha I broke some other tests here, so we have to run them all. Run them all. No, they all pass. Well, okay. That's great. I guess none of the other tests involved a trailer that we threw away. All right. What type is response body? It's a vector of bytes. And hey there, Papados del Papa. I think there is another way I could have done this. I was playing around with this the other day. You could also say assert matches. I had to do this for when there was an uncopyable argument, like if it was an error or something. So you have to reverse it like this because this becomes the pattern. I think you can do that as long as there's 2 parentheses here. And then maybe I put a B in front and then it works? No, it's still a problem. Okay, maybe that doesn't solve it. We're still back to that, right? Actually, this is even worse. That doesn't even work. All right, forget that. Was it that I had to do as deref here? as ref. Or I had to borrow it, or there was some way I got this to work. I can't remember what it was. Never mind. the slight subtle details in vectors and slices of vectors and versus strings and string slices are all a little really weird. The B syntax works with, yeah, you would think that, okay, so we can try that. Put this back to B, and then I still have to do that, right? No, see, it just won't work until I do that. Actually, it still won't work because can't compare them. Interesting, but that works? So when I borrow the vector, I can't even compare it to a slice. Yeah, partial equal to a borrowed vector is not implemented. I mean, yeah. Really weird, really weird. Anyway, that's the way, that's one way to make it work. I'm gonna be happy with that. Does it have a booty if it has a body? Good question. I don't know. Okay, so we support trailer junk, which is good because we'll need that for WebSockets not to break. I'm gonna check that in. HTTP. Try swapping the sides of the assert. I can try that. Sure. So I added the trailer, and I handle it there, and then there's our test for it. That's nice and clean, right? Add handling of trailer. Extra bytes after end of response. Yeah, sure. All right, they're saying I could maybe reverse these. In my mind, it shouldn't make a difference, but we'll see. Okay, yeah. So you can do that. What irritates me is you can't swap them. That doesn't in my mind assert equal should be what's the word? Reflexive? Symmetric? Is that the problem? It's the partial equal implementation is asymmetric. So it works this way but not the other way. To me that irritates me because I think it shouldn't matter if you do A equaled B or if you do B equal A. You should get the same result. And what I mean by result is they should either both compile or both not compile. And at runtime, you should get the same value out of them. Obviously, this is not reflexive. Vex implement for arrays, but arrays don't implement for vex. So, shouldn't Rust not care which side you put it on? When would you ever want an asymmetric comparison? I think I'm going to leave it the way it was, though. Changed this a bunch of times, didn't I? Trade even says it should be symmetric. Yeah, maybe we should file that as a bug in Rust. Which, you know, probably someone else is going to get irritated by it, and they will file a bug, and then it'll just get fixed. Now you know why people put the result in the left and expected in the right? I do the opposite, though. I'm just so used to putting expected first. There was a reason why, and I was unable last time to find the reason why I made this a habit. I think it had something to do with when in Google test when the assertion fails, it'll print out expected blank, actual blank, and they had it expected first, actual second. And if it wasn't Google test, it was some other test framework that I used at some point in the past where they put expected first. And then I just developed this habit of always putting the expected first, actual second. All right. How are we on status? Clean. Nice. So then, just for the heck of it, let's run our tests again. All of them. All Rust tests. Pass. Nice. So then we have the trailer available. It's in the response, so I don't need to include an upgrade results. I wonder if I need to be so elaborate with upgrade results. What if I just put connection, option box connection here? Am I ever going to have more than a connection for an upgrade? I don't think so. I don't think it makes sense. I'm going to collapse this then. So I'm going to collapse this back. If the connection was upgraded to a higher level protocol, this will hold the underlying transport layer connection, which becomes the caller's responsibility. Sure, and then that's an option then. Remove this, and then fix this stuff up. So this is just connection, right? Is some connection. That's some connection you got there. Here, connection is none. And I break anything else? No. Nothing broken. We're all good here. All right. I wonder if I should take a break soon. It might be a smart thing to do. Just get up and stretch. It's been 2 hours. What would be the next thing that I do besides yawn? Make everybody watching me yawn. I'm sorry about that. So, if you did request an upgrade but you don't get a 101, it'll just fall into the else, which is what I want, right? You won't be able to reuse the connection, which makes sense. Because if you fail to upgrade, I don't think it makes sense to reuse the connection. But maybe it does. I think it's an atypical response to have a failed upgrade, so I don't really care if it stores the connection. So it will just no connection, and the response will be not a 101. All right, then I think I'm done. I can build WebSockets on top of this, right? So let me check this in. Thank you for the follow. I do appreciate it. I think rather than building WebSockets on top of this, though, I want to do the web server stuff next. And that means I'm doing something completely different, which means it's a good opportunity to take a break, right? So what does this have in it? Right, so this is essentially changing that flag to a connection use. Oh, I should remove the hello world. That was just to show how we make module global doc comments. So I added this. Added that. Okay, that is separate. This I'll check in separately. So this is HTTP client connect shouldn't be public. Now you know why people put the result. Oh yeah. You also do the result left side. Maybe I'm the only one who's backwards. It did help me find a bug in URI parse, though. Do you folks remember that? I wonder if that's even been addressed yet. We can look. I managed to find an infinite loop in this library, and I logged it as a bug in their GitHub. This one, that's actually not, yeah, Stack Overflow. Yeah, if you, because if you're weird like me and you put the expected on the left, this actually causes a Stack Overflow, whereas this works. The only difference is the order of the arguments. I did open a lot. That's when I was evaluating the library and starting to get more and more disappointed at their implementation and their API. So not only did I find that Stack Overflow, I found that they weren't done with the code to parse certain kinds of addresses. And, oh, looks like someone else opened an issue. Bubble up as borrowed to the URL. Interesting. Anyway, this one completely didn't work. And the percent encoding is just a mess in their library. Like, they should handle the percent encoding. There's no reason why they should make the user handle it. It's a function of that specification. Anyway, enough criticizing. I did find things I didn't like. That's one of the big motivations I made my own. Fetch results. Right, so that's now a connection use with the fetcher. So I really did two things, didn't I? The flag becomes a connection use, and then the results now is a structure because it has a possible connection in it. Yes, right. So this is enable upgrading of HTTP client connections. So one is to change the what's the name of it? Oh, thank you for the follows. I appreciate it. There's Rover again. I know Rover's my example to show you how to use it. We changed this thing. Changed the reuse parameter of fetch to be Boolean parameter to be connection use, a connection use enum value, so that we can have three possibilities. One, single resource request implies connection close. Two, multi-resource request implies reusing the connection for later, or implies caching the connection for later using my wonderful pantry. Three is upgrade request implies upgrade header return connection to client if status is 101. All right, the other thing I did here was change a return successful return value of fetch from response to fetch results. Too long. In order to carry both the response and the possible connection if it's upgraded. That's an awesome git commit message, I think. I'm happy about it. Hi, and Kim Luke, how are you today? Typo implies. Oh, how could I have a typo and not see it? It's too late, I already committed it. My bad. Where was the typo? Impulse? Oh no! It's gonna forever haunt me in my immutable Git history. How's the beast? Where's the beast? Oh. The beast was on the beast tower, but he jumped off, and I'm getting scolded by my kids saying, "You could have turned the camera on, but now he's gone." I made two typos, really? Where was the other one? So the beast is okay. He's getting older. He's being picky about his food, but he's still going around. Where's my other typo though? Oh, right there. What's wrong with me typing implies? I messed up twice. Hey there, Atomic Nibble. And develop it. How are you doing? Develop it said something first. There we go. Can mend those fixes. Not after I push it, though. I'd have to force push it. I'm not going to force push just to fix some typo. It would be showing a bad precedent. Hey there, comma dev. My cat's about that old, yeah. About 16 years old, yeah. Going strong? Well, I mean, my cat's going strong except for his back legs. He just can't jump up as much now. And sometimes I think he's getting kind of senile because he'll like meow at me and it's like, what do you need? Do you need attention? Food? Do you need to use the bathroom? Do you need me to clean up the bathroom? His litter box? And I can't figure it out. And I'm like, maybe he's just senile. All right, let me get my bearings again. I think I want to take a break just for a few minutes. And then I want to go make a new crate for the HTTP server. So the complement of this. And then maybe play, or if I get that far, I'll play around by having the client talk to the server. Yeah, so I'm going to take a break for just a few minutes. And I'll use the break timer, I guess, for this. Break timer, yeah, just about 3 minutes. I'll be right back. Let's see if this works. Be right back. Hey there. Look who I got. It's a pooch. You might hear her from time to time. She loves me picking her up. Just kidding. She hates it. You might hear her occasionally barking at people. I know it's not a cat, it's a dog. We have a cat, a dog, and a snake. And you guys still haven't seen the snake. Hey there, Metalstorm. Alright, let's start a new crate. I'm going to go to here. Hit new folder, HTTP server. And I'm going to start by copying the cargo, license, and readme into here. Change the readme first. Server. This is a library which can be used to serve web resources using hypertext transfer protocol. So this word changes to server. I don't need it to say the REST implementation, do I? I should update this README based off of what I wrote in Pantry, I think. I have a more up-to-date text for that. Oh, we have a snake. Are you gonna bite me? Okay. Just in case you're squeamish, just fair warning, you're about to see a snake, so hide your eyes if you don't like snakes. Look at that. It's a snake. And he's not biting me. It's like, who's that? There you go. So now you have seen all three of our pets. You don't hear the snake too often. It doesn't really make a whole lot of noise. Read me. Yes, I think I want to just grab this one. He does? Okay, so apparently he sometimes wakes up our kids with farts. I didn't know that snakes farted. Terrifying? Yeah? Okay. Had to take their word for it. I didn't know a snake could fart. Yeah, it's a ball python, right? Ball python? Yeah. Sometimes I say the wrong kind of snake. We have a ball python. And he eats dead rats. It's actually a very difficult thing to get him to eat. More than you would think. All right, so yeah, ball python. He's a pretty snake. He's only ever bitten me though, right? Twice. He didn't bite you? No. He's only bitten me, and only because I had the audacity to pick him up to bring him over to his crate to get fed, and he was hungry. Hey there, Buff Seagull. The snake is pretty, especially after he's shed his skin. Before he shed his skin, he's not pretty. All right, so I just want to put some boilerplate here. The server type operates as an HTTP server as described in the RFCs. It maintains, we're not going to say it maintains a set of connections. It says it maintains a set of resource handlers. I think the rest of this is going to be not the rest of it, down to here, right? It maintains, right, we're going to rewrite this part. It maintains a set of resource handlers and a transport layer list, typically TCP listener. In response to incoming connections, the server parses data from the connections as HTTP requests and then represented by a request. Uses the resource handlers to produce responses based on these requests. Represented by a how did I split this? Oh, I didn't split it. I just need to copy this part. Response. Are we going to have an example program? Sure. Along with the library is an example program. What are we going to call it? I don't know. Some funny name that has to do with saying hello world. I don't know. Jeeves, which demonstrates how I'm not sold on that name completely. Which demonstrates how to use HTTP server. Greeting any web clients with a friendly response. Okay, and then server. Why did I choose to put that as a footnote but not these other ones? I don't know. Server. How does it look? Toggle open side. Good enough. I'll give it a closer look later. Same license, which is MIT. Okay, so this is not pantry. It is. So let's look at the corresponding one here. Right, server. Description. HTTP server for HTTP? Providing access to web resources? Sure. Oh, there's a dog barking at someone. That name's wrong. I wonder who's intruding, who's invading now. Hold on a second. I gotta go find out if someone's at the door. How could someone just walk by our house? The audacity of walking by and having to draw aggro from our dog. Okay, anyway, did I get the... I think I got the repository wrong here. How would I see that? I think I did get that repository wrong. Not got remote, get remote. Yeah, why did I call it web client? That should just be HTTP client. Good thing I found that before I published it. And this doesn't have to exclude anything because it doesn't have any C++ junk in it. All right. So this is HTTP server, no exclusion list required. And I don't know if we're going to have all this stuff. Probably not the pantry or the async trait. I'm wondering if I should wait until I actually need these to pull them in. Part of me says I should wait. Yeah, I think I should wait until I actually need these. I know I'm going to need that for sure, and that almost certainly. These I don't know about. I'm going to take them out for now. We'll need that for the example program along with... No, we won't need that. Yeah, okay. I'm happy. So, make a source directory with a lib.rs in it, and then we will start with configuration test, mod tests, use super everything. Okay, and then we need a test, right? So, just gonna start taking the unit tests I already made for the server, which was here. Bite him back to show dominance. No, see, our dog performs a critical role. She is like our early warning system for delivery people, for friends, for kids coming back from school, for the ghosts. You know, we might have a ghost in the next few days. You never know. All right, so server. This is just too much detail. Can I reduce it? What's the key for, is it K0? KJ? KL? K0, there we go. So a lot of these have to do with parsing, which I'm going to skip. How about this? Client request in one piece. Actually, I don't know if I'm going to... This is going to have the same problem that the client has, right? Where it requires me to mock the transport layer, which I really don't want to be doing. And maybe I don't start with tests. Maybe I just start with an API and make the example. Yeah, the example would sort of help us drive it. So yeah, instead of tests then, we're going to drive it with an example. And the way I learned to do that was example. Someone taught me that on the GitHub with a pull request, actually. Examples, and then we have our executable, which is Jeeves, right? Jeeves.rs. And this will have a main fun function. All right, and I actually want to have the same kind of shell of a main that I did in Rover, which is to handle control C's and have an asynchronous main. Sort of like rolling my own thing that Tokyo and async standard can do with an attribute. I just feel better doing it myself for some reason. So we won't need options, but I will want to have a server. And then we will want to make it, well, actually, this can have it serve immediately, right? If we tell it what port number it's on. The question, though, should I have it serve immediately? And then if I did, then it would require that I give it a port number, right? And possibly an interface list. How did I do this in C++? How did I do it? Oh, I had mobilization dependencies. A transport layer. Did I just delegate to the whole transport layer to do the bind? Yeah, I'm going to have to look elsewhere then. HTTP transport or something. Yeah, this one. What did I do there? Wire up? No. What's the API here? Okay. Give it a port number and a callback. Yeah, so it wasn't anything more than a port number. Did we bind all interfaces then? Where's the bind part? I guess it would be in this open. Open. I remember this stuff. This is like different between Windows and Unix. This is the Unix one. That means all interfaces, right? The third argument to socket. I suppose it should just look at the Windows one. Oh, no. It's bind that does that, right? Where do we put in the network interface? It's a socket address, right? Local address. Where do I set that? Where is local address set? Ah. Yeah, where do I set local address? What? Did I not set it here? Oh, there's a common impl. Yeah, I forgot that. It's been a while since I worked on this old library. Not POSIX, not Windows, but the common one. This one. Oh, it's passed in. Is that defaulted? No, it's not defaulted, so I must have missed it. Where do I didn't pin it, so now I have to go back and find it. So there's a big delegate. Oh, here it is. Yeah, so it's 0, which means all network interfaces. So I didn't bother to do that. I'm not going to bother to do it now. It's just going to be just the port number. Bind all network interfaces on that port. Do I put it in the new? The alternative is to have it be mutable and have like server, like serve or something, or start. And then either put the port number in there, or maybe server.port is 8080. There's like 3 ways I could do it. I'm not sure which one I want to do. With C++, I think I ended up doing it this way, where you set it and then you start, right? Because the bind network is called somewhere else. Yes, so oh no, we placed it was in mobilize. So it's sort of like the equivalent of this way. You do it in new. The problem there is, what if you started serving on one port number, and then without re-registering all of the resource handlers, what if you wanted to switch the port number? It would be convenient to say server.stop, server.port is something else, and then server.start again, right? It would be, if you did it in the new, then to change port number, you'd have to destroy the entire server and start a new one. I guess it could be in both. The new and be able to assign it. So, yeah, that would be a good compromise, right? For people who might want it to be in new, but then also be able to set it later. Sure, both. I just don't know what the conventions are in Rust. How, this seems reasonable to do it this way, so that you could change the port number if you wanted. That's right, Space4M, it's Rust. How are you doing today? Okay, so if we're going to do it this way, I don't need to change the port number, it's just start. And then, actually, before we start, we're going to want to register a resource, right? And I think I'll just do it with closures. So I'll do it the same way that the test did it. Where did I put that? Here, I think. Where did I put the delegate? Oh, thank you for the follow. I appreciate it. There should be somewhere where we take the server and we give it a resource. Oh, this is where it's not registered. Okay, so where would the actual registered resource be? Oh, down here. 2 pieces, 1 piece, invalid request, connection broken, host missing, all this junk. Would it be in these then? Ah, right, I remember this. It was first make a request before it's registered, expect 404 out. I don't need to do this in a unit test, right? So I just need to do this in the example program. So this is it right here, register resource, right? So we gave it a path and then a delegate. So then path, question, do I leave it as a binary string or do I do it as a vector of segments? What's more convenient? In C++, I left it a vector of segments, just because I could. I mean, either way, it doesn't really matter, right? Because I could either split or join if I wanted to. We'll do it, I want to do this. If I want to do it as an array of segments, how would that work? Array foo, just like I was doing there. And then a closure of some kind. And what does that closure look like? Right, request in connection and trailer? Why was that? Why did it get a connection? I know why there's a trailer there, because if it's an upgraded connection, oh, that was why. We're given the connection in case we want to tell the server to upgrade it. because the resource delegate is supposed to take it over. Yeah, so how would I do it here? Well, yeah, we need to get the connection. I think we'll get the connection in and we'll return the connection back out if it's not upgraded. I think that's how I want to do it. Why would you change the port in somewhere during runtime, and why wouldn't you just recreate the server struct in such a case? Like for my game server, for example, there are cases where you tell the game server, please switch to a different port number, and I don't want to have to go through re-registering the WebSocket closure. I just the which port you serve you allow incoming connections on, it should be independent from everything else, right? TCP listener uses to socketers. Okay. We'll find out what I have to put. For this closure, though... Actually, what if I just make it a function? Because that'll work, right? Function... handle request. And I'm going to need to be pulling in some dependencies here, right? We're going to want to use RimaWeb. Does not pull in RimaWeb? It doesn't. It does. So how come I don't have this available to me? I'm confused. Shouldn't I be able to pull in request and response? Maybe because it's not parsing completely yet. Yeah, okay. I don't know why the autocomplete didn't help me there. Request is a request. Only connection too, right? Because connection is a boxed DINE connection. Yeah. And then the trailer, right? Vector of bytes. And then what it's going to return is going to be, are we going to allow an error here? I don't think so. I think we're supposed to produce a response always, right? But you might also give back the connection if it's not an upgrade. Yeah, that's another reason why you might want to change the port. If you tell it to start serving and then you can't bind the port, you should get an error. And then you'll want to go change the port number and try again, right? I think I want to return more than one thing here. So it would be, what name to use? I can't think of a name. I need to define it here, though. Pub struct something. Something is going to have a response in it, so we need to use RimaWeb response at least. Response. And then also connection. But in this case, you're not stopping serving, changing port, and starting server again mid-run. You just failed to start serving. That's true. But what about the case where you're able to bind the port, and then for some other reason you change the configuration for the port number, but that's it? Do you ever use SQL table joins? I do not. You're just learning what they are? Okay. Would be considered advanced? I think it would be considered advanced. When you start to get to table joins, I think that's you're getting to the more advanced stuff. In Rust, you can make a token type to ensure functions are used in the right order. I didn't know that. Huh. Typical REST API would have a server builder allowing you to set and mutate a port. I've seen it both ways, where you can either make a builder or you can just change its configuration on the fly. Hmm. This is going to be the connection back, right? Box, dyn, connection. Actually, box is in the prelude? I can't remember these names. It's already included for us, right? So I just need a name here. Resource results. How about fetch results? We already have a fetch results in client. Well, it's the same thing, right? We're fetching on the server side. So this is use Ramu web server fetch results. And this is always going to succeed, right? I don't think it's fallible. Yeah, it's fallible. It's infallible. All right. And so handle request. I suppose we're going to then go to the futures. Okay, I'm gonna need futures then. Futures. Futures. What was it? Pending. I need pending. Futures, future pending. Oh wait. Basically, never complete the future, but let the server run forever. For just this basic example, it's going to run until you hit Control C. All right, and this is not compiling Y, probably because I don't have an entry for it in my cargo toml, right? Or do I? I don't need it. I don't need one, right? No, I don't need one. So why is it not building Jeeves and having a problem with this? Oh, I know why. I didn't include in the workspace. The moment I do that, it's going to have a fit. Now it's going to have a fit, right? Yes. Okay, so I misspelled connection. Apparently I didn't export it either. Wait, I did? Why does it think it doesn't exist then? Why is it unresolved? It is resolved. It's right here. Okay, maybe I need to do a cargo clippy to find out. No connection in the root. Oh, wait. It's my bad. The connection was from client, so we need our own connection type. Yeah, this is a server-side connection, so it needs to define it. Not there, but there. Okay, so we need to bring in the same traits that the client brings in from futures. We're not using read and write xt yet, but I probably will soon. And then while I'm at it, I should pull in this stuff. All right, and then what's this warning? Field is never used, but it's public. All right, okay, getting there. So server doesn't exist. Let's make it exist. So struct, pub struct server, nothing in it. Impl HTTP server. We'll at least need a public new function. We already said we should have a port number here. Should it be optional? Should I always force you to set a port number? Actually, now that I think about it, do we want to support both TLS and non-TLS? with the same server. So that would mean I might want to serve on multiple port numbers. That would imply that rather than having one port, that we have a way to add a port or remove a port. I don't really need that though. It should just be one or the other. Would bind be a better name? Yeah, maybe. Rather than just new. And maybe it would, well no, I want it to be independently bound. So start is sort of like bind plus start, bind plus serve, or bind plus listen. I don't think I need to have a state where it's bound the port but not listening. But I was just debating with myself whether or not to have multiple ports. But yeah, if we have one port, we should say whether or not to use TLS, right? So, do I keep that a Boolean? I hate making Booleans, but I think I will for now. So let's make it false for now. Yeah, maybe I'll come back to this later and support multiple ports, but right now it's just gonna be one port. So it's gonna be port, which is a U16, and then use TLS, which is a bool. Self. And that should have worked. Oh, there's no server because I didn't pull it in. Okay. All right. Why does it not complain about register? Probably because of this select. And that comes from where? Oh, that would be in Rover. Where you select, right? Yeah. Futures. And also Control C. We need that too. No connection from there. We're not using response yet. Oh no, I do want connection from there. But no, not from there. From here. Yes, okay. So then, yeah, we don't have a register or a start. This should have compiled though. Oh, I need to another use around future extension. And I think I'm going to collapse these. I'm starting to get into this habit of collapsing these. So like this instead of those two. Cool. So now we're down to, we just need a register and a start. Start's easy, right? Start could fail, so let's do a match on that. Yeah, match, server start, sum, or okay. Then wait forever, right? Otherwise, how do I print errors in Rover? Like this. Actually had a pretty elaborate way of doing it. And I'm doing that, yeah, I'm doing it in a similar place, so just paste. So it might have a source, it might not. Okay, so then start is a synchronous one that could return a failure. Serve. Serve result unit error, which we need to make our own error thing, so that means I'm pulling in another module. I'm doing the modules before I do my uses, right? Mod error. That's a... Oh, right. I'm doing mod error and then using my own stuff, right? Pub use error. Pub use error. And we'll just seed it with the client's error type. So that's here. Copy it to there. All right. So the only error I need to handle so far is what? Like bind failure. Bind failure. Bind. So the root of that's going to be a standard IO error, right? Unable to bind or listen to the transport layer port. And then get rid of all these other things. This is enumeration for all different kinds of errors which this crate generates. The server could not bind. Why don't I just repeat the same text? There we go. Okay, catching up on chat. Hey there, Dr. Padawan. I'm doing well. Hope everyone else is too. If you actually need to explicitly reconfigure the port mid-runtime, you drop the old server and make a new one, right? I just like the idea that we can make it independent. Would bind be a better name? Yeah, I'm not sure. I like start. I'm partial to the word start. Or mobilize. Sometimes I use that word. Okay, why am I getting this now? Oh, because we're not returning it yet. There we go. Alright, and what's wrong with this? Must use, yes. You must use the server if you make one. And these we don't use yet. Alright. We'll wait and see if we need those traits. Back to Jeeves. Start. Why is it not working? Probably because this needs to have a mutable self. Yes. Okay, so, why does it say boxed error? Oh, it needs to be in scope. Okay, so, I remember doing that for Rover. We had to pull in standard error as with no name, because we don't need the name. Like that. There we go. All these little things that I just pick up and I have to carry over. So now we just need register. So then, pub function register, mute self. And then we'll want, let's just define a type now. Type resource handler equals function. Should we allow it to mutate itself? Why not, right? It should be given the request, right? And return, actually it should be given a request and a connection, just like this one does. Actually, it should be given all these things. So, yes. Can you guys hear all the racket in the background for me? People are like yelling at each other. Yeah, this should just do all of this stuff, right? Do I make it public? I think I might have to. Oh. Do I have to box this all? Okay, request comes from here. There, PhD horrible. Yell back. I do sometimes. You're arguing with another. I think they're washing the. Are you guys washing the dog? Hey, who are you washing? Dog or cat? Or snake? Hey! I don't want to say their names. Hey, who are you guys washing? The snake? Okay, they're washing the snake. I don't know why. Yeah, the dog's right there, actually. I know they're not washing the dog. Now that I see that. Okay, anyway. Too distracted by people washing snakes, apparently. Yeah, I didn't know that was a thing either. I guess the snake likes to take a bath every once in a while. I think it's a big thing because they haven't done this in months. Well, they smell. That's probably why. They're probably like, wow, this snake smells horrible. Let the snake float around in the water. An example of a token API. That's useful. Let me give you a point for that. I want to learn about this token API stuff. Obviously, I don't know how to use it yet. Right now, I'm just going to do it without that. But yeah, maybe we add tokens to this in the future, like that you... Well, the way I have it now, you can't call anything until you have a server, so you have to call new first. And then you could call start without registering anything. That's fine. And in fact, I also want to allow registering something after you started. That should be allowed too, right? So there really is no order that I need to enforce here. So this is resource handler. This should be boxed, right? And this should be infallible. Oh no, I need a path too, right? Path, which is a P, because we want to be flexible here, where P is a reference to an array of vectors of bytes. Actually, if it's going to be two-dimensional like that, do I care? Might just require into vector? Yeah, it needs to take it over anyway. It should just be into vector of vectors. All right. To do. Register. Why do you not like register? Oh. That? Do I need to do the weird slice thing again? Maybe. Oh, and there's also I need this B in front. I think. Thank you for the follow. Trait bound vector of vectors convert from... Okay, it's because it's a fixed size thing again. Dang it. I hate the weird syntax stuff I have to do with binary stuff. Can't I just do the other trick? Foo as bytes... Or do I need to do a 2vec also? And now it's happy. Do I have to do the 2vec? No. Yes, I do. Okay. I'll have to figure out a better way to clean that up. You guys want to be on stream? Keep yelling. Why doesn't it like handle request? Oh, I need to box it. Do I need to say boxed? Or just... Oh, there we go. Box that guy. Cool. Okay, now it says literal a string. Yeah, we don't care about that. So allow that guy. Alrighty. Box for new tires. What is box? If you're interested in what box is, it's a way to take a value and make it portable by making sure that it's managed on the heap instead of the stack. So once it's boxed, you no longer need to know what its exact type is. You can handle it through a trait object, which is what I'm doing here. This resource handler is a dying, which means it could be any type which implements this interface or this trait, right? fn mute is a trait, so any type that can implement trait will fit this dying fn mute. But because it could be any type, we don't know the exact type, we have to put it in a box. The box holds on to the pointer to the thing and also its size, because it also has the side effect of it being on the heap, I think. Let's see what it says. It's for heap allocation. But I think the side effect of that is that, yeah, it doesn't need to be sized. It holds on, it figures out where it is based off of being on the heap. Actually, does it internally know the size of what it is? Maybe it does. I don't know too much about box other than it's convenient for wrapping things, which are types that you can give it to a function that needs something that implements a type but doesn't need to be any specific type. The expected lifetime of the handler function probably need to be static. Yeah, I probably need to refine this at some point. It's probably going to complain to me about it not being static, right? So I might need to do like how do you do that? Is it like for static? I forgot the syntax for that. Or do I do a do I have to say like plus static here? No, I forget how to do this. Or is it just you put it here? And the plus goes with the dyn. Maybe that's how it works. I also need it to be send. Where's the inlay hints? I don't get an inlay hint for that? Well, that's a bummer. No inlay hint. I hope I have that type correct. I want the plus send and static to go on this whole thing, not this one. Yeah, it doesn't make sense for the plus to apply to the return value, right? The plus applies to everything here. Yeah, I need it to be send because we're going to give it to another thread, and it needs to be static. I probably need to also say it's unpin, right? Just like do with connection. Hey, let's do it. Should we do it now, or should I wait until it's necessary? You know what I'm going to do? I'm going to say we probably need that, but we don't know yet. I want the compiler to tell me when I need that. It's set up correctly. Hey there, Actin Dev. How are you doing today? Premature optimizations and all that. Yeah. Premature trait constraints. Let's not put them in until we need them. Yeah, because I'm not doing any... I haven't implemented that part yet. But I think Jeeves is... This is all we need to do a basic web server, right? We create a server, we register a handler, and then we tell it to start, and it might not be able to start, but if it does start, we just let it sit there serving, because it's going to serve through a worker thread. I could alternatively have a serve which is asynchronous. I don't know, which is more flexible? Have the server run its own thread so that start is synchronous and it just happens in the background, or I can make it called serve, which has to have an await here. Right? And then I don't need to do this at all because it would only maybe break out if I tell it to stop. I guess it could be called start either way. If I make it a future, then I get to control the context in which the server runs, right? But if it's synchronous and in the background, then servers can control the thread context. Do I care? I don't know. What the handler does, it's going to return what response to give. It's easier to show here, I guess. What response to give given a request. So if the request is like, get me foo, the response will be 404 not found. That's what a resource handler is. Like you can imagine like in a real web server, a resource handler for a request that indicates a file on disk would go open the file, read the file, and then compose a response where the body is the contents of the file and the headers are like what kind of file it was, how long it was, that kind of thing. Neither one is going to rob you of any flexibility. Okay. And hey there, Ginger the guinea pig. Weak, weak, weak. I used to have a pet hamster. I never had a pet guinea pig, though. The hamsters made a similar noise, though, sometimes. Especially if you pick them up and they didn't like it, and then they try to bite you. Oh, the good old days. Okay, so, I think I will, just because I'm more comfortable with it. I'm going to go with a worker thread, which means that it's synchronous. That means in our main thread, we're just going to sit there and wait forever, or basically until you hit Control-C to break out of that select. All right, so just to get something runnable, let's have start do nothing. Just say it's okay. And we'll have register do the same, I guess? Well, this doesn't need to do anything, right? So it's runnable now. I can run example Jeeves. Doesn't need any parameters, it just run, right? Okay, now it's running, and I hit Control-C, and then it escapes. Okay, cool. Cool. So, a couple things we need, right? We need start to do the bind. Maybe we do that first. That's easy enough. I just need to do some research really quick to learn how to do a... I want to look at it from the perspective of async standard. So, pull that up, and I want to look at... I think it's TCP listener, right? Yeah, so I'm going to want async standard, just like I have in the client. Yeah, 1.6 is the current version, I think. And we're going to use it up here. Use async standard net TCP listener. Okay, let's make it. We'll need to have it here, right? Yes. In fact, if you call start twice, it should say, hey, I already have a listener for it, right? So I should put it here. Listener. Option. Right? And I'll have to learn how to do that with TLS. I don't know how to do that with TLS yet. Oh, wait a minute. I think it doesn't matter for the listener, right? It's once you have the connection established, then you attach TLS if you want it. Yeah. That means I'm gonna want TLS to be in here. And then I might as well just pull it in now. And then listener is none. Actually, I separated. Why not put the port with the start then? Yeah, why? You guys are probably telling me about that and I just wasn't listening. I don't need the new to have either of these, do I? Yeah, just make it part of start. Yeah, why not? Yeah, it's mutable. Start makes it mutable anyway. So I can just say self dot that equals whatever. Port use TLS. And we don't need that. Listener is none. Actually, oh, that could be an argument to the worker thread that we're going to spawn, right? Yeah, and we don't need to do that. I do need to include it, though. Port U16, use TLS bool. All right. So yeah, don't need to store it. Okay. New gets nothing. Why am I getting an error here? I didn't supply. Okay, I just need to hit save for some reason. Okay. Should I have... Okay, I'm actually not done with Jeeves. This actually has to make a response. Should I cheat and look at what I did in my unit test to make it easier on myself? Yeah, so it's just set to status code and reason phrase. I didn't even bother with the body? I could put a body in there though, right? Why not? So, let response equal response new. Response status code is 200. Response dot reason phrase is okay. Probably string from okay, right? And no? What's reason phrase? It's a cow. Why can't I do that then? Okay. Why can't I just say okay then? What's the deal? Do I have to say into? Okay, and then fetch results has what in it? Response and connection, right? Response, connection. This needs to be mutable right here. We're not doing anything with the trailer or the request yet. Actually, yeah, I'm not going to do anything with either of them right now in Jeeves. It's going to ignore the request. It's just going to say okay for all of them. Okay, so response dot body is hello world. And I might as well set the type, right? Response header set header content type is text plain char set equal UTF-8. And this needs to be binary, right? Or did I make that? Yeah, I didn't make it binary. So as bytes. It didn't like that either. Why not? Because it's a vector. 2vec. I'll need async TLS to do that? Yeah, probably. Hey there, RazorX and Rylex. What's the difference? I'm missing the context for that now because I've gotten too far. And move back to you, RazorX. Sorry, Rylex, I'm not sure what's the difference was for. Can you remind me what I was talking about when you typed that so I can answer the question? Otherwise, I'm not sure what you meant. So there's just a basic response. It's just going to say hello world to any request we give it. If we send it to foo. All right, so then let's do the listening part first. Difference between hamster and guinea pig. Oh, hamster is much smaller than a guinea pig. That's the main difference from what I remember. Like a guinea pig could be as massive as like 4 or 5 hamsters put together. They're pretty big. Guinea pigs are almost as big as small rabbits. They don't die of loneliness if you have 2 of them. One is hellspawn. I never owned one, so I wouldn't know. Okay, so before doing okay, we need to get that listener, right? Let listener. Actually, is there a reason why I even put it there? Why can't the listener just be owned by the thread? I've already decided I'm gonna have a thread, right? So might as well just pull that in. Just like I did for the pantry. Why did you string as bytes to vec instead of b string to vec? Did I silence a lint about it? I don't know what lint I might have silenced. Oh, this one? Maybe because I'm dumb. Let's see. So you're saying I should have done this? Oh. Okay. Was it this warning that was... It wasn't even that warning. I don't know what that warning was. I don't know why I needed that. No reason. No reason, Silmith. So I'm going to give you a point for correcting me. I stand corrected. Is it because crate wide I'm suppressing it? No, I'm not. So... Oh, it's because this is a short string. If we make it longer, it has a problem with it, right? No, that's not it either. I don't know what it was. I've already lost the context of it. Warning about a similar case else somewhere else in the code. Yeah, I don't know. Well, now that we're not allowing the lint, if it comes back, right? Yeah. Okay. I need to go find my pantry. Find my pantry. Silly phrase. And yeah, we're gonna pull in standard thread just like that. Use standard thread. Blah 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 blah. Older code, it would not work because methods and traits were not implemented for longer arrays. Yeah, that's why I tried to make it longer just now, and that's what I thought it was, but it didn't actually do anything. It didn't become a warning again. I don't know why. I'm gonna have the listener be owned by the worker thread. Yes. And we'll just make one in start, which means we'll have to have a check. If some don't care equal self dot worker, then return error already started. Already started. The server cannot be started because it's already running. You need to stop the server first by calling stop, which is a struct.httpserver.html method.stop. Hopefully, if I got that right. Well, thank you for the follow. I appreciate it. Cannot start the server because it's already running. This could be a code smell, and to indicate that, like, I'm having to cover this possible flow of calling start twice. That should be solved a different way, like what Ereld was saying, that if I use a token API, maybe like you can't call start unless you have a token that allows you to call it, right? So when I go learn about this, it's possible that I might get rid of this error because maybe it's not possible to get that error anymore. But for now, I'm going to leave it in there. Why is it not letting me do this? Expected bool? Oh, let. And I don't need to do this. I can just say if it's some, right? Is some? Yeah. So it won't be some, so we can now assign it. So that's how, like, I did it now. Thread spawn was what I did, right? Yeah, exactly. I just do this. Self.worker equals that. Some thread spawn executor block on. Okay, so executor comes from futures. Executor. All right. We're going to give it all of our arguments, actually. So this is too long. Let me break it up. Sure. Continue breaking there. I can put this all in one line, right? Port use TLS. There we go. Actually, no. I should get the listener first and not spawn the worker thread if we couldn't bind the listener. You can also make a separate builder or server config struct the start would consume. Yeah, exactly. One of those might be better. I'm just thinking, like, when I get to this point where I need a special error to cover that, this is just a code smell in Rust, right? We shouldn't need that. We should let the type system handle that. But I'm too lazy to do it right now. I could just look at it as an opportunity to my future self to do some satisfying work. I've left a little thing to clean up later, right? Yeah, stop could give the config back. That's a good idea. Let me give you a point for that. And I need to add that note onto your other note so I don't forget. Because I've been doing that for the connection thing, right? In order to use the connection, you have to get it back out of where you left it, rather than seeing if it's in use by something, right? You just try to get it if you don't have it. Okay, so I need a worker thread, and it's going to get a listener, actually. We're going to make a listener now. Let listener, TCP listener, bind. Okay. Now, if we have a port number only, I'm going to look up how I'm supposed to get the socket address from just a port number. They probably have it here. So this is one way. We could just hard code the localhost address, but maybe there's an easier way. Maybe we look at all of the implementers of 2-socket ADDRS. How about incoming? No. Wait. Stream of incoming connections. What is this? How does that implement I click on the wrong thing. I definitely clicked on the wrong thing. Implementers. No implementers? Implementations. Okay, so IP address, string. There ought to be one for just port number. Maybe we do have to hard code the localhost address. No, it should be the 0 address, shouldn't it? Token hack is neat too. Yeah, I like the idea of the token hack. That's using like a new type, right? Or a phantom data? One of those really nifty things that are new to me. I'm surprised there's no way to form a socket ADDR from just a port number. Like, why? The convention with TCP is that if you leave the address all zeros, it just binds all interfaces. Is there not a way to do that? Maybe I just need to Google search or Bing search this. Rust TCP listener bind all interfaces. Maybe it's protocol specific. Here we go. Someone's asked it. Of course someone has asked it. What's the answer? Just bind to the IP address any. Okay. Actually, I know I will need to do that because I was playing with some code the other day which it only binds IPv4 address any, and it refuses IPv6 connections. So we'll probably need to do both. We'll have to have 2 listeners for both protocols eventually. Okay, so it's IP address any. That's what we'll do. Should I uptick that one? Because it was helpful. I need to sign in. I'm not signed in on that window. So it's just, I guess we'll have to search for what namespace it's in. IP address, right? It's in the standard library? Am I in the wrong language or something? Oh, yes, this is not even Rust. What language is this? .NET? Okay. Well, you would think that Rust has a similar concept, right? Maybe I just need to look at IP. I need to go back because the type was there. IPv4 ADDR. Do they have an all? They have localhost unspecified. Is that what I want to use? Unspecified? Because that is what I want, right? I think that's what I want. I want IPv4 address unspecified. What namespace are we in? Async standard net. Okay. Async standard net. We want IPv4 address. I'll do IPv6 some other day. All right. Bind IPv4 address unspecified. All right, and then is not satisfied by an IPv4 address. Oh, do I need to give it a port number too? Probably. That would make sense. I didn't like that either. Perhaps I should look at bind. Or to socket address. I do need to await it, so hold on. I'll need this to be inside an async block, won't I? Yeah, so let's do that. Async block. We can just do this, right? And then it might have an error, so we'll handle the error outside, I guess. Map error to error. I had something for that, right? Bind. Question mark enter. Okay, but I don't have this bind yet, and I don't have the worker done yet. Yeah, but I guess this is not how you do it. Oh, does it need to be a tuple? Maybe it needs to be a tuple. There we go. It just needed to be a tuple. It must be implemented on the tuple. I bet you that's what it is, right? Yeah. Look at that. It's implemented on the tuple. Sneaky. What's this one, though? Either IPv4 or 6? Can you do that? What happens if I bind to that? Ooh. Hey, let's try that. I'd love it to work for IPv6 automatically. Yeah, why do we need to be IPv4 biased? If that'll work, that'll be cool. I can't use unspecified, though? Maybe that's a problem. Oh, because it's an enum. Okay, then I can't do it. I'll probably need 2 listeners eventually, one for each protocol. Right? Use IPnet. Is that not better? What's IPnet? I don't even see an IPnet. Oh, that's from a crate. Do I want to pull in other dependencies? I'm trying to minimize dependencies. What does this dependency IPnet do? Usefulness to working with IPv4 and 6 addresses, IP prefixes. And what's IPnet do? Represents a network that... It's the same thing. It's the same thing as this one. It's, where is it? It's an enum. It's the same thing. I wonder if IPnet predates its inclusion in async standard and probably also standard as well. Because why would they bother replicating that type? Oh, it's okay, Dr. Padawan. I don't mind at all exploring other crates. So now I know what IPnet is. I'm wondering is it an old crate that's brought into the standard later? Oh no, it's still up to date. Why would you need it then? Oh, they build in the existing ones already in the Rust library and align to stay consistent. Okay. So it's just adding extra stuff. Okay. Good to know. I'll give you a point. Really? You never had a point on my channel before? Here, have another. Colon binds to 4 and 6? I didn't know that would work. I guess I had the assumption that you need 2 listeners. I guess I can look it up, though. That would be an easy search. Bind to both IPv4 and IPv6 with 1 listener. Is such a thing possible? Oracle has something about it. C++. That's probably going to use WinSock, right? You should always bind both sockets explicitly. Why cross-platform compatibility? Okay, Windows by default requires that you explicitly bind on 4 and 6. Binding only to 6 will not implicitly bind to 4 as well. But does that mean that you have to bind it with one socket? Or this says both sockets. That implies you need 2 of them. Okay, so on Linux you can do with one socket? Huh. Interesting. Some platforms do not support accepting 4 connections on 6 sockets. So for maximum compatibility, which is what I like, go with the 2 sockets approach. Thank you, Simon Richter. So that's probably what I'll do for a maximum compatibility, unless Rust takes care of it for me. I'm giving away points to people who contribute to the stream. If I forget to give points, and you feel like you've contributed to the stream, let me know. All right, so that should bind to the IPv4 address. Let's have a dummy worker for now. I just need a worker. Oh, I'm gonna need to be able to tell the worker to stop. So I'm gonna need the same kind of mechanism I use in the pantry, right? I'm gonna need an MPSC channel. Maybe a one-shot also. I don't know. I'm gonna need an MPSC. And I'm gonna need to give that to the worker. In fact, this is the signature for the worker, pretty much. Yeah. Sure. Yep, right here. I don't need these K's and V's though. Not yet, at least. I might need them in a little bit. How do you give your points? It's like gift, I think. But you have to gift it to another user. But be careful, that command is broken. Listen to all interfaces with TCP listener solved? Solved? I like solved. Oh, and it's a Rust specific one. Thank you, Dr. Padawan. Yes, it's called dual stack mode. It's somewhat platform specific. If you're on Linux, it's enabled. You can try binding to the any address for 6 and it'll still listen for 4. So that kind of corroborates what we read in the other Stack Overflow post, that it's platform specific and it'll work on Linux probably. Yeah, well, I'm specifically from TCP, how the protocol is designed, if like actually it's not how it's designed, but by convention, listening to that will allow you to receive connections on every interface that supports that address protocol. This means it'll only accept a connection on the loopback address, so it won't like receive an incoming connection even from another computer on your LAN. Whereas this will receive it from localhost or your LAN or the internet if it's open on your firewall. Okay, I don't have a worker message yet. I want a similar enum though. I think we'll just start with the stop. Remove the K, this tells it to stop, and that'll be our only variant for now. Okay. And then it'll have the same sort of structure to start with, right? It's going to just do a, does it need to do anything more than handling messages? No, it should also handle the futures we give on listens. So I need a similar approach, I think. We'll need to handle messages. Select, I need to pull that into. Select comes from where? I don't see it. Oh, is it futures ext? Probably is. I bet you it is. So, yeah. Oh, no. Well, now it should be a different error, right? Yeah, if I don't pull in futures ext, it probably has a problem with select. Oh, no. Never mind. We don't need futures ext. So I need to handle messages. We just have a receiver for now. I'm gonna just leave that case out. I'm just putting the structure here because I know I'm gonna have more work for the worker thread to do. We'll have the same kind of handle messages approach. Let's just steal from previous work because that works so well, right? I think so. No KV, no pools. We just have a worker message receiver. No traits. We only have, oh, there's where we need futures ext, I think. Yeah. Futures ext. No? Future ext? Never know when it should be singular and when it should be plural. Okay, that wasn't it? I'm confused. Okay, that's definitely undeclared. I think I need to have future there. Yes, so what's take while need? Trait was not satisfied, that's the problem. I don't get that error. Okay, maybe it might be confused by these other things, so I'm just going to remove. I need the for each actually. But the only possibility is stop, which is unreachable. For now. No, it still has a problem with the take while. Why? No method named take while found in struct. That, in the current scope, it exists, but the following traits were not satisfied. Oh, perhaps add a use for... Oh, it's stream extension. Okay. I hate it when it does that. I should never let it do that. It messes up my formatting. Stream extension. Oh, thank you for the follow. I appreciate it. Is this gonna just complain because it might outlive in a borrows message? Wait, what? I never got a problem with it here. Why does it say it's borrowed? I don't actually think we need that yet. I'll just comment that out and it should be fine, right? We should never actually get into the for each. We're only doing this syntactically to produce an output that we're going to wait on, which is a unit output. Okay, so then what's wrong with this one? Oh, fuse needs what? Sometimes you can't get all the information in line. You have to do this in a terminal. Futures ext. Okay. I knew I would need that at some point. Future ext. All right, now what? Yeah, it's worker, not listener. Okay. Yeah, and then we have to give the listener... Actually, it's more than listener, right? But yeah, I'll need to at least give the listener to the worker. And I don't think we'll use it with handle messages, right? That's going to be more for like registering a new resource. Yeah, so okay. We need the listener and we need the receiver. So this guy, we have to make a channel. In fact, I like that comment so much, I'm going to copy it. Store the sender end of the channel and spawn the worker and giving it the receiver end as well as the TCP listener. Receiver. Okay, and then we need to keep the sender for ourselves. So where do I put that? I guess I also need it to be an option. That makes me think I ought to have a structure for it. Struct HTTP server, like worker variables. I don't know. Worker, for a better, lack of a better word. And then this moves into there. So join handle, and then this goes there, and then I have our sender, which is I'm going to call that. I called it work in, I think. Yeah, just call it work in. It's an MPSC unbounded receiver of worker messages. Yes. Okay. So then it's this assignment that's a problem, right? Right. So some server worker, and then the worker, the join handle is this, and the work in is the sender. Other way around. And did I get it backwards? I did get it backwards. We keep the sender part. They get the receiver. Right. Okay, so I should add a well, not gonna add an explicit stop yet, but what I do need is a drop, right? If they drop it. So implement drop on HTTP server. Gonna drop the server. What do we do? 4, right? What do we do when we drop the server? We have to see, why don't we just call stop, self stop, unwrap, or unit, just to ignore any errors, and we can have an error here. Pub function stop, mute self, returns result, unit error, and the same kind of thing. In fact, here's again that code smell, but that's okay. Can deal with it. This should say if it's none. And I really ought to do this with a match then. Match with a take. In fact, if it's some worker, then we got to stop it. Otherwise, if it's none, we it's error already stopped. And to do here, I'm not going to write that just yet. I need an already stopped. That's not declared, is it? Similar to already started. Okay, the server cannot be stopped. It cannot be stopped because it's not running. You'll need to, well, I don't need to say that, right? That's obvious. Okay, the server cannot stop the server because it's not running. Okay. All right, no errors. So this drop makes sure we stop the server. Stop should be what we do in the pantry when we stop in its drop implementation, which is to join the thread. Tell it to stop and join the thread. Okay, so that's I can just unfold this, right? The worker is the work in and the join handle. So we can remove the self from it. This has to be mutable though, right? Pretty sure that panicking inside a drop will just flat out abort the process. That's another good reason to unwrap, right? I mean unwrap or. It's basically catch the error and snuff it out, ignore it, right? What did I do wrong here? Is that not how this works. Do I need to say that? I don't think so. I think this is just wrong here. Suspected semicolon. Maybe I do need to say that. Then the overall problem is we need to put it in an OK. Okay, yeah, because I don't have the OK here. Yeah, there we go. It's okay. It's okay. Actually, wouldn't it be better just having OK if we get all the way out there? I don't need to take the worker because we already took it. Unwrap, we need... Why did I have an unwrap there? Is that because this take is an option? Yeah, it's an option. Okay, yeah, so we already did the unwrap by having a match. So just join and unwrap that. This should be join handle. Perfect. And what's wrong here? Oh, yes, this needs to be an early return. Because either I need to do an early return or I need to move the OK back in there. I think I'm going to move the OK back in there. Then we do that. Then we do that. All right. So it's either already stopped or we have taken out the work in and join handle and we tell it to stop and then we basically block until the worker thread joins us. Yeah. Actually, I can't ignore you, Sarian, because you and a bunch of others have a lot of good advice for me. All right, so not using TLS yet. Correct. Maybe use it in the future. Okay, so this should start and stop and sit there and do nothing. So it should be safe to run, right? I like to just run these just to make sure that nothing panics when it runs. Oh, we do have a panic. Can I execute local executor within another executor? Okay, I must have called block on instead of a block on. Right here. Not there. I don't have a backtrace, but I could probably find this, right? Where do I have a block on? Start. Oh. That's the problem. I should just make this asynchronous. Because Jeeves is calling it an asynchronous, it's calling start asynchronously. Yeah, so this should be an await. Because this should be an async. And then we don't need to block on. We just do that. What was the reason? Is it async has to go after pub? Yeah, okay. We're cool with it now, right? So doesn't that imply stop should also be async? Stop is a problem because this join blocks. Is there an asynchronous join? If it's so, it would be here, right? Well, that would imply that there's a asynchronous thread, but there isn't, right? That's for a task. I don't think that there is. Come I don't... Oh, here it is. This is going to wait. How would I make this asynchronous? I would have to spawn another thread, wouldn't? Or another... I would have to spawn another task, wouldn't I? Spawn a task that blocks until... that waits for it? Or I could just keep it synchronous. No, that's a danger though, right? If like if Jeeves were to call stop, it should be asynchronous. We should fix that. Let's fix it. So if that, to make that async, I can't do that there. To make this asynchronous, this would need to be done in another task that we spawn, right? So this is where I think I would need to pull an async standard. and use its facilities. This, I haven't done this before, so this is going to be new for me. Is it just task something? Ah, task spawn. That's what it is, right? It's detached from the current task. It means it can outlive its parent. Doesn't mean it can block and not block the... Actually, I don't want it to be a future. I really do need it to be a thread, don't I? Oh, this is a conundrum. How do you asynchronously wait for a join handle, then? I should search for this, then. Unless I'm thinking of it wrong. Rust, asynchronously wait on thread join. Okay. That's .NET. How about asynchronous thread join? You would think someone would have had this problem too, or maybe I'm just not thinking of it correctly. Does this even make sense? Am I thinking about this correctly? Thank you for following, even though I'm not able to figure this out right now. I don't think there actually is a way. You know what? Another option would be that we just tie the lifetime of the worker thread to the lifetime of the server, and then stop doesn't actually tell the doesn't actually stop the... Yeah, I think that's what I'm gonna do. Thank you for the follows. I think then, yeah, I'm just gonna have just like the pantry did. I'm gonna have the worker thread start right at construction time, right here. So that means this is it's still an option, but it doesn't start out as none like we did there. How come I can't find new? Because I'm in the wrong place. I need to go to pantry here. Go to new. Yes. So yeah. Okay. So then what I did in start needs to move. Some of it needs to move. So I can't start the worker with the listener because it'll be started before we have a listener. So that means I'm going to have another message to pass a listener over. So we'll do this. So instead of self worker, it's just, I guess we'll just for convenience do this. And then have worker there. Actually, I could combine that. Just do this, and then have a colon. And like that, and then the comma. That works, right? We just don't have a listener yet. Are you a Golang developer and you want to start learning Rust in the future? Ah, hey there, Windy Twitch. When you want to learn Rust, it's really easy because you can do Google search for Learn Rust, not Rust Learn. And the very first link here past those other ones is the starting point. That's where I started like 3 months ago. And they give you different paths. You can read the book, which is sort of like geared towards learning it by increasing concepts. Or there's the Rustlings course, which like I think is working through examples. Actually, I don't know about this one. I know that the Rust by example is like example focused, whereas the book is less example focused, more conceptual focused. But yeah, I guess there's this middle of the road approach, and they have different books for different subsets of things, like how you do the package management in the cargo book, how you do documentation, getting familiar with the internals of the compiler, all sorts of things, all linked from this site. So that's what I'd recommend if you wanted to learn, start to learn this stuff. All right, worker no longer takes the listener. That's fine because we don't need it yet. That satisfies this, which means start no longer starts it. Instead, we have to actually, when we get the listener, we have to send it. We'll do that in a second. We're not going to send it yet, so we're going to get a warning about not using it, I think. That's fine. No problem, Windy Twitch. I really have gotten into the language. It's super challenging, but once you get stuff running, there's an enormous sense of accomplishment. I don't have this in my cache anymore. Do I? Oh, I do. I need to clean this up so it's easier to read with fewer words, but yeah. It's very strict and rigorous. Usually, your code just works once you get it to compile because you're spending a lot of the time meeting the rigor of the compiler. I like that sense of accomplishment when I actually get it to compile, though. And a lot of these things are really new and modern compared to like C and C++ that just like, for example, don't even have any kind of built-in package management. So Cargo is just quite a relief compared to C++, where I had to like mess around with CMake and then manage dependencies using that, and then give people instructions on what to clone. With Cargo, you just say, just add a single line to your Cargo TOML, and it just works. Oh, you need futures? Boom, done. Yeah, I compare it to languages like C and C++. .NET is probably a lot more convenient like Rust. But yeah, coming from C background, Rust definitely beats the those older languages in terms of like package management, and like the linter being built in and helping you learn stuff is really nice. The language and its standard library being very cross-platform is really, really nice as well. The fact that you can have TCP listener like built into the standard library, that comes from the standard library. I mean, there still isn't one in C++, at least up to C++ 17. I don't know. They might have added TCP, like network stuff to C++ 20. I don't know. You really like the compiler holding your hand? I think of it as the compiler holds your hand while you walk over a bed of coals, but sure. Yeah, you learn a lot. It's painful, but when you get to the end, you feel you accomplished something, and it's your code usually works. I've had a lot fewer bugs after successful compilation. It does have the built-in unit testing, which is also nice, but I haven't actually needed the unit testing nearly as much. You think they finally got async networking in 20? It's about time, don't you think? I mean, like, operating systems networking interfaces pretty much de facto standardized to whether you think of it as WinSock or BSD sockets or POSIX sockets. It's been pretty much the same for like 15 years or longer, right? It's just refreshing that to see in the language it's there day one pretty much for me. So yeah, I have caught the bug, and I don't. Given the choice, I would not go back to C++. 30 plus years? Yeah. I think it's because they're just tied down to so much legacy stuff, whereas Rust has the opportunity to start fresh. And C and C++ are older than a lot of those networking protocols, right? So one thing that surprised you coming to Rust was there's no random number generator? I thought there was. I used one, though. Oh, I might have just picked up a crate for that. You might be right. The crate package management in Rust is so nice, though. It almost feels like it's standardized, right? Like, it doesn't feel like you're going that far away from the standard library by pulling in a crate like Rand. And some of these crates like futures, it's pretty much part of the standard library anyway, because everyone uses futures 0.3 now, right? You could almost build it into the standard library. There's probably technical reasons why they haven't done so, but I wouldn't be surprised if some crates like futures and Rand just got introduced into the standard library at some point. They probably have a good reason why not. Like, maybe one reason not to pull in Rand is that they want to keep the Rust standard library trim, and you don't need random numbers for a vast subset of programming use cases, right? So like, okay, so if you do want rand, just get the rand crate, and it doesn't bloat the standard library. That I would accept that. If they don't want a bloated standard library, sure, leave it out as crates, right? They don't want libraries to die in the standard library. Okay, so there we go. Some things are tricky to get into the API, right? You read something about that somewhere. So there's lots of possible reasons. Probably some or all of them are true, right? Golf. What's a four-letter word sport that starts with a T? Okay. Hi, Mr. Balrog. How are you today? I don't have a joke for you today, though. Unless, do you have a joke? Do you have a bad joke? That joke? Why do ants never get sick? I don't know. Why do ants never get sick? Because they've got antibodies. Because of the yeah, so Mr. Balrog guessed it before he heard it. He got it. What do you call an empty can of Cheese Whiz, Mr. Balrog? Cheese was. Oh, okay. All right. So I feel like we've traded jokes today, and that's a nice feeling. Hey there, I forgot to say hi to Driftin' Aloft. That's actually a nice name, Driftin' Aloft. Driftin' Aloft. It's gonna say a party gone well. All right. Where was I? Oh, right. We are making it so that the worker thread runs the entire duration. So stop should not stop the worker thread. Stop should only send a message to tell the worker thread to stop listening, right? So, yeah, this all then moves, right? Back to here. And since we always start it, that means we're always going to stop it. So it'll be like what Jeeves does in its drop. I mean, where'd it go? The pantry. Where is it? It dropped off my list somehow? Must have closed it. Open the pantry again. Yeah, this one. At the end. Not the tests, but at the end before the tests. Here we go. Yeah, we introduce the self, and then we have to take and unwrap the worker. Yes. Take, unwrap. And there's no okay there. And then this veneer is removed. It's just that. Oh. Oh, I combined them together, didn't I? I don't need to do that anymore. Yeah. The work in is always there. It's not an option. I had nice documentation for this. Yeah. Let's just do this. Boom, done. I just need to remove the KV and I'm done, right? Oh, thank you for the follow. I appreciate that. All right. I'm just doing major surgery on this new class. Don't mind me. Really? Oh, I put it in the wrong place. Yeah. My bad. That goes there. This doesn't need to exist anymore. All right. Okay, yeah. I wanted to name it join handle for some reason. I renamed it to worker. Yes, okay. You crazy Americans and your canned cheese. Hey, remember, it wasn't my joke. It's one of my kids' jokes. So you can't blame me. One of the better things to come out of your middle school and mud playing? Comma in the URL. No! Are commas allowed in URLs? I forget now, and I made my own URL library too. Okay, so this no longer is done, right? Actually, that means we don't... No, I still need the already started, don't I? This should come back out of the message, shouldn't it? Yeah, so we're gonna need some messages for start and stop then. Actually, I don't even need a stop right now. I'll wait until I need a stop. I don't need a stop right now. The Jeeves only needs a start, which we have. Okay, but then the start, it doesn't make the thread anymore. It needs to send a message. Send a message. Not here. What am I doing? This should have been work in sender. Worker thread is some thread. Right. Why does this all have a thing? Oh yeah, it says I should have a default, which I agree with. Let's add a default. Implement default for HTTP server. Use the nice light bulb to fill in the details. This is just going to return self new. Warning alleviated. Chats like Twitch use regular expressions. How could they? Okay, good night, Mr. Balrog. Oh, I didn't say hi to someone. Stamount, hello. %2C in the chat to pay respects. My respect to the comma. Alright. Oh, I ran into this the other day, and I don't know why, and I don't know if anyone else runs into this, but it turns out if you turn Clippy Pedantic on, you get this really strange warning when you try to use the select macro. It says that you're trying to do a mute. You see that? I can't even mouse over it reliably. Generally, you want to avoid reference mute if possible, but I never actually had one. It's somewhere inside of the implementation of the macro. So the only way I know to work around that now is I had somewhere I had to this one. I had to allow mute crate wide because it falsely triggers on select all. Yes, I will put it here. All right. Okay, we will need to handle the message very soon. But I want to make sure everything else is squared away. Right. Right. Okay, everything is squared away. So, there's one for stop, and then this tells the worker thread to start listening for incoming requests from HTTP clients. So, listen, or start listening. If I'm going to have a stop listening, this should be more elaborated, right? Like stop everything, or exit. I like exit. This tells the worker thread to terminate. And I'll just need to say exit there, and then up here it's gonna take a while, not exit. Okay, so then we have start listening, and I need to provide a listener. TCP listener. And then this tells the worker... do I need to... actually, no, I don't need to tell it to stop. I just need to start, don't I? Definitely had some less than helpful warnings from Clippy. Looks like you're handling Rust. Would you like some WD-40? Had one where suggested to change it another way, which resulted in a bar. Yeah, I had one of those too, Sarah, and it was one of the newer ones, where it says you should use combinator instead of an if-else. But if you use the combinator, then you end up using a closure, which then needs to borrow something longer than you needed to borrow it with an if-else. So I've had to like manually suppress those or rewrite it in a different way. Hey there, Ibicall. Never caught me online before. You see my VODs? Thank you. Yeah, I export all my VODs to YouTube just because I'm a hoarder and I feel like I've generated all this live content. I should keep it around. Guess you still need to close implementation for... I don't think you need to. I think everything in Rust drops pretty gracefully, right? What'll happen if we drop... We're going to join our worker thread, which means everything that the worker thread owns, which is going to include the listener, it's just going to drop, right? In fact, we'll have to add it in a second, but the worker is going to hold the listener by option. But when it terminates, it's going to drop that. Drop isn't guaranteed to run. Well, if you terminate your program with a panic or an exit, sure. But what if you do a graceful exit? I guess we could test that. Hey, let's test it. Let's do a printf. A print line. How's the line go? Goodbye and thanks for all the fish. Now, we should get that when we Control-C out of Jeeves, right? And does this compile yet? I don't think it's going to compile because I have some... Oh, no. I did get that. Oh, did it call... I didn't rewrite start yet. Start should not try to... Wait a minute. Oh, hey, kitty. Why are you yelling? Come here. You want to say hi to chat? He doesn't want to come here. A cat does not want to come here. Yeah, so this line. I don't need that anymore. Which means I don't need... Oh, wait, no, I still needed that. But it's not to be generated at this level. That's right. It's going to be generated deeper in when we try to give the listener to the worker thread, and it already has one. I know, Toulouse. Isn't that sad? My cat just like yells at me from that box over there. And I think he's like expecting something. One panic will unwind the stack, dropping everything in the way, but if another panic occurs... True. I'm not writing this program to, or this library to gracefully close on a panic, though. I just want to make sure that it gracefully closes and drops everything on a non-panic exit. So I have a path for that, right? In Jeeves, if you hit Control-C, it'll complete this future, which will gracefully exit main. So I expect it will print out the message that we saw. Allow access. It actually is listening to the port number. Control-C. Goodbye and thanks for all the fish. So I think we're good. I think it should drop everything in the path that I care about, which is the non-panicking path. Does it really matter if it drops? Not really. There's one argument, like, for example, the game I have online, I have no cleanup paths at all in that stuff. I started putting in things like stops and like demobilize, but I'm pretty sure they just crash the program. When I need my server to be updated, I just kill the process. I don't even let it like shut, like it could be in the middle of writing to a file. I don't care because I already have code built in there. If it only partially writes a message into a file, that it just, when next time it starts up, it just ignores it. So I don't even bother with any kind of results about the program dying. I just do a kill process. And that's one philosophy, right? Okay, so here's that warning again. Calling as bytes on a string literal. Right, so that the solution to that was to do a B to vec, right? Yeah, there we go. I've learned something. No more warnings in the Jeeves. Back to the library. Don't need that anymore. Pretty sure we're good. Okay, so start makes a listener and throws it away immediately. We don't want that. We actually wanted to give it to it. So that would be a self.workin.send, unbounded send. The message is going to be a worker message start listening with the listener. Right? Okay, and that can fail, but it shouldn't. I probably have something in Pantry where I wrote a comment for this. Right. It shouldn't be possible to fail since the worker holds the receiver for this channel and it isn't dropped until the client itself is dropped. Yeah. I'm going to keep that comment in there because it's sort of like whenever I need to do an unwrap, which I'm going to do here, it's me justifying, this justifies the unwrap there, which you can't see. It should never fail because the worker thread holds on to the receiver its whole lifetime and the thread is never joined until we drop. So it shouldn't be possible to do that. Okay, but then how do we know if it succeeded or not? I think we need a one shot to wait for it to happen, right? I think so. So let's include it. Let's say start listening has a listener. And it has a receive sender, result sender. One shot, which we don't have yet, because that comes from channel. One shot sender of result error. Okay. Hi, Anakim Luke. Again, did you leave and come back? Would you summon the lurkers and wonder how many people would show up? You mean into chat? Why would I want to do that? It would just be chaos. Shutdown program is necessary if you want, for example, keep file content format properly. Yeah, so for my game, the files it writes are journal files. And when I have the program start up, it reads the journal entries back. And if the last entry is corrupt, it just drops it. Because I figure if it was in the middle of writing a journal entry, it hadn't yet committed that journal entry anyway because we're using Raft, using the Raft consensus algorithm, which I will correctly link the command there. Since I use that in my game, I can kind of cheat and say, well, if it didn't quite write a journal entry, it must not have committed it, and so we don't need to keep it. It'll just get regenerated naturally after the game starts back up. So I just toss corrupted records. And I rely on the file system to not corrupt things already successfully written, but I don't mind if like the last few entries get dropped because, yeah, we probably didn't commit them anyway. And if we did need them, Ref will recover them from the other servers anyway, so I get to cheat a lot with that. You can basically toss all your state when you're using Raft because the other instances of your program will give you any state that you're missing as part of the consensus algorithm. So there's no need to cleanly shut down or finish writing. If you stop, you just stop, right? All right. This is getting quite long, so we're going to... Actually, if I just do that, that will work. So we need the listener, and then we need the the result sender. So we'll arrange for that here. Let result sender result receiver equal one shot channel. So then after we send the request, then we wait for the result. So result receiver dot await dot the first level is okay because we will receive a result. This technically is a result with a result because it could be canceled, right? It should never be canceled, and I should have the same explanation here. It shouldn't be possible for this to fail since the worker will always what? The worker will always send us back an answer. It should never drop the sender of the channel before doing so. So if it does fail, we want to panic. Okay. So then we have to handle that message in the worker thread, right? So then worker here, I need to re-enable this because sure, it's unreachable to get to stop, but we do, it's actually called exit now. We do want to handle start listening, and that is, from that we want the two fields in it. Listener and result sender. And we will handle it thusly. We will say, too bad I don't still have that code. We actually need to have a, we will be in charge of the listener for incoming connections. Actually, I might need to end up sharing it, but now it doesn't need to be shared. We'll just keep it an option, right? Let listener equal optional TCP listener. Actually, I don't even need to do that. I can just say none, right? And then here I will say, let's rename this new listener. I could even make another arm for like if listener is none. Can't I? I can say this. Yeah, why don't I do that? I can do this, right? Start listening. We don't care. Actually, we do care. I need the result sender. If listener is some. I don't like this formatting. What if I do... Does that look horrible like that? Doesn't look too bad, right? If this happens, then result sender send error already started. Okay, here we're going to send OK. Do I have enough parentheses? Never enough parentheses. Always need more. The reason why we have to have an extra set of parentheses is the value is the unit value, so you need that, and then the outer parentheses go with the OK. Cat's meowing again. Okay, we actually need to store it, right? So listener equals some new listener. And what's the problem here then? A captured variable cannot escape. What escaped? Something escaped. It escaped. Something has escaped. What escaped the closure? Oh, because of the async closure? Ah, yeah. Okay. Yes, yes. So we need to ref cell it. And then I need to RC it also, right? And those we need to pull in from which crate? Which standard? Cell, ref cell, RC, RC. I'm assuming that means you're not buffering those writes then. No, because there's no point in buffering them. Actually, no. I might be buffering them because there's no There's nothing wrong with buffering them. It would actually reduce the disk usage doing it by buffering it. Because the worst case is that I'll lose the last buffer, but then one of the other servers would fill me in anyway. Need to write data to the database and gracefully shut down. It's critically required. Yeah, probably because you have a single version. It's not replicated that way, right? It looks like Java 8 Streams API with chain for each loop. It kind of does, right? You end up having chained method calls whenever you have streams and when you have iterators. And it's the same principle. It's, I forget the term for it, but yeah, method chaining. That's what I like to think of it as. What's wrong here? Oh, yeah, I need to actually borrow it out here. Let listener equal listener borrow mute. And this should be, why can't I just do this? Do I need to dereference that? Oh, yeah, let mute listener. Interesting that I need the explicit dereference there. Okay, yeah, and these can both fail and we don't care if they do. I should probably put a comment in there. I hate having redundant comments, though. I wonder if I could... No, I can't think of a way to do it. Of like consolidating these two sends. The problem is that the patterns are slightly different. To combine them would have one arm with an if-else in it. Maybe that's better, though. Is it better to have two separate arms, one for the already started and one for the optimistic case, or is it better to have a single arm? A single arm would look like this. If it is some, then this, else this. Actually, I think I prefer this because then I can take the result sender send out of that. Yeah, I think this, I like this way better because I can do this now. I can do that and remove this much of it. And also take that out and put it there. Remove some unnecessary parentheses and we're done, right? What happened here? I'm missing some parentheses somewhere, I think. Oh, right here. Yeah, there we go. It is replicated, but data still might be lost if the app dies instantly. Oh, like if it never got committed? Yeah. So if you want to try to keep all data that you possibly can, sure, that makes sense. For my game, what I decided to do is like, well, if the entire cluster goes down, I'm not really going to care about if like the last few seconds of the game get lost. If I did care about preserving every single event in the game, yeah, then I would try to have everything committed as soon as possible, so no buffering, or if the buffering is done, it would be done by something that's more resilient to a crash. All right, so we have the start listening done. This seems overcomplicated for what I want, but yeah. This should work, right? Should I put something in here? Just to test it? Make sure it's happening? Now listening for connections. Sure, I'll just run it and see. Oh, that's running Rover. I don't want to run Rover. I want to run Jeeves. Jeeves of the connections. Now listening for connections. See, it worked. I could even have it tell me what port number it's listening on. Now listening for connections on port something. And we will retrieve that by going to the listener and saying, what is it? Address or something? Or local address? Isn't there a way from a listener to get the address it's listening on? There ought to be a way. Really? Oh, wait. It's an option, isn't it? And I'm looking at the wrong thing anyway. Local address. There it is. I want the port number from that. I have to unwrap it. Okay. And then what? Port number? Port. There we go. I'm listening on port 8080. Nice. Okay, so it's listening, but we're not handling anything that comes into it, right? It's not the job of this queue to do it anyway. I think it needs to be another future out here, which means I need to move the listener out to here. Didn't I have a nice comment in the pantry for this kind of thing? Looks like I just collapsed them. Yes, so we'll just pass it in. And I think I did that by cloning. Yeah. I did that by... you have to clone on the first one. No, clone on everything but the last one. So I can... right now I only have one thing, so I can just pass it in. And... that means that it's added here. A listener is an rc'd refcelled TCP listener. Oh, and then someone in chat was telling me I technically don't even need to do that, right? Can't I? I can just do this. And it doesn't even need to borrow it. It gets its own, right? No, it does borrow it. Yes, and then, although this isn't working now. Oh, because it's an optional, refcelled optional listener. Okay, now it should work, yeah. So the trick was to do a dereference, I think? No. What's the trick here to get the ref cell from the RC? That? Yeah, that little weird thing. So we have to dereference the RC, and then we have a ref cell, and then we want to borrow it. So at the cost of this strange little syntax here, I don't need to increment and decrement the reference counter. I'm basically just borrowing a reference that we made here, or using the one and only reference in this case. Should we just use at, not both? Oh, okay. Thank you, Sarian. I approached it from the direction of that first, right? And then said, oh, that's not enough, so maybe I need to do that. Oh, yeah. But I didn't approach it from the other direction. And that is because deref is implemented for them, right? Yeah, we're working through deref. Yeah. Pretty sure that's right. And hello, Uru Niwa. Yeah, RCT implements dereft. Indeed. All right, so now if I want to process the listener, actually, I don't even know what the API is for that. I need to look. TCP, what time is it? It's 4:23 my time. Down for almost 5 hours. Wow. This is a long stream. I can feel it in my voice. My voice starts to wear out at anywhere around 4 to 5 hours in. Probably because I need to hydrate. By the way, I don't know if anyone else is streaming in the team right now, but if you're interested in Rust, highly recommend anyone on Team Rust stations. So if I'm not streaming, a lot of the time you'll see either Ecton Dev or Brooke Zerker or Mr. Halsey or Togglebit. I subbed to Togglebit this morning. Eric.dev, Madhouse Steve. All those guys are incredibly awesome. All right. I need to look at the API here. How do we use a TCP listener? We call accept. Okay, great. And say synchronous. This is exactly what I want. I want a future that completes when we get a new connection. I'm going to need to make one every time, though. So we're going to need to do this in a loop. Yeah. All right, I got it. So we need a new thing here. Is accept connections. Or really it's well, for now we can accept a connection. Later, after we've accepted a connection, we have to now sit on the connection and wait until we get requests, right? So it's yet another set of futures. I think, yeah, so we'll just break this up into the things we're doing. Accept connections. And later we'll add a, process or, yeah, handle requests or something like that. But not yet. Okay, so for the first one, we got a clone. Wait, what am I doing here? Yeah, because they both need to borrow it, right? One needs to set it, the other one needs to use it. And fuse it, of course. Don't need to do anything if it completes. Actually, it won't. We're intentionally going to make this one never complete. All right, so then the signature of the method. It alphabetically goes before, so I'm going to put it before, and the name is accept connections. It just gets a listener. Cool. To do. Actually, even better than that, we can just sit here and do futures, future pending for all time, right? And then that should compile. Okay, it doesn't, so I need to clean this up. Consider, temporary value used when temporary value is freed at the end of the assignment. How so? Is it just that line that did it? No, it's something else I did here. What did I do here? Oh, I added the clone. That's what I did. Okay, so I wonder if it's because I need to do... Oh, that's why it can't be just a ref cell, because it needs to own that reference. Yeah, these need to own their references. That's why. So we have to do that, but we don't borrow the RC. We actually give it. It's passed by value in. Yeah, that was important. For these two pieces, these two subtasks, so to speak, to independently operate with the listener, they have to have their own reference. Yeah, the clone did it. The clone made it temporary, so it can't be temporary. Someone has to hold it, so we're going to have the futures themselves hold it. Right? So now it'll work, and we're free to actually do something with these connections. So in general, I just want to loop, right? And I want to say let connection equal listener. Actually, I just thought of something. What if we want to stop the server? We need to have this breakout early. What happens if we're in the middle of an accept and then we call... Ooh, are we screwed here? How do we break out of accept early? I know. I'll have to combine it with another one-shot. Yeah, I'll have to combine it with a one-shot that will cancel it early. So I need to put this into another select. Yeah, sure. Yes, that's what I need to do, right? This needs to select on two futures. One where, careful about using clone and RC, because if the T implements clone, you'll get that instead. But I think it's okay with ref cell, right? Because you can't, I don't think a ref cell can be cloned. Yeah, it makes sense. RC, you are not cloning because you want the same object, right? So, yeah, generally, when I use RC, I do it with the ref cell anyway, for that reason. More common to do RC clone. Oh, you're saying when I do the new. You're saying it's safer to do RC clone. Or, I mean, instead of clone, to do RC clone, right? All right. Did I not type that right? And it wasn't right for some reason. Expected a reference, found a structure. Oh, I need to borrow it? Okay. I'll give you a point for that, since it's probably good advice. Here, I'm just going to give the last one for because I don't need it anywhere else, so it just gets it gets to have the last one. That's fine. All right. Okay. So this would be what? An async. The general format for this is that and then an arm, right? So some kind of async block with an arm that does nothing. And then just to test this out right now, we'll put the pending in there too. And the loop goes in here. This one, so this is accept, right? Okay, I almost got it, right? Except for this should have an await. Oh, no. What does it have? It doesn't have anything. Oh, wrong syntax. Here I do need an await, don't I? Or does it not? It doesn't because we handle it in these arms, right? This needs to actually have something at the end though, right? Or does it? Hold on. Is that correct? That's not even correct. What am I doing wrong here? Oh, we don't need an await there. That is a future. Got it. Okay. So then we don't have an await, we just want a future there. Now what's wrong with this one? Not satisfied because... Oh, it needs to be fused. Yeah. Need to fuse both of them? I guess I don't need to fuse pending. Interesting. Alright. So then let the connection be to... Okay. Do I need to do like a move in here? No. How come I don't get listener? Okay, what would it be? I can't. Autocomplete's not going to help me, so let me just figure it out. Accept await. And it can fail. What do we do if it fails? Oh, they didn't say what the possible failures were. How can this fail? I guess if the socket breaks somehow? How would we want to report that? I don't have a mechanism of reporting that yet. I'll probably want some kind of one shot out of the server though. I'll leave that as pending. We'll just ignore it. Well, no, we should break. That's what we should do. If let okay connection equal that, else break. And to do this happens if the listener breaks somehow. We should set up a mechanism for reporting this. Yeah. Yeah. So it shouldn't happen unless something in the underlying system, like perhaps if you disconnect the network or something, right? So like the network interface disappears. Well, yeah, but this won't happen. That won't happen because we're not binding to a specific interface. But yeah, anyway, I guess if that happens, we just want to report it, right? I might need to read more about what instances does that actually happen. I don't even know what do I do in my C++ version of that. I think I just ignore it. It's probably a bad thing. Okay, what's wrong with my syntax here? No method named except found unstruct. Oh, I didn't take it out. I forgot to take it out. I do that here somewhere, right? Yeah. I gotta take it out there. Now what? No method named except found on... Oh, because it needs to be something. Oh, right. We only want to do this if the listener is something. So the entire future would be, no, wait. I need to do that in the loop, actually. Because we could be told to... Oh, right, I was going to add another thing with a one-shot to when to tell it to stop listening. But I don't need to worry about that now. Right now, it just needs to be... It needs to know when to start listening. Or when to start accepting, really. I guess we just look at the sum, right? Okay, this is a little harder than I thought, because, it needs to be inside this loop. And I need to wait for something. I suppose we need a one-shot. Shoot. That means I need to expand this a little bit more. Tend to use non-blocking sockets and run poll and list. That's what Rust does internally. Try catch probably in the loop in C++. Don't you need to borrow it? Yeah, that's what I'm doing here. But I need to redo this because we don't want to borrow it outside the loop. What I want to do is borrow it, and if it's something, then we'll stay there and accept. Actually, it needs to be completely outside of this select, doesn't it? Shoot. Oh, this is going to be tough. Actually, I think I know what it is. This feature needs to own the listener. We can't share the listener like this. Because otherwise it's a problem where it's being held up in two features at once. So wait, then maybe this is the wrong architecture then. Maybe in start listening, here's where I just make the feature directly. And put it where? Box it and then use it in the other place? No. I like the separation of handle messages separate from accept connections. But accept connections should sleep until there is a listener, right? So if you fundamentally, there will be a loop on the outside. That's for sure. Inside the loop, we're going to either wait for a one-shot or we're going to be listening, and it depends on if we have a listener. So that means that the listener is actually internal in here then. And we're not sharing it. I think that means, yeah, I want another structure. Struct shared worker state. And do I want that actually? No, I don't. Scratch that. Gosh, this is where my brain gets twisted up in knots thinking about how to do it, because I'm used to architecting asynchronous code completely different from this. Yeah, we're not using a blocking accept, we're using an asynchronous accept. So what it does is it gives us back a future which will eventually give us a result, either a stream or an error, right? So while we're waiting for that future, we're holding up the listener. So that's why I need two futures, really. We need one that's going to be waiting on this accept, and another one which will need to trigger if we want it to stop listening. And then that will cancel the future that this accept is in the middle of in order for us to drop the listener. Yeah, fundamentally, I need to loop because we're going to be constantly starting and stopping listening. But inside the loop, there'll be yet another loop on the connections if we're listening. I think. Actually, I don't know if I'm going to have an internal loop or not. But how am I going to get the listener in? With a channel, I guess? Another channel between these two pieces? Or do I leave it like that? No, I need something like a channel. I need a channel, but I'm going to use it more than once. It can't be a one shot. Yeah, okay, so we'll pass the listener through another queue. We're waiting so it behaves like a blocking in the async function. The way that my understanding of blocking in an async function is that the future that calls this async function yields until the accept returns or the future itself is destroyed. There's two ways out of a future, right? You could either complete the future or you can drop the future. So if you complete the accept, that means you got a connection or an error. If we drop the future, that's because we either stopped the thread it was in, or the future was in a select and a different future was completed first. And that's the way I was handling this before. Is if we have two selects in parallel, one that's waiting to accept and another one that's waiting to be told to stop listening, then that'll make this work. Because then the one that the accept is tied up in will just be dropped, and then we'll never complete the accept if we stop listening. Where's my window? Yeah. So, but I need that other future to stop listening. Yeah, there needs to be a queue with yet another message. So I need another enum. So this is in one direction. This is message to connection acceptor. One is to listen. Well, no, it's already listening. Accept connections. And it's given the listener, right? And then the other one would be to stop accepting. Or I guess it's start and stop. And stop, it needs the listener back, right? Does it need it back? No, we can just drop it, right? Yeah, so it doesn't need anything. And I'll need, instead of this, we're not sharing that anymore. It's going to be a receiver, which is a MPSC, unbounded receiver of messages to connection acceptor. Inside we'll have a listener, which is an optional that, right? So let listener equal that. Well, I'll remove the type annotation in a minute. We're just needing that right now. We are still going to select on multiple futures here. One is we're waiting on... oh, dang it. This won't work. I can't use an unbounded receiver because that's a stream, not a future. I might be getting myself stuck here. And this might need, I might need to take a break and come at this fresh later. This can't be an unbounded receiver. What can it be though? Shared state. So back to something. Yeah, let's say I have a shared state. Worker shared state. Or worker state. And it's shared through a reference to a ref cell. And in there, should I just put the listener in there? Sure, why not? And so, we would need to borrow that mutably to get at the listener and then take it out, right? Right, so wouldn't we do this in the top of the loop here? I think so. If, yeah, I think this will work. If we have to borrow here, let listener equal worker state borrow listener take, right? To take it out. So we take it out and it's like, okay, do we have one? If let sum a listener, actually I can combine those two, right? Oh no, if I combine those two, the borrow persists. If I don't combine those two, then the borrow checker knows for sure we're not, just to be safer, I'm going to do it this way. Maybe I can combine the two together, but I'm not sure. If we have one, then we're going to do a bunch of accepting. If not, we have to wait for something else, right? So I think I need to make a one-shot here. Kick acceptor. Optional one-shot receiver. And I don't need any data associated with this. This is like a kick. The kick pattern. I've invented a new pattern called the kick pattern. So here we would just do, if there's no listener, then there must be a kick acceptor. There's no other path. So I'm going to do let kick acceptor equal worker state borrow kick acceptor take unwrap. I'm going to say if there's no listener, there should be a kicker. So this shouldn't fail. If it does, we have a bug and want a panic to see it while debugging. Right. Can we use unbounded receiver into future? I don't know that method. Oh, Chris. Hello, by the way. I don't know about this unbounded receiver into future. What does that do? That would be found here, right? Unbounded. How come I'm not finding it in async standard? MPSC? Oh, because it's not part of async standard. It's part of futures, right? I don't have that open at all. Let's open it over here, futures. API reference, MPSC, there it is. Unbounded receiver, where are you? What does into future do? Is it a trait implementation somewhere that I don't know of? It's from the stream trait. Okay. Thank you. It will call. Stream trait. Show hidden items. Is it stream trait or is it stream extensions? Ah, here it is. Found it. Converts the stream into a future of next item tail of stream. If the stream terminates, then the next item is none. What's tail of stream? The term future can be used to compose streams and futures together. Ah. Into the world of futures. I like that. Note that because into future moves the stream type must be unpinned. That's fine. If you want to use into future with an unpinned stream, you have to pin the stream first. Makes sense? This can be done by boxing it. Makes sense, yes. Okay, so their example shows we have 1, 2, and 3. Oh, that's like the rest of the stream, tail of the stream. So that would have like 2 and 3 in it. And this would have 3 in it when it's done. I get it. Okay, cool. So that would be another way of doing this, right? So that I wouldn't need to share the state. Would it be cleaner then? Let me consider it as like, we'll try it both ways. So to do, try the alternative thanks to what we call of having the having handle, what is it? Handle messages. Of having a channel between handle messages and accept connections used to provide the listener as well as to tell it when to stop listening. Actually, another possibility is I don't even need to divide the worker into these. I could just combine them. Although I do like the idea of keeping them separate because they are 2 different kinds of work. One is to handle messages from outside of the worker. The other one is to handle internal things. But yeah, I'll try that later and compare. So without having a channel, I'm putting it into common state, which doesn't feel right. But we'll see. The consequence is I need to borrow immutably and take things out. Right? I already don't like this. I already want to try Ubicall's solution. But this should work, though. If there's no listener, it should be kicker. So we get the kicker and we wait on it, right? Kick acceptor dot await dot unwrap or nothing. So our this future will sit here until we get a listener. So the way it works is we'll have to set the listener and then send to the kick acceptor. Yeah. We'll have to kick the acceptor, basically. If we have a listener, then I need 2 futures. One, oh yeah, I don't like this. Because I'll need another one-shot. Or I need to reuse kick. Yeah, I can reuse kick. So this block here moves in here. And we select either on this... I don't need to do this anymore, right? Don't need that. We still have that. This break doesn't make sense, though, right? Actually, what the break would do, I don't need to break because we actually just wanted to go back to the top of the loop, so we don't need to do anything here, right? It would naturally drop the listener and then wait for another one. Yeah, okay. I'll leave this part in there though. Yeah, so then instead of future pending here, it's another one of these. I kind of wanted to make a function out of it. I hate being repetitive. I hate being repetitive here. How can I combine these together? I could combine them together by putting this inside of here, I suppose. Like if we have no listener, then just wait forever here. Good night, Nui. Thanks for being here. Yeah, I think I can combine this down a little bit. Always select on this. Inside of this one, if we have a listener, then try to get a connection. And that's it. Otherwise, wait for a kick. Right? How does that look? So it's gonna, every time it loops, it's going to reconsider, do we have a listener? If we do, we're going to wait. Oh, you know what the problem is? It's only going to accept one connection, then drop the listener, isn't it? I need to put the listener back. Yeah, I need to do something like this. Like, it needs to be out here. It starts off at none. And then we get it. Oh, no, what am I thinking? It is here. Never mind. I just need to put it back. I need to say worker state borrow what? Dot listener equals some listener. Yeah, so after we accept a connection, we put the listener back so that when that future completes and then we loop back around, we'll make another future which takes it back out if it's there. Yeah, and then if we get kicked, if the kick wakes up there, then it abandons this future entirely. And I suppose if we get kicked, we want to drop the listener, right? That means I can move this out of the loop. Yeah. So we always take the listener out every loop. If we have a listener, this future will try to accept a connection from it. Whether or not we have a listener, if we get kicked, we will drop whatever we have and then go back up and basically drop. We always drop the listener if we get kicked. But if we're able to accept a connection, we put the listener back in and then try again. I think that makes sense. All right, what are we going to do with the connection? I guess I should print something here. Print line. Connection recede from connection dot, what is the type of this thing? It's a TCP connection, right? Oh, we get a tuple, a stream and an address. That's nice. So, okay, connection address. So I can just put address here then. Right? So I'm going to infer the type now. Let's turn on inlay hints. Oh, I have a bug somewhere. That's okay. Here it's, yeah, I never fixed that up. So, listener, kick acceptor. This, no. This needs to replace listener. Right. And then, it's the worker state that we're borrowing. Turn off in the hints. Okay. So this would be, oh, the responsibility. Okay. We don't need it the already started error, because what would happen if we got another listener is it would just drop the old one. Isn't that what we just what we want anyway? Yeah. It doesn't, yeah, so I don't even need this already started, do I? Where do we listen? Where's the listen call? Or the bind? Where is the bind? There's the bind. Okay, so if we're already listening on the same port, we'll get a bind error anyway. The only way this would start, you can call twice without calling stop first, would be you change port numbers. And so it would bind the new port. Actually, this is much cleaner then. You should be able to finish any existing connections on the old port and have the new port open, right? So then I don't need that error at all. I can drop it. This already started. We don't need it. Gone. Actually, I kind of feel like we might need it. Maybe I'll put a to-do here. Where to put it here? To-do. We probably don't need this error. But let's keep it just in case. Yeah, I don't think I actually need to do that. The flow should just naturally drop the old one and give us a new one, right? So I don't need that at all. I can just say now listening, and then we don't even need a new name for this. It can just be listener, because we're putting it in worker state when this happens. Worker state dot listener equals some listener. And then I have to kick the kicker, so I need to do a where are we going to do that? Oh, guess what? GeForce Game Ready driver is now available. I'm not clicking there, though. Go away, message. This is listener, local addressed unwrapped port, right? Get rid of this. What's wrong here? Doesn't like what I'm doing. Oh, because this needs to be a block. There we go. If there's no listener, there should be a kicker. So every time that we set a listener, we need to set a kicker. And we need to set an initial kicker also. So yeah, I need this worker state declared outside here. New. Whoa. Ref cell. Oh, fighting my keyboard again. New worker state. Does that have a? That doesn't have a new in it. Oh, I guess we'll just do it right here. Worker state has listener and kick acceptor. Listener, none. Kick acceptor, one shot channel. Okay, so then that replaces the listener. Cool. What's wrong with this one? Type not known? Oh, it's some. Getting tired, I think. Trying to figure out if stream extension next could help you get rid of the take while for each chain. Yeah, that is another code smell, isn't it? The fact that I need the unreachable. I need the unreachable, otherwise it'll complain that there's a missing arm, right? The only reason that we don't handle it there is because this is a way to stop it. The fundamental thing I need is to make the stream have an end. So the take while provides an end by turning it into an option where it's none if we get an exit. Think you could call next in a loop and wait for it instead of chaining? Yeah, that would be more imperative. I'd like to do it with the iterator style because it's new and cool. But I see what you're saying, you would call. Yeah, we could just do a loop and like while the next one isn't an exit. That would work too. But for each is so awesome, don't you think? Yeah. So essentially the alternative for the take while and for each would be a while with that is the condition of the while, and using calling next. While next is not equal to that, right? Yeah. I'll give you a point because that's valid. I'm just so biased right now in favor of the chaining approach that I'd like to keep that. Imperative is so unreadable sometimes. It's so readable sometimes. Yeah, I agree with that. In the end, I go with what's more readable. To me, this is more readable because it's kind of like giving you a recipe. Start with the receiver. We're going to take things out of it while it's not exit. And then for everything that you get out of that, you handle this. It's just unfortunate that Rust doesn't see that we won't actually get into this closure if message matches that, right? It's just not smart enough to see that. Iterator is often better optimized for the compiler. I don't know. I'll take your word for it. It's 5 o'clock. Good thing I don't need to cook today. Otherwise I have to stop the stream. Okay, so almost getting it to compile. It's just that the channel doesn't work. What's the problem with the channel? Oh, right. I need to split this. So this is the kick acceptor receiver. So let kick acceptor sender, kick acceptor receiver equal one-shot channel. Right, and so that we give that other one to handle messages. I really should give a better name for receiver. This should be work in receiver. And this is hard to read all in one line, so I'm going to break it up. Okay, and then handle messages needs its second argument, and I get a little uncomfortable with the more positional arguments I have. This is the kick acceptor. There's only one meaning for that word in this context. One shot sender of nothings. Well, we can rename this one. It's only used one place, so it's no big deal. Okay, and then this will be... oh, but it needs to be... I need to be able to reset it. Dang. Oh, wait. Okay, never mind. I don't need to do it this way. Yeah, I can just put them both in here. Yes, I can just put them both in here. I think I'm going to end up doing what Iwikal was saying, because then I wouldn't need to have this worker state, which is object-oriented programming nonsense, right? Sender, receiver. Yeah, I shouldn't need to do this. Anyway, we'll figure it out. We'll do it this way, and then we'll clean it up to do it the other way in a second. Okay, so get rid of all that. What's wrong here now? Oh, someone's at the door. Gotta go answer the door. I'll be right back. Okay, Mrs. Reimer is handling the door. I feel like streams would just have worse performance than editors overall since the code isn't as hot in the pipeline. There's usually a lot more branches. Isn't Rust just structured-oriented programming? I don't know. Definitely discourages object-oriented programming, though, because the more stuff you put into this state, the more entangled into the borrow checker you get. Okay, so no field kick right. Kick acceptor receiver. There. Okay. Yes. Oh, this is such a hack. I don't like this. I don't like this at all. So initially they're both set up. This one should, when it needs to kick, which is here, it needs to pull out one and kick it, and then make a new one. Okay, so then who makes the new one? This is not going to work. I shouldn't do it this way. I shouldn't use one shots. This shouldn't be a one shot. This should just be a channel, if anything. If it's going to be a channel, then I should just use the next approach, right? Yeah. Okay, I'm going to use a Iwi calls solution. So that means there's no worker state. Instead, there needs to be a channel between these two. So then we'll make it here. What to name it, though? It's going to be an MPSC unbounded. What to name it? What to name it indeed? It's the listener, sender and receiver, isn't it? That's essentially what it is. The automatic door works into future. Yes, into future and then next, right? Okay, so then we don't have a state anymore. The listener is created here, and we're just going to send it through the channel. So that means I need to define. So instead of a state, then we have another kind of message. What did I just name it? I named it something. Listener. Okay. So listener message. And then one is to start, and it has a listener in it. And the other one is to stop. And technically, I don't even need to stop right now. I don't even need that right now. We just have a start. I don't have any way. I don't need a stop yet. I'm telling myself this over and over again to convince myself. So I don't need this. All right. We don't have a worker state in. Instead, we get the listener receiver, which is an MPSC unbounded receiver of listener messages. Enums with only one variant. It'll have eventually a second variant, but yeah, right now it doesn't even need to be an enum. It just needs to have, the only thing I care about is the listener. That's how we get the listeners in, right? Okay, so then we don't need to do this. Instead, we either have one or we don't. So let listener, which is, I'll just annotate it right now. It's an option listener, TCP listener, equals none. I'm going to remove, I don't like to have these hard-coded type specifiers if I don't need them. But right now I need it because it's not done yet. So I don't need this. So we would still have two of these. And we still have this if sum, but this is going to take it out. If it's there, we take it out to use it. Right? No, we don't. How are we gonna work with that? Borrow it? Borrow it immutably? Might as well, right? Here we should drop it though, right? For now. No. I was gonna have it put it back, right? So it should take it out. But then I need another name. Almost as cool as enums with no variants, like the never type, yeah. An enum you can never make, called never. Yeah, I'm tired. I get slower trying to figure this stuff out. The compiler doesn't really help by screaming at me with the squiggly red lines too. Okay, this is a problem right here, right? I just need another name for this. How about current? How about... I don't know what to put here. Current listener? That's just so bad. Okay, this needs to go, though. This is what's getting in my... Well, actually, what is getting in my way right now? Cannot borrow listener as mutable is not declared as mutable. All right, fix that. That was it. All right. Okay, so we take it out and put it back if we still have it. We'll have taken it out, so this will effectively drop it. Here's the trick, right? For this future, we want to turn it into a... Actually, don't I want to turn it into a future right... Oh, no, I just want to turn it into... What do I want to do here? This is mutable, right? Because, what was it? I forget what it was. Was it? It was into future. Yes. And then we get the stream back out. So I can do something like listener receiver equals listener oh, it comes back out. So we should just use the same names they use. What do they call it? Tail. Tail. Thank you for the follow. I appreciate it. We have a next item. Right. So this would be a listener then, right? The item for this is, yeah, it's a listener message. Message tail. Is that into... I did have stream extensions included, didn't I? Yeah. How come it's not helping me into helping with this? Oh, wait. Okay. Use of moved value. Oh, shoot. Do I need to do the same thing where I need to take it out and put it back? Oh, if I put it back, it should be okay, right? I just say that equals tail. No. It won't let me do that? So maybe I need to put it into a cell or something. Yeah, why don't we just do that? Equals cell new. That. And I'll need cell, right? So cell comes from cell. All right, so then, so instead of, we have to actually take it out, and then we have to put it back in. How do you do that? Is it with that? Or is it give? I forgot how cell works. Hey, cell, how do you work? Set. Okay, still getting errors. Is it not take? It's get. Okay, that's still not the problem though. No method name get on cell. Okay, what am I doing wrong? What? There is a get. Oh, that returns a copy. It's not get then, right? It's remove? Only works for copy types. So just do I use option then? Yeah, I thought I could use something better than option, but all right. We're not using, yeah. Guess we'll do option. You're right. Thank you, Sarian. Or just try again tomorrow. Yeah. Procrastinate by doing something else you also don't want to do. Oh, I see. Procrastination, how to defeat it. I think one way to defeat procrastination is just start. Force yourself to start, and you'll find that once you have started, it's easy to finish it. But the hardest part is starting. So this would be sum. Okay, and then this becomes take, and this becomes sum again. No method into future for an enum because it's not take, is it? It has to be unwrapped. And that didn't work because it's not declared mutable. There we go. All right, cool. So the receiver, we're going to take it out, unwrap it. The unwrap is safe because we always have one. See, this is why I didn't like about using option, that I have to do the unwrap. But I guess we'd have to do that regardless, right? I'm being subbed to Silverlight 1042. Thank you for the 7 months. That's a long time. I feel I'm humbled by your subscription. Thank you very much. I hope you're enjoying the stream. Take out and unwrap and then turn it into a future gives us one message. And here we will sit forever unless we get a message, right? Which is fine. So when we get the message, we can do that first and then we can match the message, right? And there right now there'll only be one message possible, which is a start. Start listener message start with a listener in it, which is we need a different name, because what we're going to do with that is replace the current listener. Oh, I can't do that because it might be tied up in this future, right? Oh, wait a minute, no, we've taken it out, the first thing, right? So actually, which one goes first is a problem, isn't it? It actually doesn't matter. If there's another future in there, then it gets removed. So listener is some new listener. Done. Why you no like that? Expected option. Oh, shoot. What? Found a listener message. Expected an option listener message. Message. Did I misspell that everywhere? I did. Wow. Okay then. Why is it expecting an option? Oh, because take can give us an option. Will it ever give us a none? I can just unwrap that. Right here. Because it should never give us a none, right? Cannot borrow listeners mutable more than once at a time. Oh, crap. It doesn't like that I borrowed it. It's hard to see there. If you wanted to use cell because it's not a copy type, you need to replace it with something else. Washing dishes is something you procrastinate a lot. At the point where you'll even start, but then you'll be listening to some podcast or stream where you're doing it. Forget that you're washing dishes and walk away, and the world will get cold. Really? What if you leave the podcast Like, so that if you walked away, you wouldn't hear it anymore. Like, leave it on the counter while you're washing dishes. That would keep me there. All right, let's see what the problem is. Oh, because it's shared. Yeah, we're going to have to put it into a cell, aren't we? Yep. This has to be a reference counted ref cell again. We can just do it this way. RC new, ref cell new, none. And then we need to borrow it mutably before we can take. And then down here, same thing. We need to borrow it mutably to assign, right? Actually, that's not how you assign, is it? I don't know how to do the assignment. I don't know how to do that part. Maybe it will help me out here. Type annotations needed because I happen to be able to figure this part out. Is it not going to help me out with the other problem until I tell it the type? Cannot infer the type. Really? Oh, what's this worker state? Oh, I didn't fix this one up yet. Oh shoot. Yeah, the listener sender goes here, right? Yeah, it's being followed up by all this stuff at least. Okay, so then listener receiver goes here. Okay, so then this one just gets it gets two things. Working receiver, and not that. Listener sender. MPSC, unbounded sender of listener messages. So this is all different again. Oh, right. We don't need this then. Start listening is to just send it. So acceptor, listener sender, send, unbounded send, listener message start, listener. There we go. And it's over my limit line. Thank you for the follow. I appreciate it. Over my limit line, I forgot to say hi to somebody, looks like. Oh, hello to Ascend Common, who asked about procrastination. I have to deal with procrastination myself a lot. Okay, that's happy. That's happy. For me, it's just forcing myself to get something started. That's the hard part. I just have to kind of, at some point, say, I'm just going to start. I'm not going to think about starting. I'm just going to do it. It needs to get done. I'm going to do it now. Okay, Clippy, I need your help. Cannot infer the type of current listener. Consider giving this one explicit type. Okay, so it revolves around line 80 here. Yeah, putting on the workout clothes, yep. Once you've done that, the rest flows naturally. That's true. I thought it would be able to get the listener from the... Oh. Is it because this isn't compiling? It's not going to be a... No, that would be right? Let me do that. One of these. Let's do these one at a time. Okay, it's not that one. Okay, both of them are bad. One at a time then. Let's do this bottom one first. 998. It expected a ref cell, but it saw an option instead. Huh? Oh, equals, yeah, that's not going to work. This would be listener dot borrow mute, right? How do you put something into a ref cell? Ref cell, please. Do I just do a new and assign it? Oh, replace. Here we go. Replace. Okay, cool. That was the bottom one. Now the top one. The top one's problem is what? Type annotations are needed. Really? I wouldn't think it would need a type annotation for current listener. That's something that you get from when we take the option out, but we put in the unknown type here. I guess it can't infer across for futures. Okay. RC ref cell option TCP listener. Okay, why did that not work? Oh, maybe that's why I couldn't get the type inference, because there's another problem that was buried underneath them. Oh, it's the same thing. Yeah, this needs to be replaced. We took it out and we need to replace it. So does that even need to be an option? Yeah, this doesn't need to be mutable because it's in a ref cell. It does still need to be an option because ref cell has to have something in it, right? Yeah. Okay. They're for different purposes. The option is that we need to make it none sometimes. The ref cell is because we need to share it across two futures. Got it. Do you need the RC here? Maybe not. Because, yeah, we only really need to borrow it immutably. I think you're right. I need the RC whenever I am going to give it by value to do different things. But if we're just giving it by reference, actually, does that mean I didn't need it at all, ever? Let's see. Let's see if I can do it. Get rid of the RC new. Yeah, you're right. I didn't need it. Does that mean did I not need it for... I'm not needing it anywhere here anymore, right? Yeah. Does that mean I didn't need it in the pantry either? Because I could have just passed the ref cell by shared reference, right? Let's try this. Get rid of the RC, and then instead of cloning, we just allow that same ref cell to be borrowed. Borrow the ref cell. Okay. So it trickles down because now that is that. And I don't need to borrow again. And same thing with the give. It doesn't need to borrow again. And now what's the problem? Mismatch. So we just need to borrow the pools then. There we go. Didn't need RC at all. Okay, so CD, this should run its tests alone. Pantry. cargo test. Yeah, I didn't need it at all. So I'm gonna give you more points. Let's shore it up to +5 total. Because that's an improvement to another crate. Now we don't need RC at all in that crate. Perfect. So, my mind is blanking. Pantry. When I get tired, my mind blanks. So we don't need RC at all because we're using ref cell and we're not holding on to references. So basically the lifetime is not independent. That's what it's saying. The lifetime is not independent because it all gets tied back to the worker thread. We will only need RC if the lifetimes are independent. No need for RC because no need for RC in this crate. Let's just say no need for RC. Where are we using it exactly? Oh, for sharing pools, since it's all in the same lifetime, essentially. Thanks to Sarian for pointing this out. There, I give you attribution. And well, I'll have to publish that later. In the meantime, back to here. Catching up to Silmouth. Yeah, you are. Don't need RC. Yay. Because it's all within that shared lifetime, right? Okay, what kind of warnings are we getting now? Unused result. Sure, that would be if somehow the other future were to be completed, but it never is. This future never completes. It loops forever, right? So I should just unwrap and justify. This should never fail because the listener, well, technically it's accept connections, which holds the receiver, never completes. Never drops it. Never completes, and thus never drops the receiver. Well, I should say both, right? It could never complete but drop the receiver. Never completes... I could just say it the other way around. Never drops the receiver. There we go. Okay, what's my next warning? That because I haven't finished writing that. Can I quiet... I can quiet these, but I don't know how to quiet the one about self. What's this one telling me? Oh, it's telling me I don't need to box it at all. That's fine. I'm going to have warnings there anyway, so I'm not even going to bother with that. Maybe I never need those traits. I'll wait until the end for those. Okay, so it's compiling. Is it doing what I want, though? In order to test this, I'll need to have something connect to it. Right? We should annotate where all these other things happen, right? So this should say starting, accepting connection, now accepting connections on port, whatever, right? New listener dot, that's interesting. Again, we are not getting autocomplete help. It's like this one. Local address on wrap port, right? Oh, is this wrapped in something else? Uh-oh. Recursion limit reached while expanding that. Consider adding more recursion limit. Okay. Is it because it's inside one massive... it's in one side, and it's inside of one massive select. I could probably fix this by moving these async bodies out, right? Would that be more clear anyway? To define these out separately? Yeah, let's do it without doing recursion limit stuff. Let's say we'll just give them names. So this first one is, hold on, I have to do it inside the loop, don't I? What's the name of this thing? This is acceptor. Equal this. We might as well fuse it while we're doing it, right? Well, I'd rather fuse it in place. So this is acceptor. And then this one is, what should we name this one? Listener receiver? The listener receiver is already a word. Oh, it's actually listening for messages, so message handler. There we go. No recursion limit problem. We define our async blocks separately. Actually, that also helps cement the fact that they are captured. All right. Okay, we're not using the connection there because we get the address separately, which is kind of weird. Usually with the connection, you can ask it for its local address. But this one you can't. I wonder what its type is. TCP stream. I thought you could ask a TCP stream for its local address. So can't I say connection dot local? Yeah. Well, so why do they bother giving us the address if we can just get it from the connection? Who knows? Okay. Maybe this is the remote address. That might be it. Maybe we can't get the remote address. Ah, yes. Okay, that's what it is. We can get the local address from the connection, but we can't get the remote address. So that's what this is. All right. Good. Okay. Should just try it. It should just sit there listening, and then when it gets one, it will say connection received, and then it should immediately drop the connection, but it should go back to listening again, right? We should probably print something there. Accepting next connection, right? Let's just try it. So, run Jeeves. No example name Jeeves, because I'm in the wrong directory. Run Jeeves, please. And we got a panic! Yay! Where do we get a panic? Okay, so easiest way to get to see the panic would be to go to Jeeves. There. And just hit debug. See where my panic is. There's my panic. In this thread, while we were doing what? Called unwrap on a none. Oh, we got a none from the listener receiver. Why did we get a none? We got a none from this channel somehow. That unwrap failed. Oh, wait. That's my fault. Right? No. It should be something. I put it in the something. Oh, did I not remember to put it back? I put it back immediately. Oh, that's weird. The sender shouldn't have been dropped. Like, it was this unwrap. That's the problem, right? If the sender is dropped, then the message it would be this unwrap that we would get hit. But I think it was this unwrap. Actually, I don't even remember now. I'll have to run it again. I also need to use the restroom. Did it print anything out before it panicked? Yeah, it didn't even print anything before it panicked. Yeah, I need to take a quick break. Just a minute or so. Be right back. Hello, friends. I'm back. Find out where the panic was. It's right there. So it is in the this first unwrap then, right? So listener, it's too bad I can't even. You can't see much local variables in this mess. Oh wait, is it shared? Did I mess that up? No. It's moved into this async block, right? Oh wait. Is it moved in here or is it shared by reference? There's 715209. You're back, huh? I didn't say hi to Dr. Cheese Wheel though. I missed that one. Hello. Hi, sorry it took me 16 minutes to say hello. Towards the end of my stream, I kind of get focused on problems and then I stop paying attention to chat. It's my fault. Okay. I feel like putting breakpoints around here to see what's happening. Wait, this feature here, won't it complete almost right away? Because there's no listener? Don't I need an else here? I think this is a problem. I can't accept if there's no listener, can I? Yeah, I need to have an else, I need to have an else here to not complete this feature. Yeah, so this should be, this is not related to the problem, I think. This is, well, it might be. I don't know, this, for all I know, this could be, because I'm kind of tired. But this, we don't want this feature to complete immediately just because there's no listener. This feature should block forever and never complete if we don't have a listener. This should say future pending. Oh, wait. I doubt that that's the problem, though, so I'm going to assume it's going to crash again and debug again. But hey, maybe it will work. No, it crashed again. Same place, maybe? Ooh, different place. Ooh. It's a multi-borrow thing. Already borrowed. Okay, so it can't replace it because it's already borrowed. Where did we borrow twice? Wait a minute. Oh, this is still holding on to it while it's waiting. Yeah, we can't do that. I can't do that. This has to first borrow mutably, take it, and then do a match. Let current listener equal take it out, borrow to take it out. Then once we're done with the borrow, then we can do the if let. All right. The subtleties of refcell. Hey, there we go. It's waiting for a connection. Can I get another terminal? I guess I can use this one. And we can see both. I can do that. And from here I can go to target debug. Is it target debug? Oh, no slash in front. Target debug. Yeah, we got rover here, right? So rover, is this an old rover? Oh, this is old. I don't want to use this one. Yeah, I need to build first. I probably can't build while this is running. Cargo build. thank you for the follow. I appreciate it. So now do we have more than one executable? No, it's old. What's going on here? Oh, do I have to do build example? Rover? Yes, that's what I did wrong. No, that's still old. It's not the 23rd. Where did it put it then? Rover at EXES. There's a whole bunch of them. Oh, it put it under target debug examples. Ah. And there's Jeeves too. Look at that. And it looks like we have some old versions of Rover from yesterday, which have weird little things on them. Anyway, run Jeeves. Couldn't compile what? Why not? Link error? Whoa. Why am I getting a link error? That's new. Why am I getting a link error? Can't open file debug example Jeeves.exe. Oh, is it still running? Oh, I'm dumb. It's still running in the debugger. Now I can build it. I actually might as well just keep it running in the debugger though, right? So start it running and then from this window run Rover. So Rover will please go to localhost 8080. Connecting. There we go. And we got a panic. Look at that. But we got accepting next connection, connection received, accepting next connection. Okay, so it's somewhere else. It looks like the listener made it all the way into where we're accepting connections, which is good. But we panicked somewhere else. Let's find out where. Here, unwrap. Oh, this problem again. It got a none back from the listener receiver. Why did it get a none there? I don't get it. Is it that the other one is getting an exit or something? I guess we should do more print debugging. Print line. Waiting for listener. I think, right? Or really, waiting on listener receiver. This is actually not a really good name because right now we're receiving listeners, but we could also receive a message to stop listening. I'll need to come up with a better name on that. Let's just say waiting for messages. This is accept connections. Let's put that in front. Why not? Why not? And then let's go to the other one and do the same. So this is all done in a stream, right? So this is handle messages, waiting for messages. And then, well, it's going to be processing messages. Here we should say got message. Let's do the debug on it. Will I be able to do that, or do I need to implement debug on this thing? Probably need to implement debug. Might as well, right? So that's this. Let us derive debug on that so that we can print them out. There we go. And then what's next? So I'm printing that already. Let's do that there. I should have something when we get to the end of the future, though. Saying something like exiting, right? Exiting. And then it shouldn't happen, but I might as well have another print statement when we enter and exit the accept connections. Entered. Exiting. This should never... In fact, I bet the compiler's going to tell me it can't happen. Yeah, see? Dead code. Unreachable statement. We trust you, Rust compiler. Alright, so I suppose debug again is what to do now. Okay. Entered accept connections. Waiting for messages. Handle messages. Got a message. Start listening on all this junk. Now listening for connections. So handle messages says now we're listening connections. Accept connections says now accepting connections on that port. Accepting next connection. Waiting for messages. So these are the two features it runs in parallel. What's handle messages doing? It's probably waiting for the next thing, right? So now I'm going to try to connect to it again. All right, so then what happened here? Connection received, and then it dropped it, and then went back to accepting the next connection. Oh, that feature also woke up. Oh, right, because we make a new feature every time. So we abandoned this feature and re-entered it again. Is that the problem? Maybe we're waiting and we're holding something while we're waiting. The end of the future sounds like a science fiction short story. Yeah, it does, doesn't it? I'm hungry. Who's cooking dinner tonight? Hey, wait a minute, aren't you? You're cooking dinner, right? You. All right. Somehow the listener receiver take is none. But, oh, was the tail none? Is that the problem, that this stream is somehow none? There's something I'm not understanding about this. You can't await on that line, right? This is waiting for the thing we get back from into future. I mean, I haven't used into future that much, right? Just learned about it today. And that was here, right? Converts this stream into a future of next item tail of stream. If the stream terminates, then the next item is none. So the stream shouldn't have terminated, right? The return feature can be used to compose streams and features together by placing, right? Note that because into future moves the stream type must be unpin. Well, the compiler would have told me if I didn't do that right? So yeah, this consumes the list. So we took it out, unwrapped it. It had to be something, and we consumed it with into future, right? It took the stream and converted it into a future, and then we waited on it to get these two back. And then what I intended to do was take that tail, which is the tail of stream, like what they did. They shadowed stream with the tail of stream. That's what I'm trying to do here. Although I have to put it back into an option, so that's why I did a sum. So the second time around, it looked like. So the first time around, am I looking at that right? Wait a minute. Shouldn't it have printed waiting? Yeah, waiting for messages, right? After that, when it got to there, listener receiver should have been something again, right? Hold on. Where's the initial waiting for messages that I should have gotten before now accepting connections? Oh, right here. Oh, it called it 3 times. Oh, I know what happened. Okay, I figured it out. And I think you already told me. One of you told me already. You've taken the thing, then wait, and while it's waiting, it's... Right, yeah, you're right. Yeah, you got it. You got a Sarian. Yeah, so we should not... What should I do here, then? If I can't wait here, how do I get the stream back out if the... Does that mean I have to do this outside of this async? I think that's what that means, right? Yeah, I think that's what I have to do. I have to do this out here and not wait on this. I suppose that means... No, I can't do that either. Okay, how am I going to do this? I need to not take and put it back. I need to do this without doing that, right? I don't see any other way though. What if it gets canceled? I don't know. No, I can do this outside because this isn't a loop. Yeah. So I can at least do this first part where we get these two, where we get the future out. So this could be I'm bad with these names. So instead of waiting for it, we just get it. We get a future from it, right? But what if it gets canceled? How do I recover it? How am I going to recover that future? Do I need to box that future and reference count it somehow? Because if we never complete that future, I need to get it back. Yeah, okay. I think then I can't ever let this future get canceled. It's in the futures crate under stream extensions. Future stream extensions, the into future. The alternative was to do next, right? Creates a future that maybe this is what I should be doing. I think didn't you say that I could use this instead? Because then it wouldn't force me to drop the stream. It would just give me a future that resolves on the next item. If that future were to get destroyed, I could still make another one, right? Yeah, I guess I can try it. So instead of into future, I would do next. Okay, so I now don't do that. The listener receiver doesn't need to be in a option at all, but I do need to make it mutable. And then this would not need to take an unwrap or into future. It would just be next. And then this would just be message, right? Yeah, there we go. So if, while we're waiting here, if the whole future gets canceled, then the next time through, we'll just resume waiting, right? Presuming that is supported. I would imagine it would be. Let's try it out. Okay, so waiting for messages, got a message. Waiting for messages again. Oh, got a second message. Why are we getting 2 of them? Wait, is that a bug? Hold on. Why did we get 2 start listenings? Control C that. Oh, that's interesting. I didn't get my stop either. Did it just crash? Or we're not attached to the same terminal. Oh, that's what it is. How do I get back to that terminal then? How do I send it Control C? I guess I can't. Okay. I should look for got message. It isn't. So we got. How did we get 2 messages? We shouldn't have. I don't see why we would have gotten 2 start messages. Did I call start twice by accident? Well, I can put a breakpoint on start, I guess. Start. Put a breakpoint there. All right. How many times does it get called? There's the first call. Wait a minute. That doesn't make sense. We haven't even sent it yet. How are these just old? I'm starting to think these are old messages. So to be sure, I can, I can close this terminal, right? How do I close the terminal? Trash the terminal. There we go. I trashed it. Trash this terminal. There we go. No more history to confuse me. Debug. Okay, yeah, so it's old. It was old terminal garbage. Kill it on the trash, yeah. Run. Run again. Wait a minute, why are we re-entering start multiple times? I think it's because I have multiple things in here that it got confused about where the breakpoint was. Anyway, there's only 1 start listening message after all. Okay, good. Now does Control C work? Control C looks like it doesn't work when we're debugging because it's still running. I bet I can do it through here, right? Okay, this is sort of a side trip. I want to be able to send a Control C and make sure it's working. Can I do that through here? Would it be SIGINT? How do you send a Control C through this? It won't work through the terminal. That just does that. That just detaches somehow. I guess we can just run it. So cargo run example G's. And then controls, yeah, so it works. All right. Never mind. Okay. Connect. Hey, it worked. The server didn't crash, it got its connection. Look at that. It's just working. Control D, I could try that. Control D. Didn't do anything. Control Z, no. It would be nice if there was a way while we're debugging that I can send it a Control C. It is fixed, yeah, we fixed it. The problem was that one await that I gave Sarian a just 1.4. I should give more for that. That one was a tricky one. I think it's worth 3 total. Yeah. That's why you have a habit of clearing your terminals. Yeah, maybe I should get into that habit. Is this something that I should just do a Bing search on? Why Bing? Is it just Bing? Yeah. Use Bing because Google search will tell me, will show my zip code at the bottom, and I hate that when I'm on stream. I don't want it to say where I am. There should be a limit for holding locks and stuff across awaits. Yeah, it does. You just do a Google search and look at the bottom of your search. It'll tell you what zip code you're in. It's scary if you're streaming. All right, so then I wanted to look up Rust analyzer debug send control C. That's the handler. How do you send it when debugging? Here we go. That's JetBrains though. There's the stop. Doesn't. Yeah, if it was on Unix, I would just do a signal sig int. But Windows is different. Is this it? Cannot send control C or control break to spawn debug console. It's an open bug with VS Code. CPP tools. Yeah, so we can't use the debugger terminal in VS Code since we aren't hooked up to that yet. Yeah, okay. Well, maybe I just, if I need to do control C, I don't do it in the debugger? Doesn't seem possible to control C in the debug console. Kill-S, what does that do? That's for OS 10. Yeah, okay, so it's an open issue with VS Code. That's fine. It doesn't point to what street you live on normally. It depends on how densely populated the zip code is. In a major metropolitan area, though, it can narrow down quite a bit. Like, it could basically say what city I'm in, and even what part of the city I'm in. So, but if I was living in an area which was much more rural, then it would just be, yeah, he lives in western Minnesota somewhere, you know? Depends on the size of the zip code, essentially. Anyway, I think this is working. I can't hit Control C, but I can hit the stop button on it. Unfortunately, it doesn't go through this process, but for a good test, I ought to just run it here, right? And then connect to it. I believe this pause is the DNS lookup. There's something going on my computer where localhost and local domain lookups take a long time. But you see it working. It's a working. Okay, then Control C exits cleanly. All right. This is a good checkpoint, right? So we have something that listens on the right port, accepts connections, drops them immediately, but all the other mechanics work. Oh, wait, I should add in the stopping of the server, right? To change the port number, or looking at it a different way, it should be that we should be able to restart the server on a different port. So what if I do this? What if I have it rotate ports? How would I do this? I make this into a loop and turn this into a timeout. I had a nifty little thing I did in, was it Pantry? I had this delay async thing. I'm going to steal that. And I'm going to put it here. And I'm going to uncomment it. Whoops. There we go. Standard time, right? Okay, so what I can do is I can have a might as well just make it a for loop, right? For port in 8080 to 8090. Start. I forget what that. Yeah, see, why do I have a bool there? I'm already regretting. It's the TLS one, right? I should not use a bool. I should have like use TLS or do not use TLS enum variants. Passing in a bool to a API in Rust is just being lazy. This should be like server use TLS no, right? or use TLS no or something like that. That's what it should be, not false. Anyway, instead of doing this pending await, we will do a delay async standard time duration from seconds. I don't know, 5 seconds. Await that. So here it should rebind a different port number in sequence until we've gone 50 seconds, and then the program should naturally exit. I did this right. So let's run it. So we'll connect to the first port number if we can do it in time. Okay, now when I try to connect, it shouldn't accept the connection, right? Because it's already rotated to a different port number. But if I go to 3 now, it should hit it. There we go. So it's rotating port numbers. Cool. So that proves that that design worked, that we can, when we tell it to start, it will abandon its previous listener even when it's trying to accept a connection, and it will pick up the new listener and start listening on it. Nice. I like it. Actually, I'm kind of curious now if it will end naturally after 80-90, or 80-89, right? So after this, it should just quit. Nice. We even got the exiting we were hoping to see. Accept connections never exits, right? But this one does. It just works. Isn't that cool? It's just like Rust. It's like this language was designed to be safe or something, you know? So I don't need this stuff anymore. Cool. I think this is a good checkpoint for checking in. I can keep streaming, although when dinner's ready, I'm gonna have to stop. HTTP server. Actually, I never made a Git repository for this, did I? Git init. Git checkout b main. Git check branch d master. There's no branch name master because I never made one. Git GUI. It will be a brand new repository. So check everything in as initial revision. Do I want to say something more? I can say this. Allows you to start up a server which listens for connections and can be told to switch ports at any point. Incoming connections are dropped immediately, however. You also can't make it stop listening without dropping the server. Yeah, essentially. We can also say resource handlers are defined, but not yet used. Cool. So, gotta make a new repo for this. Git remote add origin, git at github.com, http server.git, which means I need to actually make it in GitHub, which I'm going to do off stream, because I don't like showing GitHub on stream. No biggie, I'm just clicking new. I'm typing in the letters HTTP server and hitting the create repository button. Waiting for a few moments, and then git push-u origin main. And now it exists. And now you all can get the code if you go to github.com, Rymut 8354, http server.git. That should just work now. Yep. No releases, no packages, no docs yet. Should get the GitHub CLI. I only use the GitHub for like a few moments, really. The only time I really ever use GitHub these days is when I'm creating a new repository. Everything else is through the Git command line anyway. All right, so we're gonna keep going now. Anybody getting tired? It's probably really late for some people. I've been streaming for 6 hours and 45 minutes. This is a really long stream for me. Let's try to get the actual HTTP into this server now. So I think I need to introduce that third set of futures, right? Once we get a connection, we got to do something with it. Right now, we're just dropping it. Oh, thank you for the follow there. Nearly 1:30 in the morning there. I hope I'm not keeping you up. Learning for exam tomorrow and not doing a good job. Yeah, I'm just distracted. I'm like the cause of so many people failing their exams and staying up too late. Hey there, Ace Squared. How are you doing today? Or this morning, or this evening, depending on where you are. Okay, so we're getting a connection where? Where am I getting a connection? Here. We're getting the connection, and it's actually warning us that we're not doing anything with it. It's just going to get dropped. We should all play Among Us again? That would be fun. When do we want to do that? You guys want to play Among Us at some time? Could make it a Raimu Among Us stream. Or do it on the off stream or something. Yeah, I played Among Us with Ski Dog. I played it with CM Griffing. And that's it so far. Could you please share some good learning courses for Rustlang? I actually don't know of any good courses, but I do highly recommend if you just go search for Learn Rust. If I were to type it correctly, yeah, this very first link. Because what I did to learn Rust was I read the Rust book. But if you don't like reading it conceptually, they also have a book of examples. If you want something that kind of guides you, there's this course, but I don't know how good it is. So I can't recommend it or not recommend it. It's up to me whenever. Yeah, I'll have to organize something. This is all I know about how getting started, because this is what I did about 3 months ago. That's right, when he gets set up in his new house. If anybody in chat has recommendations for Rust language courses, please post. But yeah, this is where I would start, if nothing else. The book is, it's okay. I don't know if I would say it's very good, A squared. I struggled a bit with it. There, especially the async book, which I don't know if they actually link to, but I'm doing a lot of async Rust today. There's actually an async book, and there are a couple problems with it, like it's not done. You click on these links, they don't go anywhere. They go to a 404 page. And it's been like this all year, so, you know, can't recommend this book for learning asynchronous programming, but maybe when they finish the book? Yeah. Hey, no problem. SRE DevOps. I should say hi to you, because I haven't yet. Hi. Yeah, but for the for the synchronous basic Rust, the rust-lang.org/learn is a good starting point. Another thing you could do is just hang out in other Rust Twitch streams. So twitch.tv/team/Rust stations. Anyone in that team will probably be streaming Rust at some point, and that's what I do. When I'm not streaming, I'll watch like Mr. Halsey or Musin or Ecton Dev or someone else who's doing. I've been watching Togglebit a lot recently, and they just watching other people use Rust. I learn a lot, and I'll ask questions in their streams like, what exactly does option do with OK or, and just random stuff like that. And they've all the people I've seen in that team have been really helpful and happy to answer questions about Rust, which gives you that immediate feedback. And also, it's also nice to help them out whenever they get stuck. I try to do that too. All right, we're going to do something with this connection, right? Do I need this replace? I don't need this, do I? Oh no, I did take it out. Why did I really need to do that? I did need that, right? Actually, why? Why did I need that? Why did I need to take it out? Do I need this to be... in a refs. I need it to be in a ref cell because it's shared between two, but do I need it to be? I do need it to be an option because it starts out as none. That was the thing, right? Because if it's not some, we need to wait for the other future to get us one. I should probably comment that. Let me comment that now. So this future should only do something and complete if we have a listener. If we don't, we need the other future to complete, and we have nothing to do here, so never complete. Okay, and at this point I want to say something like, here we wait on the listener for the next incoming connection from an HTTP client. Okay. I should say something about this replace, shouldn't I? This complements the take. So I should say something like, if we get a connection, if we get a connection, we need to put the listener back so that when we loop back and run this future, I'll put it in quotes, run this future again, technically a new future is made with this same async block. We can take the listener back out. I should probably also explain why we're taking it out. We're taking it out because it might be none. And if it is some, yeah, why do I need to take it? We need to take it because it's in a ref cell and we need to temporarily borrow it. Right. So it has to do with that. I should explain why. Listener is in a ref cell because two separate futures need to access it. Acceptor takes the listener, uses it, and potentially returns it, or puts it back. And the other one I named message handler puts places new listeners there. Places new listeners there. Potentially dropping any previous listeners that might still be there. Which is what we saw when I was rotating ports. Okay, let me catch up in chat. Yeah, John Hu, I recommend him as well. He's on Twitch, but his stream is primarily on YouTube. And he has a different format where he will kind of take questions through a more like moderated means. Like he'll collect questions through some kind of app he uses, and then he'll kind of go through the questions in order. So it's not quite as dynamic as, say, my stream, but I have learned a lot from some of his YouTube videos. His one on lifetimes was really helpful early on for me. So, yeah. Just look up John Hu. He's in the Team Rustations, and there are links to his YouTube from there, and you can just search him for him also. So confused, literally, I have no idea about any of this. It just seems interesting the way I talk about it. I tried to explain in my comments how this stuff works, but what's really hard to grasp I think for most people, including myself, and why it took me so long to write this and code like this in the last couple of days, is the flow is not linear through this code. Whenever you see an async, what this is doing, I'll collapse it to illustrate. This is just setting up a variable. What's the value of that variable? The value of that variable is the combination of some data and some code. And we're not running the code yet. We're running it in the future. That's why the name is future. So we set up some data and some code in these two variables. And then we say, hey, basically the future system, I want you to run the code in both of these, whichever order. Doesn't matter to me, right? You can think of them as conceptually running these two things in parallel, but waiting until one of them finishes. If the other one's not done, just toss it. Just toss that code, toss that data. We don't need it, right? So, for example, if acceptor is still waiting here to receive a connection, it's still stuck there, and then message handler gets all the way to the end because it's gotten a message. This just, poof, gone. It never returns from the accept await, and it just vanishes. So that the concept of these two blocks of code being in parallel and then potentially never finishing is really hard to follow along and understand if you're used to a traditional imperative programming style where the computer essentially runs from the top down. Maybe there's some loops, maybe there's some branches, but essentially there's always a linear flow through it, right? This is very non-linear. This is like, here's some code that they're going to run sometime. Here's some other code you're going to run that too. And hey, just run them both right now at the same time and let me know when the first one is done. I do count on some things in the implementation of this, though. I know that the way futures work in Rust, you can only run one of them at a time. So what happens is it's going to pick one of these two at random and run that one first. And it will run it until you hit an await. When you hit an await, there is a potential point where we might switch to a different future or continue. It depends on if we're ready or not. So if we had a connection already ready to accept, it wouldn't wait. It would just say, okay, here's the connection, and this future would continue going. But if there's no connection at the time we reach this line of code, then this entire future kind of gets pushed onto the shelf, and then we'll flip over to this other future and say, well, are we ready to do something with this listener receiver, right? Does it have something next for us? And if neither one is ready, they both get put on the shelf, and then the thread just sits there asleep, and you don't use any CPU. And that's one of the advantages of asynchronous programming, is that if you have nothing to do and you're waiting, you don't just sit there twiddling your thumbs. Your entire thread context gets put in a state where you're asleep. And then there's a whole mechanism under the hood about how it wakes up. But essentially, whenever something goes to sleep, it registers an internal callback that says, hey, when you're ready for something, like when this connection comes in or there's something in the queue, mark my future as ready to go and wake up the executor that's running them. Yeah, the pending wait, this is basically saying never escape. You will never escape this else. This future will never complete. Yeah, I should put a to-do here. This is a fancy, nerdy way of saying the following. So, little future, guess what? You're never going to escape. So just sleep here forever. Now we know, well, I should say that it's important to recognize that there are two ways that you can, two possible ways that a future can be handled. You could actually complete by escaping, like this one escapes as soon as this match is done, right? That's called completing a future. The other way is if the future never gets completed, but it gets dropped. So what this select does basically is says, here's two futures. Complete one, drop the other. And which one you complete? The first one. The one you drop, the one that lost. It basically, we're setting up a race between two futures. Whichever one finishes first gets to complete. The other one gets dropped. The thing about this pending thing, it's a future that never completes. So, by definition, the only possible way that this future could be handled is it gets dropped. It gets dropped because this other future completes. It basically, this holds up the acceptor so that it never completes, and it waits. It's basically a way of saying, I want to wait until the message handler completes. So there we go. Took for programming freshman year, forgot most stuff. Yeah, a lot of learning, I think, comes from actually implementing, like actually using the skills in the real world and then running into problems, and then making mistakes, and then learning from that, and then just the repetition. Like for me, it's repeatedly using these types like ref cell, an unbounded receiver, an option. The more I use these types, the more I remember about them, and the less I have to look up in the manual. So like for the first couple months, I had to constantly look up option because I had no idea how to use an option. Because there's and there's and then there's is none, is some, map or else. Okay, I had no way to keep track of these. But then over time, I got used to what some of them mean. And also, there's a really helpful cheat sheet that I got from Museum here, which like if you have an option and you want to make, let's say you want to make a result out of an option, then it's okay or, right? Or okay or else. And then if you want to get into the nitty gritty detail, like, okay, it's one of these two, which one is it? You just click on them and read it's like, this is if you have an error pre-computed. Whereas okay or else is if you want the error to be computed by calling a function. So it's helpful to have the manual with some cheat sheets to begin with, but after a while, you just the repetition kind of helps you learn it. And I think this is true for any language. Feel like borrowing a little bit of C really helped you understand Rust? Well, certainly, because a lot of the elemental pieces of Rust come from other languages like C. Like loop is just a while or a for loop where the condition is always true, right? It means loop forever. You could also call it's repeat in other languages, right? Assignment is the same. Printfs are pretty much the same. The structure of if and else pretty much the same. I mean, the little wrinkles that we throw in with Rust, like the lets and the if being combined with assignment, if it's an if-let with this pattern. I mean, but the basic structure, if you learn C and you only know C, you can look at this code and you'll see, oh yeah, this is a conditional that has two alternatives. We either run these two lines of code or we go in here and there's just a comment and we don't do anything, right? You will at least get that much down. Rust is not a language for beginners. No, it's not. Rust is certainly not a language for beginners. And most of it has to do with how there is a lot of extra stuff in there for doing type safety and data safety. So yeah, there's a lot of type language to remove concepts like null pointers. There's no such thing as a null pointer in safe Rust. The closest you can get is you make your value optional, and none is the rough equivalent to null, right? And then the compiler makes sure you never dereference a none, because none can't have a value, right? Fundamentally, an option only has a value if it's something. If it's none, there's no value. So the compiler essentially makes it illegal to ever dereference a none. You see how that is both convenient and confusing and difficult to understand? With something like C, it's like, oh, I have a pointer. It might point to something or it might not. And you kind of like, okay, it's always pointing to something. That something could be the illegal none, zero value, null, or it could be something legal. Whereas this, it's a little bit confusing because it's like, okay, it's one of these two, and you don't really know until you do some kind of test, like an if-let, where we're doing a pattern match, essentially. We're saying, does this match this pattern? Technically, you can make a null pointer in safe Rust, you just can't use it. Sure, I'll give you that. Yeah, there is the unsafe toolbox in Rust, I like to think of it, where if you open that unsafe toolbox, you essentially have C again. All right, I think I've been chatting long enough. I should try to do something with the connection, right? So right now the connection doesn't get used, so essentially it gets dropped immediately. Instead, we want to use it, and the way I want to use it is I want to tie it with a feature that will resolve if we actually get a request. Actually, you know what? Take that back. There are a couple ways we could resolve a connection. We could either process one request and it's marked with connection close, or it could resolve because the client sent us something that was an error, or it could be that the client closed the connection. So there are multiple ways we could leave it, right? I was thinking about this before, right? And I was like, we should break the work into different sets of futures, and this is where I wanted to put the connections. So if I wanted, maybe I just use the same pattern where I have a handle connections, and then maybe I have a connections receiver, connection receiver. Fuse that bad boy and do that. And then I need to define that. We can use the signature of accept connections for a actually, there's one problem though. We're going to have multiple futures, aren't we? I think maybe I want to do the same thing same technique I did with the pantry, where this just handles a collection of futures. Start with Python if you've never actually programmed before. Yeah, I would second that. When in the past people have asked me what language they should start with, I usually recommend either JavaScript or Python. The reason why I throw JavaScript in there is that it is easily applicable to web stuff, and that's very popular. And very useful, actually. If you know JavaScript, you can make your own website for yourself to give yourself and make yourself look more professional when you're looking for a job. You can say, hey, I built my own website. And yeah, immediately applicable, and there are jobs out there for it. And yeah, but Python, good language to start with, yeah. So I think what I want to do for this is a similar kind of loop to what I had in the pantry for monitor values, where we have a loop and we are keeping a vector of futures, and each future is going to basically process requests from a different client, right? And every time we loop, it'll be because some future completed. And when a future completes, it either gets dropped or the future might be completed because we have more connections, right? So we'll basically be continuously maintaining a list of connection futures. Do I need this kick thing, though? I'm thinking I do because of the way this select all works. I think I just want to copy this exactly as is to start with. I want this exact model because it worked really well here, and I want that back over here for accept connections. All right. JavaScript is like the most popular language out there. Lots of great learning. Yeah. If you want to start with JavaScript, freecodecamp.org is what I'd recommend starting with, because you learn not only JavaScript, but HTML, CSS, and that enough JavaScript so that you can make a fully functional website, or at least get started learning other things like React or Angular or Vue or whatnot. Okay, gotta hydrate. Losing my voice. It's 6:43 for me. I have a hard stop at 8 p.m. I would really like to eat before then, though. But someone needs to cook dinner. Oh, you're cooking dinner? Hooray! Thank you for starting to cook dinner. So at my house, we have a rotating dinner cook schedule. So I get to cook on Mondays and Tuesdays. My kids get to cook on Wednesdays and Thursdays and Wednesdays and Thursdays. My wife cooks on Saturdays and Sundays, and Friday is a free-for-all. Okay, so we're going to get a connection receiver, right? So this will be a connection message, which we need to define. Let's go do that. Enum connection message. You know, I'm thinking I'm going to define it right next to the function. Whoa. Yeah, right next to the function because it's immediately applicable to it. It's going to be very similar though, right? Actually, you know what? I don't even think it needs to be an enum because we're never going to do anything other than deliver a new connection to be processed. Yeah, so why bother having an enum? Just make it a receiver of connections. There we go. We have that type, right? Oh, I need to box it though. Right. So it's a box connection. Because we might have a TLS wrapper around it at some point. You have no idea if that means you're 15 or 25? Oh, because of how old Khan Academy is? Yeah, isn't Khan Academy? It's been out there for a while. Okay, I don't want to call these monitors. I want to call these processors. Processors. Connection processors, right? And we're going to extend with what we receive. Oh, then I don't need to do it here. I don't need to do that here at all. So this is much simpler. Yeah. Yes. Yep. Okay, we don't need that. We don't need to do that either. And I actually I do need this. If we need the kick, then we're making the future which pulls out the next from the connection receiver. Do I need to call it the kick, though? I don't think we need to call it the kick. Add a special future. Let's just say add a special future to receive the next connection. Let's rename it from needs kick to needs next connection. I like that name better in this context. Okay, so I don't think I need a one shot. We just need to assign it, right? And we'll call it the next connection. And then we're going to push it into the processor list. Okay, and then don't need these next connection. Right. Don't need these comments here, right? Because this is different. We're not going to receive it from a one shot. Yeah, this is different. I do need this type though, because that tells me if the future that completes is the one that monitors the receiver. So I need a type for that. Similar to this. Put it here, I guess? Sure. This is the type of value returned by a completed connection processor. A completed future selected by accept connections. Essentially. It's used to tell the difference between a future which processed a connection from a future which processed the connection receiver. All right. So let's say processor kind. And this is connection, and this is receiver. All right, and then so we'll get processor kind for this one. It's processor kind receiver. And for the other kind of futures, we'll get processor connection. Okay, so then if we need one, the output indicates that this is the future used to receive the next connection. All right, and then in the meantime, we had to do the same thing I was doing. It was with next, right? Yeah, it does this connection receiver dot next dot await dot unwrap we can do that safely because actually wait a minute, I don't know if I can do that safely. Who's going to own these who's going to own the sender? Oh wait, this one where we have an unwrap on the receipt, this one right here, I don't think that's actually safe to do. There should be a kicker. Okay, this is an old comment. What's this? Red Rampage Crumpet has converted their Twitch Prime sub to a tier 1 sub. Thank you, Crumpet. It is a long stream today. It's past 7 hours. I'm going to go until there's dinner. That's my goal. Alright, this comment is old. In fact, it's possible for this to fail. I think what I want to... So what happens is this receiver is coupled with this sender down here, right? This sender, when it gets dropped, the receiver will fail. So, and it gets dropped when handle messages completes. And that could complete... That'll complete on exit, right? So if it does exit, and it's possible... Well, it should complete the future select, which should complete the worker. But it's safe to, let's just say, handle the possibility that, hey, it handle connection is completed, but for some reason, or the other way around, handle messages completes, but handle connections is still running, right? So inside, or accept connections, handle messages completes, but accept connections doesn't, right? So if that's possible, then this might not be something. So I think I just want to change this around to be a sum, and then we'll be safe, because I just need to add a none to this, right? Yeah, missing arm none. So what do we do if the other side breaks? We might as well complete the message handler ourselves, right? No, we should hose it forever. The reason is that if we don't, it's going to re-enter here and constantly fail. We want it to hose up, yeah. And I should have a comment here about that. So I can combine these two. There's no need for that there. Okay, so if listener receiver, what's the term? Completes? Has no next. It means the sender end which should be owned, which is held by the other function, handle messages, was dropped somehow. This can only really happen if that future has completed, which only happens if the worker thread overall is told to stop, told to exit. In that case, we don't want to constantly loop trying to get the next message here, because it would just waste. It would waste CPU. Waste CPU time. It's safe to just enter a pending future and let it get canceled. Yep. Wonder how that stream extension next works. Does it reserve an item for the stream without blocking the stream for everyone else? Well, this is for a single consumer, right? It's a MPSC, so there is no other consumer. And it doesn't block because it's an unbounded channel, so when the senders send more things, they'll just allocate more memory. And it's fully decoupled, right? There is no locking. I think under the hood they use atomic non-blocking or lockless data structure. Like I have one myself. I call it something similar. It is called, where is it? Multi-producer single consumer. It's a lockless multi-producer. Yeah, it's lockless. And I didn't come up with the algorithm myself. I gave attribution to where it is, but you don't ever need to block in this. The downside is that you will, every time you add something, you're going to allocate memory, right? But yeah, it's okay for the receiver to block because the senders can just constantly tack more onto the other end of the queue, and it's fine. If it was a multi-consumer, then I think we would have a different issue, right? Like what you're saying, it might block other receivers, but this is the only receiver we can have here. All right, so I think that's a good enough comment to explain what that's doing. I don't even need a blank line there. That's fine. All right. So I want to do a similar thing up down here, right? In here, we instead of unwrapping, so I'll maybe have a similar comment. All right, down here. And indent that. I wish it didn't have the red squigglies. It's doing that probably oh, shoot. I can't indent now? Oh. Because I accidentally hit a key. Get rid of tab moves focus. There we go. Everyone else was strange phrasing that, but does the rest of the stream know not to take the next item, but instead forward the wake to the future instead? Well, there is only one receiver of the stream, so the rest of the stream, do you mean like the other items in the channel? Because those just get dropped if the sender... no, it doesn't get dropped. Wait a minute, you just made me realize something. This doesn't happen, right? The next should always succeed. Why would it ever fail? Let me look this up. MPSC. Unbounded receiver should never fail. Yeah, why would we get a receive error? Oh. If you call it after the stream is ended, it'll panic. Oh, but that's a panic. What about, when would we get a try receive error? Why would we ever get that? Maybe it describes it here. A send will always succeed as long as the receive half has not been closed. If the receiver falls behind, messages will be arbitrarily buffered. Note that the amount of system memory is an implicit bound. Using unbounded channel is the ability of causing the process to run out of memory. It doesn't say when the receiver would ever have an error. Is that why? It's just that the next is generic. The try next for unbounded receiver does have a result, though. Let me look at the code and see why it might. If it's marked as pending. Huh. That's the try. That's the synchronous one. It's supposed to return an error if it's not ready, right? Yeah, okay. So I think you're right, it will call. It's the generic stream extension next. Generically can fail, but this one never will. Yeah, even this doesn't actually have an example where it would fail. Thank you for the follow. Let me look here. Future for the next method. There's no documentation for it. I guess it's safe to assume that, maybe I should say that here. Yeah, so this comment is all wrong then. Let me give you a point. Okay, what we should say here is, then I can go back to doing an await, right? An unwrap. Yeah. And I don't need a, sum there. Wait, hold on, what? Yeah, there will always be something. It'll never terminate, would it? Oh, no, wait. If the sender closes, you get a none on the receiver, right? I remember reading that. Where was that? Yes. That's it. That's the key right there. If the sender has been dropped, then the receiver poll next will return okay, ready, but none. That's the difference. So it's not an error here. It's actually some versus none. So this stands then. That's what it is. I still give you a point though. Yeah, sending will never block, but if the sender is closed, which happens when this happens, then it's not that it gets dropped, it's that terminates the stream. Actually, let me amend this. This can only really happen if the feature is completed. If this can only really happen if there are no more listeners to receive, and where is it? Handle messages. The handle messages feature is completed. It should only happen since the worker thread overall is told to exit. That's true. In that, well, actually, yeah, that part's true. In that case, we don't want to constantly loop trying to get the next message because it would just waste CPU time. Actually, it's worse than that, right? If we get a none, we can't call next. It would be, wouldn't it be undefined? I think, yeah, we should say that. We don't want to loop trying to get the next message here because it probably says it in the next itself, right? It probably says it's undefined. They don't show it, but I think if you call next after you get none, like if they had another line here, you could actually panic. Why don't they say that here, though? I don't know. We don't want to loop trying to get the next message here because it would probably panic. I'd really like to know for sure what it would do, though. It would be what I think it would panic, right? Because it would call try next, and it would get a try receive error because it's... No, that's not true. I don't know what would happen. Should I try it? It would be hard to set it up for it to happen, though. I don't know. Let's say it would either panic or constantly... Hey there, Chris. How was your stream? I'm having a very long stream and I'm losing my voice. How are you today, Mr. Sir? Did you guys know that the chat overlay above my head was made by the gentleman who just rated us? You should check out his channel sometime. Got some stuff fixed. Did you get the biscuits fixed? Chris has been working on this really neato extension called Assorted Biscuits, where it supports any language that is supported by Tree Sitter, and it essentially adds little markers. It just doesn't show it here, but like if we go to like HTML Biscuits, I think he's got, yeah, an example, where it adds little markers to the end tags of things to kind of give you a context of where everything ends. So if your code is filled with the ends of divs and you're like, which div is which, it would tell you which one. Can annotate the chain functions better and fix some other minor bugs. Nice. Awesome. I don't know how much longer I'll be streaming, but I'm working in some really nasty, hairy asynchronous Rust. So I'm working here with, I don't know if you've seen this before, Chris, but this is an asynchronous function which loops on the selecting one of two possible futures. It's like split timelines. So basically, acceptor and message handler are two asynchronous blocks of code, in other words, futures, and select macro says, Try them both. Whichever one completes first, then run that arm. So it's kind of like a match. And the other future gets canceled. And within that, I'm doing strange things like receiving messages from a channel to communicate between this set of futures and other sets of futures. So at the top level, what I'm trying to do here is, this is the core worker thread of my web server. It will handle incoming messages, and the only message that's defined right now is to start listening on a port. And then there's accept connections, which listens on that port and accepts new client connections, and then handle connections, where once we have connections with clients, now we're processing their requests. When we get the request, we send the request to a handler to get a response, and then we send the response back to them. And then we might repeat that, because you can reuse a HTTP connection, or the connection might have been upgraded and we send it off to a WebSocket or something else. So yeah, I broke up the work of the web server into 3 different asynchronous tasks that are modeled like futures or subtasks, where we're going to just handle them all, and if any one of them completes, then we're done. So most of these will loop forever unless some fatal error happens, and that fatal error will cause the worker overall to quit. It's actually working out pretty well. It's just that it took me a while to get this pattern down, and I'm still not sure if it's the best pattern in Rust. The code gets kind of hairy looking. Okay, I'm trying to get reoriented. I'm done with the accept connections, right? So here's where we we can be receiving listeners from the main message handler, or we could be accepting connections. So the listeners come in through this listener message start, and when we get that, we take it and place it in our local memory for the acceptors. The acceptor sits here and takes it, and if there is a listener, we will accept the next TCP connection. And if we get one, then I need to farm it out to the other future, and we put the listener back. If we get an error, the listener gets dropped. If we're ever in a case where there is no listener yet, then we're essentially going to wait for the other future, because we need a listener before we can actually listen, right? So yeah, this is where I was, right? For here, I need to send the connection off. So to send the connection, obviously, I need a connection sender. So connection sender, MPSC, unbounded sender of connections. That was box dyn connection, right? Yes, and then the only thing I need to do here is say connection sender dot send, unbounded send, box new connection, I think. Hey, look at that. The compiler accepted it. That makes me happy. So that gets our connections out of here and into a channel. And now we just have to create the channel and give it to the other guy. So let's create the channel first. Up here, this will be the connection sender receiver. Let's just say here, not that we're in charge of the listener, let's say these channels are used to pass objects between the various subtasks below. Listener, sender, receiver, passes TCP listener objects or values. I don't want to use the word object because we're not object oriented. Passes TCP listener values from handle messages to accept connections. Connection sender receiver passes connection values or boxed connection values, because the reason why I'm boxing the connections is that they may or may not have a transport layer security wrapper around them. So the type is dynamic. In fact, they even use the dyne keyword for that, right? Dynamic type. So we don't know. It might be a TCP stream or it might be a TLS connection, right? So it passes them in a box so that we don't need to know the type at compile time, from accept connections to handle connections. All right, properly documented. Let's continue. So that means accept connections needs the listener receiver and the connection sender. The handle connections needs the connection receiver. Correct. So I need to, how come this isn't working? I'm missing something. Mouse over to see what the bug is. Can't find function handle connections. I thought I made that one. I didn't. Okay then. Let's make it. I thought I did, but I guess I got... Oh, I did, but I didn't rename it. Handle connections. There we go. This is the connection receiver. That's what that big red squiggly was. I need to drink something. I'm losing my voice rapidly, my friends. We're almost at 8 hours. See, this is why Chris has the whiskey. You keep the throat lubricated so you don't lose your voice. Thank you for the follow. I appreciate that. I'm losing my voice because I'm not used to speaking for more than 8 hours and I'm not drinking enough. Okay. Yes. So this is correct so far. You rarely get to use dynamic dispatch in Rust. Oh, the dispatching of dynamic objects? The first time I used it in this project was in the client. And that was... I don't even see it in my list of windows anymore. Where is it? Oh well, let's go find it here from here again. Here. When I made the TLS thing. This. If this is what you mean by dynamic dispatch. Because when we get a connection to the server, this is the client side, right? When we get to when we get the connection, we ask ourselves, do we want to use TLS? If so, we actually need to make another value called a TLS connector and tell it to connect using our connection. That gives us a TLS connection, which is a SSH or SSL wrapper around a TCP connection. It has the same interface as the underlying connection, so it's essentially what's called a decorator or a wrapper. So it has the same interface as the underlying connection, so whether or not we're using TLS doesn't matter to the upper layer, right? We simply box one or the other and put that in our connection results. Does it have TLS? Does it not have TLS? You don't really know. I suppose at runtime you could use reflection and see what is the actual type inside the box. But it really doesn't matter because the upper layer shouldn't have to care if we're using TLS or not. This is where we care. All right. Here's where I was in handle connections, right? This should be connection receiver completes, has no next. It means the sender end, which is held by this guy, was dropped somehow. This can only really happen if that future has completed, which only happens if the worker thread overall is... Actually, this should never happen. This should never happen since that future never completes. Regardless... Yeah, actually that's it, right? Actually, what is this? There's no in that case. We can just simply unwrap it. I can't unwrap it? What is this trying to tell me? No semicolon. Yes. So what do we want to do with that value? We end up with a with a connection, don't we? So then let connection equal connection receiver next await. Yep. And then that should be of type box connection. Perfect. So then with that, we want to make a future and add it to our processors. So we will do a processors push async something. It's going to internally have one. So this is really odd. It's a future that's going to push more futures. Am I going to run into a problem with borrowing here? Maybe. I'm boxing these, right? Oh, I gotta box this. That's the problem. Box it. Yeah, I'm gonna have to stop the stream soon because I've heard the call of the dinner almost ready. I think, if I'm gonna guess, dinner tonight is apple sausages. That's my guess. Because the kid in charge of cooking tonight usually cooks that. Or it could be carnitas. I love me some carnitas. Okay, this shouldn't be receiver. This is connection. And unfortunately, I'll have to end the stream when dinner's ready. Should probably try to find a stopping point now and resume this work tomorrow. Actually, this is the minimal that it'll do. It'll take the connection and simply drop it, right? So we can just leave that for now. Finish the rest of this. Okay, wait until a connection or the connection receiver completes. So that has to do with needs next connection. This is processor kind. And this is processors into iterator. This is processors left. Processors equals processors left. And then processor kind has to be this kind to, if it was the connection receiver future which completed, mark that we need to make a new one for the next loop. Okay, what's wrong? How did I break that all of a sudden? Cannot sign process because it's borrowed. Uh-oh. Oh, shoot. We can't do that. That's not the problem. What is the problem then? Cannot borrow connection receiver as mutable more than once at a time. Oh, shoot. I'm gonna have to put that in a ref cell because this whole thing gets boxed up. And that means if you call it more than once, the first time we will have dropped this, right? Oh, shoot. It was working up until I fixed these compiler errors, and now it caught this one. Okay, so I'm going to have to do something funny with that, right? Yeah. Well, I guess we'll stop here because this is going to take me more time to figure this out. I think what we need to do is put this in a ref cell, and the only thing that we're going to be grabbing is a reference. So it's okay to dispose of the reference each loop. Okay, so this is where I'm going to end. Tomorrow I'm going to pick up here and try to solve this compiler error. And then once we get this working, then the rest of the here is where we will be I'm finishing up, don't worry. We'll be receiving the request from the HTTP client. Oops. Sending it to a resource handler, a request handler, and sending back a response, possibly in a loop. Yeah, if it's in a loop, we would never actually complete we would never actually complete until we get an error, right? Or use nested features that join their subtasks instead of putting them all in the same array? Maybe. Yeah, we'll figure out how to do that. My inclination is to use something that's worked for me in the past, which would be refcell, but I'm not sure. I can't... After 8 hours, you get kind of hard to think. But yeah, I'll fix these compiler errors and then fill in the code here to actually do the request parsing and the response generation, which won't be that hard because I already have lower level modules to do that for me. That's what I did last week. Okay, so I need to raid somebody because it's dinner time. Who am I going to raid though? Who are we following? Are there any other Rust stations currently streaming? Twitch.tv/team/Rust stations. The Primogen is going, but I don't think he's doing Rust. He's doing Vim Deathmatch. Well, so he's someone I could raid. Well, thank you, Cthulhu. And thank you, EWeCall. And thank you also for the help. Okay, I don't know who to raid. Unless it's the Primogen, or maybe Calo Creation, or someone not doing Rust at all, or anything close to it. I think you guys will have fun with the Primogen. I think that's who we're going to raid. He's in Team Rust stations. He once in a while does do Rust, but it's not Rust today. It is Vim Deathmatch. So if you like Vim and you like death matches, I'm sure you're going to love his stream. Let me start this raid. Very funny, entertaining, and smart streamer. He not only knows how to code, but he makes it very entertaining. So I'm sure you'll have a great time in his stream. Hopefully he's going to be streaming for another 24 hours. But we'll see. Anyway, thank you. I'll be back tomorrow, I hope. And take care. See you next time. Bye-bye. Bye-bye. Hitting the button now. Bye. Actually, wait a minute. I can't say bye yet because I need to put his stream on. In other words, I'm going to lose it. Hold on. I need to fix this. Fixing. I need to click on his stream first. Professional streamer here. Okay, and am I going to get an ad? No. Okay, so we're good. See you later. Bye. Bye-bye.